Good morning, all. Please, breakfast is ready. You can have breakfast outside. Breakfast is arranged outside. Please have breakfast.
Announcement for this also Wi-Fi password.
We have Wi-Fi facility. It is pasted outside on notice board with username and password. Please use it.
Screen also.
It is on display.
हाँ जी. Wherever. No. You please sit there. No. Now, first, let me start. Don't worry. Arey, we can change from here. Don't worry. So, good morning, everybody. Hello. Good morning. Professor Bhattacharya. Professor Bhattacharya. Mr. Suresh, please. So it's 9:30 sharp. Good morning to everybody and welcome to IIT Bombay, Department of Civil Engineering. I am DN Singh, your host here, courtesy INAE. And welcome to everybody. And outside the weather is really beautiful at the peak of its, glory, I would say. Yesterday it was a very gloomy day and today is a wonderful day. Courtesy to Pratyusha, who said that when I am in Bombay, you need not to worry. Professor Pratyusha, please raise your hands. So, we are meeting here for a very serious affair, which is to be taken very lightly. Technology Conclave 2025, and under the aegis of INAE, Indian National Academy of Engineering. And today's discussion is on sustainability of civil infrastructure in India. Next. Music बंद कर सकते हो. So, just a brief outline of today's proceedings. You must be realizing from the mails which I have been writing that it's not a conference. It's not a regular presentation type of a meeting. What I'm expecting is that it should be a sort of a brainstorming session, and we have to contribute all throughout the proceedings entire day, and that's why the name is brainstorm. Next, just to give you a quick idea about TC 2025 at a glance. Yes, please. INA is the one who has organized this event. I am very thankful to them for bringing all of us together today. Next. We are going to have a lot of deliberations and interactions today. And these interactive sessions are going to be two-way. Your thoughts are always welcome, impromptu. Please introduce yourself before you speak. That would be better. Next. Your cooperation for timely completion of the proceedings is really appreciated and solicited. Next. At about 10:45, you'll get a cup of tea over here. We are not dispersing out to save time and to maintain the continuity and the rhythm of the meeting. Next. Please do not forget to send your views through WhatsApp or emails after attending this session. Next. Just to give you some statistics, we got about 172 responses from all over the country, I would say. And the major themes of this today's discussion have been smart cities, waste management, sustainability in civil infrastructure, circular economy, strategic projects, sustainable construction materials, and policy. So we had a pretty wide spectrum of the inputs from the stakeholders. Next. And this is to be moderated by my senior colleagues who are here from INAE, and I request all of you to participate and contribute to this event. Thank you very much. I will now request, yes, please, President INAE, Mr. Patil, to speak on behalf of the INAE few words. Welcome to everybody.
Good morning, everyone. Thank you, Professor Singh. I must tell you all that this is the first ever technology conclave, and I'm a student of the same institute. So I said, why not we start with IIT Bombay? So 2 years back, rather 1 year back, we decided we are going to create a new format of one of the flagship program. We've been having 4 every year. So this is the 5th program INAE has added, which we'll keep conducting every year. As all of you possibly know, or many of you possibly know, INAE used to be government funded till 2024. That was the last financial year. And government announced in 2022 that you should be on your own. And the way it was seen by INAE top management at that point in time was, there's an opportunity to stand on our own feet and absolutely be in a position to truthfully speak what is right, rather than being government funded and toe a government line. And this is exactly what was started as a sort of a momentum, and it really picked up well. So I'm happy to tell you that when I took over as presidency this January, by March we had built, in a way, call it a sustainability for INAE, and as part of that, we said we will have people of all walks of life in the technology conclave, because most of the events that INAE does is normally for our fellowship, people who come from that level of achievements in engineering. But there's a forum we need to create who can be little more, I would say, by wider cross section, including the membership that INAE started, And membership, obviously, every engineer virtually 10 years who's done a professional work can actually join as a member. So there's that kind of a cross section we'll start looking at, but let's start. And the start happens to be today at IIT Bombay. We have multiple forums of discussion in INAE, and the forum specific to the subject of civil infrastructure is chaired by Professor Prem Krishna. And I must say that of all the forums that INAE runs, which are similar kind of thought processes, people who keep wanting to come together, keep discussing things, create a specific kind of a futuristic documentation which then can go to government for the purpose of action. All these forums, the most active forum is the Civil Infrastructure Forum. And the work that they began, and this probably is the fourth or the fifth work of that nature that Professor Prem Krishna's team has been leading, I had an opportunity to sit through for a whole day a couple of months back. And what I realized is these kind of initiatives on sustainability which are being discussed here, not many people are thinking in this direction. And it just so happened that through INAE, this was sent through the Council of Academy of all engineering and sciences across the world. There are 33 such academies across the world, and they sought these kind of reports from 10 countries. And I'm happy to tell you on behalf of Professor Prem Krishna that the India's report turned out to be the best. And this is the reason we said, before we in a way call it absolutely formalize the report, there's a format of all kind of no holds barred discussion with only one I would say caution: we are all recorded, so only the parliamentary language. So as long as we do that, punch all kind of holes, whatever is to be spoken, speak your mind. The whole day is there for that, and that's the reason Professor Singh said, "आपको चाय के लिए भी नहीं छोड़ेंगे, यहीं बैठो, यहीं बात करो." So Chatlam House rules. Nothing goes out of the room.
Define the concept of chai pe charcha.
So all within the room, and we will not allocate who said what, but will pick up the right kind of inputs that need to be sort of taken on board. I think with that suffices to welcome all of you. I noticed people have come literally. I met a lady who came from Meghalaya yesterday.
Yeah, she's right behind you.
Behind me, yeah. So people have taken pains to come from long distances, and this is an amazing cross-section of professionals in the domain. And of course, other walks of life beyond the profession. And it would be INAE's privilege to be with you for the whole day. And as I said, collate the right kind of inputs which we can utilize to advise the government what requires to be done. Thank you so much. Jai Hind.
Thank you. Thank you very much. I will now request Mr. Unmesh Wagh, who is the chairman of JNPA, Jawaharlal Nehru Port. What do you call it? A for? Authority. Earlier it used to be JNPT. Mr. Wagh, please.
Before I start, how much time I have? Because you said you have to be in time.
3 minutes to 7 minutes.
Okay. My dear friend, Professor D.N. Singh, Shri Patil, Dr. I came here, I wanted to be here for a full day, but there is one program when on 4th Honorable Prime Minister of India and Honorable Prime Minister of Singapore, they are inaugurating one big structure, that is the fourth terminal in JNPA. So I am little tied up, so I requested that I will be here in the morning session, and if professor allow me some more time, 5 to 10 minutes, then I have a very short presentation because I have read the agenda
Please go
and the sustainability is the theme.
Please go ahead. We'll adjust it later in the half of the day. Yeah, please.
So I just all of you very senior people, Dr. Prem Krishna, he spent a lot of time in this particular area. He was ex president of INAE. Mr. Patil, the president, is here, and all the senior people who worked in the civil sector throughout their life. I just want to spell out some of my concern or some of my wish list, because I happen to be at the place where the biggest infrastructure ever built in marine sector, which we are doing in Vadhavan. And during that journey, in government you are transferred quite often. I am lucky that since last 5.5 years, I am driving this project. So from conceptualization to design, change in design, all the clearances, award of tender, and then start of construction. All things were done when I am a chairman or deputy chairman of that institute. So there are two things. One most important, if something goes wrong, I am responsible. So I cannot say I have not designed, I have not given tender, or I have not started the construction. And another thing, it gives a total control over all the aspect, because it is under one command, everything has been done. This is rare in government. This is a rare opportunity for me also. And this project is not a small project. It is a $10 billion project. It is the highest investment in port sector. Once this particular project has been completed, this port will be one of the top 10 port of world. At present, we figure 25th and 26th. Another aspect, when I was designing this project, then I realized in India, we are not much into this kind of business. Marine construction is something which we are mostly dependent on other nations, and we are just not copying but taking the technology from them and utilizing here. When we started with the design, that time when we hired the consultant, we got all the foreign consultant only, because none of our consultant qualified. So Royal Hoscon Inn is our consultant for designing. When we designed this project and now going on to the construction, I will just go through the project so that when I talk, you will have better idea. I will take 2 to 3 minutes to explain this project. Next. Yeah. So this will give you some perspective. This is the port. This is complete offshore port. This is a near shore construction of 194 hectares. Then these are the trestles, and then 1200 hectares of this port, that is the complete port. This is S-shaped 10.14 kilometer breakwater. This green one is our highway, that is 248S National Highway, connecting port to the existing Ahmedabad highway at Tawa, and this is 32 kilometers, and at 22 kilometers it is connecting to the Mumbai-Delhi expressway, and this is where the DFC 12 kilometers where railway line will connect. The one important aspect, because this project has gone through many oppositions and it was pending since 1991. So what we did to take care of all the issues, we said we are not going to acquire 1 inch of land for this project. So it is completely offshore, except this 600 hectares of land for road. We don't require any land, and that land is acquired by NHI, so it is not a port land. Now, in engineering, in civil engineering, one thing is all the projects in India, I mean, Dr. Prem Krishna and JD Patil will tell you more about this because they have more experience, and we have Mr. Manish from ITD Cementation also, who did a lot of project. These and Professor himself, that, and yes, actually, yeah. So the experience is that most of the projects always taken extra time for the completion, and in this project we are at present 6 months in advance of our timeline, and we want to complete this project before time. So how it is possible? The important aspect for any project, one is a legal aspect. So we have taken all the clearances, comprehensive environmental clearances, including railroad. Another aspect is the cost overshoot and time overshoot because of one important reason, that is availability of raw material. In this particular project, you might have figured in, there are 4 raw materials are required. Cement still abundantly available, you don't have to worry about that. Then sand for the reclamation, that is one, and second, the stone. So what we did, we already identified sand at offshore in Borrow Pit. We require 200 million cubic meter of sand, and we have here more than 400 million cubic meter of total sand. And we got all the clearances for that. When we applied that time, Government of India, the Ministry of Mines, they realize that this may be another source of income for them. So we are the first to get this license. So we brought this license. The sand, double of the requirement is available. Then you could see this area, the blue one. This is the quarry. So what we did, we identified 100 hectare, did the seismic survey, now boreholes are going on, identified this, and we are giving all the clearance, all cleared mining permission for this area. We require approximately 67 million metric ton of stone, and this has 91 million metric ton. So that also taken care of another raw material. So we made everything available so that there should not be any issue, either legal or availability of raw material. Hence, we are quite sure that we will complete this in time. So this is the project, and next please. Yeah, this is the total area which we are reclaiming. This is the layout. Sorry. This is the layout. It will have 9 container terminals, 4 multi-purpose, 9 container terminals like this. Then these are 4 multi-purpose, 1 ro-ro, 1 we will give to the Coast Guard, and these are 4 liquid terminals. Now, the most critical aspect of this project is this breakwater. When we designed this breakwater, we went by the traditional method, and then because it's a EPC contract, then we just ask what to do, and we just floated this idea globally, and then some of the companies from Korea approached us, and they suggested some other alternative methods for this breakwater. Because this is a gathering of all experts in civil engineering, so I thought just go through them. So this is one concrete caisson breakwater method. The picture will be more clear. I will leave this presentation so that if professor wants,
Yeah, what I'll do is, Mr. Wag, that I'll circulate it to all of them.
so that everyone can have this.
Yes, I think you can wind it up now.
Yeah, I will just one minute I will take.
Sure.
Yeah, just go through it. Yeah, go through. Just click it. So this is the method.
Very nice.
Yeah, another. Yeah, go through it.
Run through it, yes.
This is the way. Then this is another method. Where you can build it. So the only point I want to make it here is this particular sector is untouched by innovation in India. So we must attract more talent in this particular field so that marine sector will be the future, and lot of more ports we require, because in 2000 where China was, today we are there. So China has 10 times more capacity, so we require that many ports in future. So the civil engineering side must concentrate on this particular aspect so that we will benefit by way of saving in cost, and definitely more sustainable structure we can create. Thank you very much.
Thank you very much, Mr. Wag. I'm sure that many of our fraternity and colleagues will like to be associated with this project in the future. Thank you very much for showing the entire project. And now I'll move on to Professor Prem Krishna, please. Just a reminder, please switch off your mobiles because everything is being recorded. We are making a video out of it. So please switch off your mobiles and keep them on the silent mode. Thanks.
Yeah. Well, good morning to all of you. Mr. Patil, our president, Mr. Wag, who has just given us a very exciting view of a mega project, port project. My colleagues on the forum and distinguished participants. My brief with you is to, and my friend DNS has allowed me generously 15 minutes, and I'll finish in 12, I think. And so I'll be brief and give you an overview of how our forum, through its study so far, has been looking at the issue of sustainability as related to civil infrastructure. So that is the purpose of my exposition this morning. Just a few remarks to open the subject. Yeah, that's the one. The need to address the issue of sustainable development, as we all know, has been growing increasingly over the last few decades. Global warming, environmental changes, zero carbon emission are all very commonly heard terms in this respect. And the very well-known 17 goals set out by the UN, which will appear shortly in a slide. That's it. Those are the 17 goals set out by the UN, and they cover the entire picture of sustainable development. If we want to look at sustainable development vis-a-vis civil infrastructure, there are these the goal 9, goal 11 and goal 13 are more directly related. It is not that the other goals are not related at all, but directly 9 and 11 and 13 are the ones that we think are more directly concerned with sustainable development of civil infrastructure. In fact, it's noteworthy that the built environment accounts for approximately half of the global carbon footprint, and therefore it becomes important that we study this particular subject, because it accounts for half the issue, half the problem really of global carbon footprint. Other areas I have mentioned there are the agriculture and the industrial manufacturing and so on and so forth, and there are other issues. The key areas of civil infrastructure, though not exclusive, include transportation, buildings, energy, and irrigation systems, not to forget the ports that we have just been told about, with the first two causing more significant sustainability concerns because of their very volume compared to the rest of the sectors. Well, if one were to look for sustainability in civil infrastructure, there are these several facets. Planning is the first one. Careful selection of materials is extremely important. Design of the structures, and of course, choice of materials, design, they go hand in hand. Construction technology, operational strategies, rehabilitation and reuse that promote environmental benefits throughout the life cycle of the infrastructure. This is depicted graphically in a chain that our forum has designed, and we are calling it the infrastructure sustainability chain. Maybe someday INAE will decide to call it the INAE infrastructure sustainability chain.
With what is happening in the
Case. And you notice the various aspects are listed here, starting from material. I don't know whether we able to. Don't worry. Material, design, construction, use and maintenance. That's the operational part. Repair and rehabilitation, demolition and reuse. That completes the entire cycle. And that's why we've listed these 6 aspects to be addressed in our study that we are making. The study by the INAE Forum on Civil Infrastructure that Mr. Patil mentioned, and mentioned it very kindly. He thought of us as being an active forum. And the INAE Forum on Civil Infrastructure is currently carrying out a study which is attempting a critical appraisal of the different aspects related to the sustainability chain, in a general sense, as well as more specifically in the Indian context, wherein it is also imperative to be aware of the scale of the problem in India as compared to many other countries. Our scale is sometimes, maybe it may work out to be 100 times more than some other countries. So that is something which we have to be very conscious of. The forum is fortunate to have senior level representation from amongst academia, R&D institutes, buildings and transportation, standards organization, and the civil engineering industry. All my colleagues in the forum are heading their own organizations, and I am really grateful that they have found the time for this study and are all here today with us. I am the only one who is unemployed in this forum. As mentioned here, the study is attempting to assess the current level of implementation also, which we believe is limited so far, and then to identify the way forward. While it is realized that the economic and environmental benefits of achieving sustainability are promising, challenges such as lack of awareness, misconceptions, higher initial costs, and the absence of adequate coverage by standardization, and very important to me, I think, policy regulations, and even more importantly, their implementation. We are good at laying out policies, but I don't know whether we are all that good at implementing them. So I think I should have written here also the implementation of those policies is very important to us. The study currently, we have been at it for about a couple of years, and it's in a pre-final stage, and this is the stage at which we thought if we can get some more ideas and inputs from an event like this, that will be wonderful in improving the quality of the document that we bring out. And the presentations that will come on the basis of this study are listed here. Infrastructure demand and sustainable habitat, environmental impact and life cycle cost analysis, sustainable construction materials and educational initiatives, sustainable design and construction practices, mainstreaming sustainability policies and standardization. The order has changed a little bit. I think I think sustainable construction materials and educational initiatives will come after the infrastructure demand presentation. Did I miss it? Yeah. And as Mr. Patil has also mentioned, it is really very fortunate that we are having this conclave today, which is addressing the subject of sustainability. And many invited experts, Mr. Wagh has just spoken, will be sharing their thoughts and experiences related to sustainable development, thus widening the scope of deliberations today. So we are very fortunate to be having this event today. The interest evoked by conclave is most encouraging. Professor D.N. Singh has already given data to you, so I need not go over this again. We can go to the next slide. Next slide, please. Yeah. So it is, on behalf of the forum, I'll say, it is an earnest expectation that the interaction with the participants, with their wide and extensive experience, will enable the INAE study to be made richer in content and more effective, inasmuch as the profession can get pragmatic ideas towards sustainable development. It is also an expectation that all stakeholders who are represented here, academia, R&D systems, standards institutions, policymakers, design and construction industry, will carry some positive takeaways from the interaction today and work jointly towards furthering the cause of sustainability. Thank you very much for your patience.
Thank you, Professor Prem Krishna, for giving us a broad outline of today's deliberations and the main focus of this activity. May I request now all the delegates and the participants to introduce themselves. Mr. Jain onwards, first on the left-hand side and on the right-hand side will come. And then followed by the second row. Mr. Jain, please.
Yeah, I'm Ajit
So
Kumar.
what I expect is that your name and your affiliation and your expertise as quickly as possible.
Okay. I'm Ajit Kumar Jain. I'm Chairman and Managing Director, Environment Research Foundation. We are working into the areas of sustainability, but focus on EIA and social impact assessment studies for various projects, also into ESG and GHG audit. And of course, our core area is waste management. I have been in the government and retired as the Additional Chief Secretary in the government of Maharashtra. Thank you.
Good morning all. My name is R. Pradeep Kumar and I'm Director CSIR CBRI, and my CSIR CBRI works in almost all the areas of buildings, and my own specialization is earthquake engineering, structural engineering and disaster management.
Hello, good morning everyone. This is S.K. Bhattacharya, former professor and deputy director of IIT Kharagpur, and currently I am the founding vice chancellor of Shivnadar University, Chennai, and the former director of Central Building Research Institute at Roorkee as well. Well, as a member of the forum of INAE's infrastructure group, and we are working on the issues on the sustainability of infrastructure, and in time to come we'll make some presentations on that as well. Thank you.
Hello everyone, this is Professor Mahendra Kumar Madhavan, Department of Civil Engineering, IIT Hyderabad. I'm a faculty in structural engineering with focusing on sustainable infrastructure through sustainable steel structures. Thank you.
Good morning everyone. I am Professor Manoranjan Parida, Director CSR Central Road Research Institute. I am also a professor at IIT Roorkee and formerly Deputy Director IIT Roorkee. So my institute works on the road related projects. In fact, Chairman JNPA mentioned about the need of stones, aggregates. So we have actually transferred technologies to AMNS, to Tata Steel, and working with JSW Steel to process their steel slag for manufacturing the aggregates, process aggregates, which has been used for road construction, Mumbai to Goa that has been used, and also trying to develop alternatives to bitumen from agro waste, how to have bio-bitumen. I'll be sharing some of the details in my presentation. Thank you.
So, Waksab, actually, this is a very good idea. We can take help from CRRI as far as the alternate construction materials are concerned, particularly the industrial waste. There was a mission which INAE was also championing. I think let's work together on Vadwan, and in the port areas there are a lot of industries, and this material can be very easily utilized as a man-made resource. This is what Professor Parida is talking about. I think this we can take forward.
Actually, sir, from Surat they can be sourced. That could be a possibility.
Yeah.
Because we constructed a road in Hazira port area,
That's right.
so exactly adjoining sea. So we can explore that. Thank you.
Thank you.
Good morning to everybody. My name is V. Suresh, former CMD of HUDCO and also Chairman of the National Building Code of India, various versions including the latest one, 2025, which is just been finalized now. Sustainability is a very major component which has been added after the 2015 SDG 2030 was formed. NBC contains the part 11 on approach to sustainability, and what is good is in the 2025 version we have taken it forward to in the context of net zero carbon vision of various countries, 50, 2060 and we are 2070, where embodied energy component is been brought in addition a very large way on the type of energy for all the building materials and how do we take care, in addition to operational energy, which in any case we are dealing on sustainability. Out of the 17 goals, the building code covers exactly 8 of the goals which is covered in the building code provision in a large way. We'll have opportunity to make a presentation a little later. Thank you.
Thank you.
Good morning. I'm Anand Sirohi. I represent the industry. I work for Trimble, which is an American company, and I'm happy to say that I've been part of making some transformative changes in the digital construction industry. The Ministry of Road Transport and Highways has adopted on 23rd of June the machine automated construction, which covers all the facets of road construction. We have worked closely with ITD Cementation on the Adani port for the armored rocks placement, so that, precision placement, because Trimble started with the precision positioning. Most of the people know us with the survey equipments, but we use the precision positioning and the hydraulic controlling of the construction machinery, so that the construction happens as per the design. So a fusion of a 3D model and the live construction. So happy to learn from this forum. I would also say that the next initiative that we have taken with Ministry and NHAI is around the improvement of the DPR quality, because on 25th there was a session which was organized in IIC, and we saw that how much is the need of the data-driven, alignment planning, optimization, and then comes the detailed survey, and then accordingly the DPR planning. So I have found a lot of gaps, and we are trying to work on that. Thank you so much.
Just a reminder, please switch off your mobiles, because everything is being recorded, and then editing becomes very difficult. Alpa, please.
Hi, good morning, everybody. My name is Alpa Sheth, and I'm an INAE fellow, and I represent the structural engineering practice industry. I run BMS Consultants Private Limited. I also am a founding trustee of the Structural Engineering Forum of India. And the reason I'm saying that is it's a very important group. If we want to bring about change in this country, we have 27,000 structural engineers who are subscribers to this this forum that we have, and implementing change, it would be a very good avenue to kind of tap into. I also chair the Bureau of Indian Standards CD 38, which is for special structures. And I think that there is a sensitivity and a sensibility, and I think as what Dr. Suresh has said, that the Bureau of Indian Standards is also going towards trying to bring in a more sustainable kind of attitude towards all of the new codes and the NBC. So I think this is a good kickstart, and my dear friend Professor D.N. Singh has initiated it, and I really appreciate that. Thank you.
Thank you very much. Yes, please. Dr. Roy? You can just speak, because mics can catch your voice.
I am Dr. B.C. Roy, the National Academy Fellow and member of Professor Singh's forum team. I have coming to Mumbai for the last 40 years, and I am very happy to say that I have the maximum number of projects in Mumbai, and primarily on transport infrastructure plus buildings. I have also the former visiting professor of IIT Bombay, and I shall be happy to participate in the brainstorming session, but I am not sure how much brain I have left in my skull. Anyway, thank you very much.
Thank you.
My name is Nori. I am chairman of Shirish Patel and Associates Consulting Engineers. We are one of the oldest consulting firms still trying to survive. Thank you, Dr. Singh, for inviting us.
Thanks for coming.
No, whenever there is time, I have already shared my views in form of slides. Sure. Whenever Dr. Singh gives the time, I'll do that. Thank you so much.
Thank you very much.
Okay. Good morning, everybody. I am Tushar Bandopadhyay, Technical Director of Indian Center for Plastics in the Environment, ICPE. We work on use of plastics on the environmental. We take care of the all aspects. Major work done by this organization in India was the first institute for making the co-processing of plastics in cement clean, making 100% of all types of plastics, including the thermosets, for its energy utilization in the positive way. Whatever cannot be otherwise recycled can be co-processed, and as per the international rule, and after all getting the approval of the CPCB. And one of the first use of plastics in the bitumen road construction. Although we worked before the Indian Road Congress had come out with the standard, but still only the other week, 3 weeks back, there was a question and answer in the parliament. Although there are standards approved by the India Road Congress, out of the 4.5 lakh rural roads, less than 50,000 roads have so far been bituminized using plastic waste. But this is a tremendous good process. There is a long gap. There is benefits are there. The roads can be more sustainable, at least 5 times more.
Correct.
Only one community, I was discussing with some other colleague, only one community will be not benefited. There is a contractor benefiting.
It's okay, I think we'll discuss all this now later.
So that
we have to stick to name and affiliation and maybe 1 or 2 keywords about your expertise. Thank you very much. Yes, please go ahead.
Namaskar to all. Myself, Charu Chandra Korde. I am a faculty at IIT Bombay, and I work in the area of using bamboo for green and sustainable infrastructure. And you all as a forum would be happy to know that the Ministry of Agriculture has given a center of excellence in bamboo research, which we are, I'm heading that. And with around 12 faculty colleagues, we are doing research into using this as a carbon negative material into construction and demonstrating negative carbon footprint construction. Thank you.
Can you just send one link so that I can circulate to all of them? They can have a look at what your initiatives are. That would be much better.
Right, sir.
Thank you.
Thank you.
Good morning to you all. I am Professor Hanumant Rao. I am a faculty member in Geotechnical Department at Civil Engineering, IIT Bhubaneswar. So I'm also I work in the area of valorization of the tailings and industrial waste byproducts, and I'm also will be glad to share. Recently, we have developed one artificial sand as an alternate material for the river sand. We have filed patent also. I'll be happy to share all the details with chairman of the JNPA. So it can really work on as an alternative substitute to river sand.
Yeah,
So
this is a very interesting initiative. All this industrial waste can be converted into sand and then can be utilized for making big infrastructures.
Yeah.
Professor Das.
Thank you. Good morning, everyone. And first of all, I would like to thank Professor Singh. So, I am a professor at National Institute of Technology, Karnataka, Surathkal, and I am into the construction management division. So I work in the construction planning, but more research towards the sustainable materials actually. So major goal is to make it net zero. That is the major goal actually. So we have done so many research into the industrial byproducts to the coarse aggregate production, and we also have got several patents into the through pelletization. How can you do actually? Then another part I work into the 3D concrete printing. So where we can go literally the faster construction, and by adopting so many like industrial byproducts, and can plan through the like technology where we can make it really a significant advancement for the society actually. Thank you.
Good morning everyone. I am Colonel Atul from INAE. On behalf of INAE, I welcome you all for a meaningful conversation today. Thank you.
Thank you. Raisa.
Good morning. I am Colonel Rai from INAE again, and I manage affairs on behalf of the INAE leadership at INAE. Thank you.
Subodh.
Good morning. I am Subodh Awad, General Manager Business Development and Operations for Vadhavan Port, deputed as officer on special duty to Chairman JNPA as well as Chairman Vadhavan Port.
Thank you. Mr. Manish Kumar, onwards please.
Yeah, my name is Manish Kumar. I'm working as Executive Vice President and Chief Technical Officer with ITD Cementation India Limited. And we are basically into infrastructure and industrial construction. So we are from the construction segment of the industry. We are always looking, I'm basically a geotechnical engineer, but currently my role is also to look for sustainable solutions for construction. So not only the material, but we are also looking for the technologies which are different and more sustainable in the long run. Over the years, we have been involved with introducing quite a few technologies in India. And currently we are working on things like CFA piles, helical piles. And one of the more important things what Mr. Wagh was mentioning, we have put a team who is working on study of this breakwater, because being involved with the Vijayam and Varsha, some of the projects where the consumption of stone was very large, we took the cue from Mr. Wagh's suggestion, and we have formed a team, and we are working with some experts from overseas also, looking for alternate solutions which are more sustainable. Thank you.
Thank you. Indrani.
Good morning. I'm Indrani Malkani. I'm Chairman Trustee of a social service organization, We Citizens Action Network. Perhaps the only one who is non-technical in that sense. So I will be bringing in a very different perspective. My organization and I work in partnership with the government and various other organs of the government in the field of bringing civil society and government engagement in a positive light by partnering and finding solutions and working in the space of public policy. In this connection, as I have understood, I would, when details are being discussed, most of the things are interconnected and interdependent. And I think that's the perspective that I'll be bringing to the discussions today. Equally, circular economy, waste management, all connected. And I would also like to share, Mr. Jain is there, with whom I have worked for many decades now, our Brihan Mumbai Municipal Corporation, an excellent innovation that took place with the municipality in the form of construction material that is waste made into bricks. Later, I will discuss this. Thank you very much for inviting me, Professor
Thank you.
Singh.
Next, please.
Yeah.
Yeah.
Yeah, I'm V.N. Hegade, a former Executive Director of Gammon and also the former Chief Executive Officer of Stoop Consultants Private Limited. And I have been involved in the sustainability cause since 20 years now, but I'm very happy now it's been picking up the momentum now. Like I've been writing papers since 20 years on the sustainability as well as the aesthetics. As far as the sustainability is concerned, I have brought out two guidelines, sustainability-oriented guidelines on behalf of the Indian Roads Congress. One is the guidelines on reduction in carbon footprint for steel bridges, and also the project preparation manual for special bridges. It emphasizes on the sustainability so that the DPR can be written to orient the procurement processes in the direction of the sustainability. I'm also involved very actively in the special assignment group of sustainability of FIB, that is the Federation International Beton. And I'm looking forward to make a presentation on environmental impact as well as the life cycle cost in this particular forum. Thank you very much.
Thank you. Alok ji. Yeah.
Good morning all. My name is Alok Bhaumik. I'm the founder of an organization called B&S Engineering Consultants. I'm primarily working, I'm a structural engineer and a professional, engineer, fellow of National Academy of Engineering, and I'm a member of this infrastructure group coming out with this. I'm also president of Indian Association of Structural Engineers. Thank you.
Thank you. Professor Sikdar, please.
Good morning. I'm a former colleague of Professor D.N. Singh. I was a professor here in Civil Engineering Department in Transportation area. I was former director of Central Road Research Institute as well. Worked in consultancy multinational for about 2 decades. And now I am advisor to International Road Federation, India chapter, working on this sustainability problem or the report we are preparing for INAE. Thank you.
Thank you.
मेरे भी former colleague हो.
Ah, yes.
Good morning. I am Dilip Shekdar. I am representing Mumbai Port, a 153-year-old port of India. And I was also a chief architect planner of CIDCO. Presently, we are revamping the entire port area and particularly concentrating on the water transport and other infrastructure for the development of the port and looking for the various solutions in the implementation of the infrastructure from this forum. Thank you.
Thank you.
Good morning, everyone. My name is Madhu Ganesh. I am a recently retired professor in mechanical engineering from Karunya University in Coimbatore. The last 10 years I've been working on waste to energy conversion, and recently, about 3 months back, I completed a Department of Science and Technology project on plastic to energy conversion by gasification. It's a 2 tons per day plant, which is functional at Karunya University in Coimbatore. I'm looking forward to the deliberations on plastic management sustainability at this forum. Thank you.
Thank you.
Good morning to all. Myself, Mohammad Arif. I'm a geotechnical consultant operating from Mumbai.
Thank you.
Good morning, all of you. Myself, Sauravyas, representing geosynthetic industry and TechFab India Industries Limited. We are a leading manufacturer, and at company level, we are also doing some environmental production declaration certifications for the various application areas related to geosynthetic. Thank you.
Thank you.
Good morning to all. Myself, Vishal Kaushik. I am working as a DGM Civil in NTPC Coal Dam Hydroelectric Project at Himachal Pradesh. And I am looking forward to learn from the various eminent personalities of this forum as diversifying in civil technologies. Thank you.
Thank you.
Good morning all. Good morning all. My name is Prashant Gajbhi. I am working in AECOM India, and we are in structural infrastructure designs of various infrastructure design projects like highway projects, buildings, railway projects. We are more focused in reducing the carbon footprints and producing the sustainable infrastructure designs. Thank you all.
Thank you.
Good morning. My name is Purav Shah. I'm a director and promoter of a company called Ruby Mills based out of Bombay. We are into textile manufacturing and also a little bit of real estate development. So at the forum, I'm looking at uses of all the different technologies into our operations.
Thank you.
Good morning. I'm Sandeep Goswami. I'm a climate science and policy professional. I studied from the World Bank Institute, Tokyo, and I'm also an alumni of TERI in Sustainable Building Designs. We have a unique tool called CAS for which we can predict climate change, and I'm probably the only person on a private forum where we have our own satellites. We can zoom down on any given location from 300 kilometers square to 10 meters square, go down 200 feet under the ground and tell you what can happen there from now to 50 years in the future, and then give you the exact disaster risk mitigation plan, so that, and which is wrapped in sustainability. I have been fortunate to be part of the stakeholder meetings of National Action Plan for Climate Change as well as the Sustainable Development Goals when it was being formed. Thank you so much.
Thank you. Yes, please, Yash.
So, good morning, everyone. I am Yash Sarane, first year research scholar under the guidance of Professor Singh sir, and I am working on the topic of carbon capture, utilization and storage. Thank you.
Yeah, hello. Good morning, everyone. I am Dr. Prithven Singh. I work with GRP Limited. So we focus on recycling of waste rubber tires, and we make various products from waste rubber. Thank you very much, and feel free to interact with me later.
Mr. Moitra. Oh, no, please be seated. Mr. Moitra, please be seated.
Good morning. My name is Shantanu Moitra. I'm a geotechnical engineer. I have worked as managing director of Fugro. Almost every major infrastructure project I have been associated with in the last 40 years. And my current interest is a little bit on the landslides in the hills, the sustainable development of the hills that we have in northern India. And I'm very happy to be in this August gathering and gather as much knowledge as possible. Thank you.
Thank you.
Good morning all. I'm Fakira Rashid. I'm a fourth year PhD research scholar working here at IIT Bombay. I work in the field of energy transition, and I focus on geothermal energy and how it can be extracted from oil and gas wells that are exhausted. So in order to increase their longevity. Thank you.
Good morning. I am Ashok Mari. I am retired from BMC, Bombay Municipal Corporation.
He is the one who was leading GMLR project, very important project which city is going to have. Mr. Mali, you should speak one line about your project. You can't say that you are retired, so please, please speak out. Introduction to the project.
Goregaon Mulund Road project is the first time we have approached solution because it is crossing the national park. Both side the road is has to be connected through national park. We have adopted TBM technology to construct the tunnel, and it will be we are expected it will be completed by 2028.
Thank you.
Thank you.
Thank you.
My name is Ajmal Babu. I'm a PhD student in structural engineering at IIT Bombay.
Thank you.
Hi everyone, I'm Zabiullah Pargi and I'm a civil engineer at GES Mumbai.
Hello, good morning. My name is Mirza Beg. I represent industry. I'm from VH Group, popularly known as Vankies. We have been working on an invention from 2011 and we have been able to decompose the plastic. I would be giving my presentation.
Thank you. Yeah, speak out. Please introduce yourself. Yeah.
Hello, good morning. Myself Mukesh Ramteke. I am the public relation assistant at Vadwan Port.
Okay.
Hello everyone. My name is Dr. Surinder Singh. I am a postdoctoral fellow at IIT Bombay. So I am working on the waste valorization and creation of man-made soil from different waste, whether it is waste to energy waste, municipal solid waste, mine tailings, industrial byproducts. So looking forward to learn from all of the colleagues present here. Thank you very much.
Good morning, everyone. My name is Najib Sharif. I'm a faculty member in the Department of Civil Engineering with emphasis on structural engineering. And my focus is mainly on the long-term performance of sustainable materials.
Thank you.
Good morning, everyone. I am Rohit Kumar, BTech 4th year student at IIT Bombay in Civil Engineering. So I'm working on energy transition, more focused on how to extract methane gas hydrates and use it as an energy source. Thanks.
Thank you.
Good morning all. Myself Pratima. I am a first year PhD research scholar from geotechnical specialization at IIT Bombay. My research work focuses on valorization of biosolids from STPs.
And one more thing which I have to add here, she is the main organizer of the entire event. Pratima.
Thank you.
Good morning. My name is Rajan Sharma. I am a PhD from IIT Bombay from Center for Environment Science and Engineering way back in 1994. Currently working as VP and Head Corporate EHS and Sustainability with Glenmark Pharmaceuticals. I am here to learn how civil engineers are looking at the sustainability. And thank you, Dr. Singh, for inviting me.
Thank you.
Good morning, everyone. I am Suhan Raghuvanshi, final year student in the Department of Civil Engineering, IIT Bombay, and I am working on valorization of industrial byproducts. Thank you. Looking forward for a critical discussion today.
Thanks.
Good morning all. My name is Mrunal Bokkade. I am 4th year PhD scholar at IIT Bombay. I work on valorization of municipal solid waste and industrial byproducts to create man-made soils and man-made aggregates.
looking forward to learn from you all. Thank you.
Vaksab is the one who was doing the technology demonstration at MBPT and 4th Container Terminal at JNPA. Mrinal Bokade. Yes.
Hello everyone, I am Manish Dubey. I represent K. Rai Jacob. Currently I am working as Vice President for MEP Services of the Residential Vertical.
Thank you.
Good morning, everybody. My name is Anubhav Kumar. I'm a second year student at IIT Madras, and currently I'm interning as a data analyst at KPMG, and I like finding ways to integrate AI and data science into sustainability.
Thank you.
Good morning all. My name is Dr. Indrajit Khatri. I am an alumni of IIT Bombay itself, and I did my doctorate in environmental science and engineering. Currently, I am working as a sustainability analyst in UPL, which we are manufacturing in agrochemicals and specialty chemicals. Thank you.
Thank you very much.
Hi, good morning all. My name is Anand. I represent Normet India. Normet is a Finland-based organization who are world leaders in underground tunneling, mining and infrastructure solutions. We not only develop sustainable materials, we also have complete package solutions for underground construction and tunnel construction, which is a upcoming booming sector in India. Thank you.
Thank you.
Good morning, everyone. I am Abhishek Rajput. I'm Associate Professor in Civil Engineering at IIT Indore. So recently our group is focusing on the development of alternative material of cement to making the concrete. So recently we have developed cement-free concrete, which is based on geopolymer technique. And right now we are looking for the technology transfer. So a lot of big companies from India are in the touch. So hope to transfer the technology very soon. And today we can discuss those things. Yeah.
So Professor Abhishek, you forgot to tell about your invention on bulletproof jackets. Just one line.
Yeah. So like my research is also focused towards the ballistic response of construction materials as well as the development of armor. So we have also developed an indigenous bulletproof jacket. We have done some of the testing in Mahu range with the assault weapons. So in that we have got more than 95% success, and I hope to be completed within 3-4 months, up to the 99 or 100%. Yeah, thank you.
Right, sir, you should be talking to him.
Good morning, everybody. Myself, Sri Hari Priya. I'm currently pursuing my second year MTech in structural engineering, and I'm currently working on the life cycle cost analysis of the PSE and structural steel eye-girder highway bridges.
Thank you.
Good morning, everyone. I'm Dr. Pratyesha, Assistant Professor at the Department of Civil Engineering, IIT Andhra Pradesh, and alumni of IIT Bombay. My research area mostly concentrates on soil stabilization and soil remediation using sustainable materials as well as technology.
And she is the one who is holding the rains today. She promised yesterday evening that there will not be any rains tomorrow morning, and that's what is happening. Thank you very much. Yes, please. Next.
Good morning, everyone. I am Dr. Sushmita Sharma. I am an assistant professor in IIT Meghalaya. So I come from the farthest place, I think. And I am an alumni of IIT Bombay. And my research area mostly focuses on soil remediation and also calcite precipitation in soils. And currently, the topic that I want to get your useful advice is on construction and demolition waste. In Meghalaya, there is a scarcity, the policy exists, but we wanted to find out more into going to deep into the construction management waste in the region. Thank you.
One more thing about her, Dr. Sushmita, she was associated with Powai Lake cleanup and Warsaw Lagoon cleanup, which are the biosediments, very typical and very, very critical topics. Next.
Yeah. Good morning, everyone. I am Gitanjali Lohar. So I am a postdoctoral fellow at IIT Bombay. I work in the area of tunneling and underground space utilization.
And she is helping GMLR project, this Goregaon Mulund Link Road. Yes, please. Professor Kant.
My name is Tarun Kant and I'm a professor emeritus here in IIT Bombay, and well, environment is very close to my heart, so that is why I have come to attend this. Thank you.
Yeah.
Professor Tarun Kant created this hall when he was the Dean IPS. So,
good morning, everyone. My name is Dr. Pankaj Pathak, Associate Professor in Department of Environmental Science, SRM University, Andhra Pradesh. My research is on waste management, most particularly in e-waste management, where I'm recovering and recycling metals, critical and rare earth metals from e-waste, and the plastic waste management, where we do the degradation of the plastic and making the resourceful material from the degraded waste. In addition to this, we are also focusing on the techno-economic analysis as well as life cycle assessment of this secondary resource material. Thank you.
Thank you very much. Next, please.
Good morning, everyone. My name is Ritika. I am third year PhD student at IIT Bombay, working under the guidance of Professor Solomon Devarma. My research area is utilization of flexible payment waste in concrete payment. Thank you.
Thank you.
Good morning all. I am Anusha Toshikhani, third year PhD student from Transportation Engineering Department. So from IIT Bombay. I work on internal curing in concrete payments to reduce the curing period of the concrete payments.
Good morning, everyone. This is Sarat Pandey. I am second year MTech student in IIT Bombay, and currently I am working on carbon capture and storage in alkaline industrial byproducts such as red mud, and trying to see if this can be a feasible option for carbonation or mineralization and as an optional material for soils and geomaterials. Thank you.
Thank you.
Hello everyone. With VH Group to demonstrate the plastic decomposition technology. Thank you.
Good morning everyone. We are representing the VH Group. My name is Swati Kumar Chaturvedi. Thank you.
Thank you.
Thank you. This is Sanjay Mohite. I am working in this solid waste management sector from last 20 years, BE Civil, and I did MS from Germany, from Technical University Munich in sustainable resource management. And I have delivered many landmark projects in India. One is the first bioreactor landfill of India in Kanjurmarg, Mumbai. Then first sanitary landfill at Delhi, at Okhla. Then further, I have also delivered first waste to energy project on EPC and O&M. Earlier projects were on DBO or PPP projects. So Devnar project, that also. So I am consultant, and further I am also working on various sanitary landfill projects, cluster basis at Kerala and Tamil Nadu. And further also I am integrating with France and Japanese technology providers for waste to hydrogen. Thank you.
Thank you very much. Next, please.
Namaskar, this is Shashank from Bombay Municipal Corporation, Deputy Commissioner. I'm heading 8 departments. Now, since all our esteemed, learned and experienced all persons, there are 2-3, you can say, food for you all for intelligence. First point I just want to discuss with, not discuss, but put up for the agenda as per the time permits. First, that this Mumbai has MSDP, Mumbai Sewerage Disposal Project. Now this will be commencing in 2026 and will be BMC generating more than 500 tons of sludge. If BMC can get some solution, this is point number 1. Point number 2, as some different delegates had mentioned about plastic recycle. So we have more than 6,000 tons of waste every day generated, and plastic, if we can get some good solution, that will be very, very fantastic. Third is, I just want to mention about some this thing, cow dungs, some mention about cow dung. Now we are facing a lot of issues from cow dung getting deposited in the Hisar River and Poisar River. And it is causing all this river completely. So something can be done, certainly it will be welcome. And sir, I mentioned about Powai. We had last meeting with Personal Secretary to Chief Minister Sri Fadnavis sir, Mr. Srikar Pardeshi conducted, and then different, I can say, came from Powai and IIT. We are in that Powai purification also. It should be a wonderful lake for all. So these 4 areas I'm focusing. I just get some solution. I will be very, very happy. And also thanks Professor Singh, Dr. Singh. In 1890, he helped us BMC to reconstruct retaining wall and Pedder Road. Extremely grateful in the COVID areas. So it was very nice contribution from sir. Thank you, sir, for inviting. Have a good day for all of you.
Good morning. I am Ritunjay Chaube. I did my PhD from IIT Delhi, and presently I am Global Vice President and Chief Sustainability Officer of UPL Limited. UPL is the 4th largest agrochemical in the world, and we have more than 60-70 operating plants around the world. So presently we are working on decarbonization. So recently we have set science-based target to decarbonize entire UPL by 2040. And I want to share my view with this forum that not only UPL, in industry, we are facing 2 issues right now. One is that how to decarbonize. In that, scope 3 emission is one of the challenges, that how to decrease the scope 3 emission. And the second challenge is how to achieve zero landfill waste to the landfill. And that we have taken target at UPL that by 2040, we will decarbonize entire our organization and we will achieve zero waste to landfill. But I think that is challenge also where we are discussing and working with a lot of group and people.
Thank you very much. Sri sir.
Yeah, good morning to all. I am Sri Harsha. I have 16 years of experience in waste management. Currently, I am associated with Anthony Group, working at Kanjunmarg Processing Facility. So currently we are handling 6,000 tons of Mumbai waste, which is approximately 90% of total generation. We are right from collection and transportation of waste, processing and disposal, where we have implemented several technologies which include material recovery facility, aerobic composting, captive power plant from landfill gas and waste to energy. Further, we are exploring new technologies and we are working on it. And I would like to thank Professor.
Don't thank me. Just talk about 1 minute Thana project, your waste disposal facility. It's a unique model in the country. Yes, please.
Yes. So currently we have awarded with the project for processing of waste generated in the Thane at the Atkoli location, where we are supposed to install material recovery facility of 1000 TPD and also RDF processing facility. So the salient features of this project is, here we are implementing ZLD MVR technology for the leachate treatment. That is one of the salient features. And we are utilizing different feeding mechanism in this particular plant. We are utilizing EOT cranes, and we are also implementing automation to the machineries, online monitoring and all such kind of things. And further we are importing shredders from the China, and we are processing RDF and we will be disposing that. So whatever organic generated from this, further it will be taken care in the next step, either through composting or biomethanation. That is next phase which need to be decided.
What I wanted you to highlight is that is the first SLF being constructed in the middle of the city.
Yes.
The uniqueness of the project. Next, please, Pankaj.
Good morning, everyone. My name is Pankaj Chauhan, and I'm civil engineer and working with Anthony Lara in solid waste management. Thank you.
He is the person who is handling the bioreactor landfill at Kanjurmarg, which is a unique facility. Yes, please.
I am Bongirwar. I am presently associated with MSRDC project. We are doing 4 lakh crore worth infrastructure project in city Mumbai and around Mumbai. One of the technology which I have been working is the use of bottom ash as a fine ingredient to replace sand, 50% sand. And because of our effort, the technology has come into the BIS code also. And now we are going to implement for the 700 kilometer stage of MSRDC to save more than 20 lakh ton of sand, as well as more than 200 crores of the cost. Besides, this technology is very useful for the pile foundation because it can increase the cohesion, and presently we are using about 340 to 350 kg cement, which can be reduced to 270 kg cement. We have already done a successful project in Calcutta in association with IIT Kharagpur, and the days are not far off when the technology would come very fast. Another technology which we have developed is the cost-effective solution for black cotton soil, which I was associated with this technology. For our project, there are 700 kilometer of more than 500 kilometer of black cotton soil, and we are spending 700 crores with the traditional technology of removing a 50 centimeter soil. With my technology, the same cost would be reduced to 50 crores. Okay. This is the advantage. These are some of the technology which I must mention. Another is solve the drinking water problem for the villages. I am going to make a small presentation in the afternoon. I would like to request all of you to kindly attend this presentation. And as you know, under the program of Jal Jeevan Mission, the Government of India wants to give 50 liter per person per head for the village population, the pipe water. The cost would be substantially reduced with this technology. We have already done a lot of projects in Maharashtra. Thank you very much.
Thank you very much.
Good morning, all of you. Myself, Adil Iqbal. I have the affiliation from IIM and NIH in an earlier career, National Institute of Hydrology in Roorkee. Currently, I got a fully funded PhD program in AUT Auckland, and my research topic is very much coherent with the today's topic. So thank you, Professor D.N. Singh, for providing me an opportunity to learn here.
Anything about GMLR?
Yeah, currently I'm working with the GMLR.
Eco-sensitive issues.
Yes.
Can you just describe in 1 or 2 lines?
And the GMLR is the project which is very a special form of the project because they associate multiple stakeholders nearby, including reserve forest by SGNP and the eco-sensitive, cross lines are there, and also the film city. So all big bones are there, despite we are running this project successfully, and we got all sort of clearances right from the court, from the communities, and the various vulnerable, the hindrance was there, that all achieved. It is the first project in India in the tunneling, or especially in the forest regime, which has got the 100% approvals and the 5-star rating by the GRIHA, probably we are going to achieve. And it is the first project where we are, under the guidance of Professor Singh, going to achieve the industry integration of 4.0, which is latest.
Next, please, next.
And later on we will discuss.
Yeah.
Thank you.
We have 5 minutes left and 7 people to be introduced.
Good morning, everyone. My name is Shivendra Kumar Agrawal, Project Director, GMLR Project.
Good morning to all. Myself Dinesh Vilas Pagar. I am a design manager of GMLR project, and I would like to say GMLR project is the till date India's biggest project, and TBM tunnel boring is also the biggest dia till date of India, 14.49 meter.
Thank you.
Good morning. My name is Shrutika Pangare, and I am working as an environmental expert for GMLR.
Okay.
Good morning, I'm Shabana Khan. I'm a geotechnical engineer. I'm representing Strata Geosystem as well as geosynthetic industry. Thank you.
Student of geotechnical engineering.
We are involved in development of retaining walls using polymeric waste and plastic waste, and looking forward for much more insights and moving ahead.
Thank you very much. So we have completed the round of introduction 4 minutes before the allocated time. I think a big round of applause to everybody.
Any people on online, Dr. Singh?
Yes, please, we can take some of the online participants. Quickly, if you can introduce yourself, please. I have to read out names. Mr. Vipul Dabode, Prasanna KM, Shailendra, Shiva Prasad, Dr. Archana Sharma, Professor Mohanty.
I'm heading the enabling design team from Hindustan Construction Company.
Okay.
Namaskar.
Namaskar. Yes, please. Dr. Archana.
I'm Archana sir. Now I am representing IIT NR. I am ex-BRC. We had developed some electron beam facility for medical sterilization and wastewater treatment from tannery to textile and sewage water. I am interested in this conversation and brainstorming. Thank you so much for making me part of it. Thank you.
Is this Professor Uday Desai there online or Uday Desai? Snehal. Yeah, Professor Desai, please. Professor Mohanty, can you please introduce yourself?
Hello.
Yeah.
Hello.
Yes, please.
Yeah, this is Dr. Snehal. I'm Dr. Snehal. I pursued my doctoral degree from NIT and currently I am working here at MNIT Allahabad as an assistant professor. My area of interest includes sustainable construction materials, waste valorization and development of thermal efficient construction materials.
Okay.
Thank you. Thank you for the opportunity.
Thank you. Professor Uday Desai. Professor Mohanty, please.
Good morning to everyone. So I am Mr. Mohanty, a distinguished professor in SOA Deemed University. Before that, I was in IIT Delhi and also IIT Bhubaneswar. So we work on climate change and natural disasters, particularly with enhancing the hydrological cycles. We are facing a lot of problems like lightning, the monsoon times, or flash floods, urban floodings, and also landslides. Another important thing is that the coastal erosions and sea level rise, which will lead to a big problem, and with enhanced intensity of tropical cyclones, we are getting the coastal inundation, which is maybe going to threat for the coastal highways, which we are planning for entire coast. So we are working on the mainly on climate change and its impact on natural hazards.
Thank you. Dr. Shiva Kumar. Dr. Shiv Prasad, please.
Hello, sir.
Yeah.
Myself, Shiva Prasad. I am working as a research assistant professor in Hanyang University. I am currently working on recycling of cement and alternative sustainable supplementary cementitious materials in concrete.
Okay.
Thank you.
Dr. Srinivas Kadali, please. Sanjeet Mishra, Seema, Nete. Okay, I think, yeah, Prasanna, please, go ahead.
Yeah, good morning, sir. This is Dr. Prasanna KM. I work for Larsen and Toubro and working for the Mumbai-Ahmedabad high-speed rail project. I'm also my guide is Dr. Bibija sir, who is there from NIT Suratkal. I did my PhD from there on the geopolymer, and also I heard a lot of from Dr. DN Singh sir.
It's okay. Thank you. Let's move on to Mishra. Yes, Sanchit Mishra is there. Sanjit Mishra. Mukti Advani.
Yeah, good morning, sir.
Yes, please.
I'm Sanjit Misra, research scholar from NIT Suratkar, working under Professor B.V. Das sir. So currently I'm working on 3D concrete printing and we are trying to develop 3D printable material that is sustainable. Thank you, sir.
Thank you. Vipul, are you there? Okay, I think we are done with the introduction round. Thank you very much. Now I will hand over the proceedings to Professor Krishna, please. Okay. So I think we can now start the presentation by Professor Parida first. Professor Parida. Yeah. Professor Parida is the Director, CRRI, New Delhi, Central Road Research Institute. Yeah, we are starting. Yeah.
Thank you. So, once again, good morning, everyone. I'm starting my presentation on infrastructure demand and sustainable habitat. So, that's the opening chapter of the document being developed along with Professor Sikdar. So, this changing of the slides?
Yeah.
So here I am going to give an overview of infrastructure demand in India, and we look at the different sectors. The transport sector that covers roads, railways, metros, airports and ports. We had a very good presentation on the ports where we know exactly with respect to the requirement of different materials, alternate materials. Then you have the housing project. Then other infrastructure projects, that is the power, energy. So there are conventional materials, typically cement, steel, bitumen, and so we have conventional materials, cement, steel, bitumen, aggregates. Then there are a lot of industrial waste and other waste that can be processed and which can be used for the infrastructure development, and some idea about the future directions. Yeah. Oh, actually, this some issue with this slide. So again, graphically, this is how things look like. Okay. And I start with the road infrastructure sector, where there is substantial investment, and you can see the annual construction rates are 10,000 to 13,000 kilometers per year. You have key projects like Bharatmala, then expressways, greenfield corridors. Then you have substantial activities with respect to the rural roads. The projects are executed by National Highway Authority of India, by NHAI DCL, even MORTS directly takes up certain projects. Then in border areas, border roads organization, the state PWDs, they also take up a lot of projects. Plus the projects in the urban areas like the various municipal corporations. So that's broadly the major players, those who are in the road infrastructure sector. So this is the total road network currently in the country is the second largest in the world. So that's a huge network, and still we are expanding. It carries 60% freight and 87% passenger traffic. The national highway target is going to be 0.2 million kilometers by 2025 and beyond. And we have seen that especially other than the regular national highway project, there are port connectivities, specifically for the ports. You have seen there is a substantial requirement of port connectivity. Next, please. Railways, so we have the dedicated freight corridors, high-speed, semi-high-speed rail projects, especially the rapid rail transit project is also coming up. Currently 70 kilometers of project completed in NCR. Then there are other sections which will be coming up, and as part of National Rail Plan Vision, 45% freight models here, and reduced transit time. In fact, the present shares of railways is low, which is supposed to be increased under this vision. Next. So in terms of metro, there are 23 plus cities. Currently, our level of urbanization is something close to 35%, and the projected figure is 50% by 2050. So obviously, there are going to be more and more cities with metro projects. 1,013 kilometer of operational metro network, and under construction 647 kilometer. Present ridership level is 1.12 crore, which is very, very low, I'll say. It's supposed to be increased substantially, so that's a sector which is going to increase in a very big way. Next one. So these are the airport projects. So it's the third largest civil aviation market worldwide, and 254 million domestic passengers, 220 plus airports by 2025. Currently operational is something close to 140. And then you need this UDAN for regional connectivity, which is providing connectivity in the various state governments. Next. So in terms of ports, 7,500 plus kilometer coastline, 200 plus ports. There are more and more ports to be developed under the Sagarmala project. So which is envisaging 839 projects and 5.8 lakh crores of investment by 2035. While the chairman JNPA was making presentation, I was trying to work out for one Vadhavan port, the total aggregate requirement is 40 million cubic meter. So if you think it's the area of 1 square kilometer, the height of the material required is going to be a 24-storied building. So that's the kind of requirement, and if you depend on natural aggregates, on natural mining, probably many mountains, many forests are going to be wiped out. Next one.
I think this is where we should be including this concept of man-made aggregates on which many people are working in the country.
Yeah.
I think you should be leading this mission from our side, Professor Pal.
Man-made aggregates, even using industrial slags also,
yes.
Valorization of the aggregates by processed steel slag, it is also possible we can think of. A lot of development is going to be taking place in tunnels. So these are two examples of Jojila Tunnel, Atal Tunnel, Urban Metro Tunnel. Processing talked about the tunnel project in Mumbai. So more such projects are going to come. As we say that the urbanization is going to increase, so they will also, we'll see more tunnels coming up. Next. Then ropeways also, National Ropeway Development Plan, Parvatmala. So for hilly areas, it is being pursued in a very big way. So this is specifically the one at Dharamshala and McLeodganj ropeway project. But that is one segment, at least Himachal Pradesh and many of the hilly areas are looking very keenly at this Parvatmala project. Next one. So this is a very quick overview of the housing, and as we say that the urbanization is going to increase, the housing scenario is also going to be very critical. We have 3 crore rural houses built, 2 crore more planned. Then housing demand projected at 93 million units by 2036. There are various government programs like Pradhan Mantri Awas Yojana and Rajiv Awas Yojana, Smart City Mission. Although Smart City Mission, the second version is yet to pick up, but few of the state governments have pursued that. And current deficit is something close to 10.1 million units for the urban housing shortage, which is going to increase to 3 to 5 crores unit in times to come. So projected demand by 2030 is 31.2 million affordable housing units. The challenges of the sector, the associated challenges are affordability, rising prices, then shrinking affordable supply. Those challenges are there. Next one. So this is again like highlighting some of those points in graphically. I'll skip this one. So in terms of cement demand and supply, so in the chapter 1 we have tried to all these data has been taken from secondary sources, some of the policy documents of Niti Aayog. Present installed capacity is like 600 MTPA, and which is to increase to 850 by 2030. And the demand growth is expected to be 7 to 8%. We have so many projects, so we need to really, meet these requirements. Next one. So in terms of steel, 143 million ton of crude steel for the 23 to 24, which is going to increase to 160 million tons by 2030. And the consumptions are in construction, in auto industries, capital goods, and like it's definitely increasing in a very, very big way for all infra projects. It's very, very critical. Like in fact, in terms of consumption, which is 74 kg persons per year, which is lower than the global average of 230 kg per year. So in terms of number, like these numbers are certainly going to increase. Next one. So in terms of bitumen and aggregates means whether we call them as stones, annual demand is 3.4 to 5 billion tons annual demand for all the sectors, not just road, but the entire infrastructure sector. Then bitumen, currently 50% of the bitumen is imported, and with all the projects, in fact, the demand is increasing continuously. So one is that we can think of alternate materials. The other thing is about the technology also. The type of technology can really be extremely useful in terms of reduced consumption or reduced use of these materials. Next one. So these are like the environmental challenges of conventional materials. Definitely, like they are people are familiar with that, business as usual, then cost effective, durable. But then you have the challenges like high energy use, depletion of resources, environmental impact, and circular strategies. So those are the challenges. Next one. So we have all these waste options possible. Many of the members talked about like use of waste plastics. CRI we are also using different waste materials for road construction, then using end of life waste plastic as geocell that can be used in road construction. Then fly ash, the institute worked since 1994, worked in fly ash mission, so currently being used for embankment construction. Then copper slag, red mud, municipal solid waste, ferrochrome slag, phosphogypsum, foundry sand, and CND waste and steel slag. So all these are the materials they have been tried. So next one. The future directions is like really moving towards low carbon materials. There could be digital infrastructure and resilient designs. The second aspect, most important part, is mainstreaming waste-based alternatives. When we talk about these projects, the total investment in infrastructure may be around 10 lakhs crores rupees per year. And the usage of alternate materials may be less than 1%. So that's a very small number. Then integrating with the climate goals, engaging private sector, and new technologies. So when it comes to deployment of the technologies, largely road sector we have seen, it is confined to the government initiatives. But the private sector is yet to come up in a very big way. So that's how I see a substantial engagement with the private sector. Then obviously the future direction is balancing growth with environmental sustainability and resource efficiency. So these are like some of the opening ideas, and I'll just say that with respect to these aggregates, it is possible that with our experience of processed steel slag, there are two brands in fact. The Tata, they call it as Agrito, that's a processed steel slag, and AMNS one is Akar. So these are not the raw slags which are to be used. If you use the raw slags, there have been failure of many road projects because it contains free lime, so it needs to be processed. The expansion ratio needs to be controlled, and we need to do specific trial that is it really suitable. But for road projects in Surat between Mumbai to Goa, we have seen that it's working well. close to 500 kilometer of road construction has been done by using that, and in marine environment like Hazira Port it has been used. So there are good possibilities, there are a lot of questions to be asked, but then means we need to start with the trial, we need to start with the deployment by which the confidence can be enhanced. Then in terms of bitumen, the bitumen substitute has been out of a agro waste. So like from rice straw, the waste of the rice straw that can be utilized for biobitumen, and the potential is replacement of 25 to 30%. There is another one like especially from lignin. If you are using the bioethanol plant, the lignin, processed lignin can be also used in the bituminous mix. So that has a potential replacement of 10%. So I believe if we work in a very focused way, it is possible to develop these alternatives, not just alternative materials, alternative processes by which the uses, means alternative uses can be worked out. So that's all from my side, sir.
Thank you. So can we take a couple of questions, on this presentation right now? Yes, please.
Foundry sand be a material that can be used for any of these applications that you mentioned? Spent foundry.
Yeah.
My question was, could spent foundry sand be an alternative material for any of these applications that you mentioned in the port construction or for road construction? So that's the raw material that is being wasted today and is occupying a lot of unused land as well.
Which directly we have not used, but I understand that that can be tried, because we had some discussion with the foundries near Coimbatore. So, but there is no trial project where it has been attempted, but can be explored.
You have to also keep in mind the volumes which are required. Now foundry sand is an issue, but this is still confined to the laboratories and the academic institutions. Upscaling of foundry sands for filling purpose is a very big question because of the volumes and collection. Remember, you have to collect it pan-India. That's a major issue. Okay, any other point, please?
In many cases, the foundries are also segregated. So aggregation of the material, that means
I did have a question.
May I request you to identify yourself when you ask a question, please?
Yes. I'm Indrani Malkane. I wanted to ask, you have mentioned about municipal solid waste. And in my introduction, I had mentioned about an initiative which was taken up by the Municipal Corporation of Brihan Mumbai. That is the municipal solid waste being converted into bricks. And that project took place in 2001 in Deonar. I was wondering that if Mr. Jain is aware, when he was additional municipal commissioner there, such waste, could it be scaled up? Because it never did scale up, and yet the demand for bricks and the cost, etc., is there. I mean, it's something which is required, and waste is a huge, big problem. So municipal solid waste, that is. So I was wondering that in this August gathering of this forum, under this organization, the forum, that how such waste can be utilized optimally by way of making bricks, because housing or any other construction across the country, we see that. A layman's question, but then we are all generators of the municipal
Indrani, during lunchtime, you should be talking to some of the research scholars here. You have created man-made aggregates and man-made soils out of the waste. And I think they will be displaying it to you. So please hold on until the lunch and you will be getting the answer to your question and query.
Oh no, I intend to get everybody running.
Director CBRI is here. Maybe Professor
Thank you.
Pradeep Kumar can respond to that.
I'm Ajit Kumar Jain. One question about the reuse of the recycled material coming out of the municipal solid waste. My sense is that this can only be done if it is market driven. Yes. Ultimately, it should be competitive in the market for a common man to be able to absorb that. So, has any or have any techno-economic feasibility studies been done, maybe regarding use of plastics, waste plastics, and also the CNT material?
Let me just tell you on the waste part of it, two aspects. One is the organic waste, another is the inorganic waste. Well, on the organic waste, several works have been done to transform the waste to manure, which are being used. But the question that comes is the marketability. Once the manure is produced, you need to do proper marketing, otherwise it gets dumped. That's number one. But in the inorganic waste side, particularly the C&D waste, a good amount of works have been done on the reuses of the coarse aggregates and the fine aggregates, recycled aggregates in the concrete, and that's being used extensively in the construction sector today. So, and quite a few organizations have come up who are producing the recycled aggregates, and I think we need to scale up. We need to have more agencies to take up this to formally use it, but it is well established. The BIS even has come up with the standards for usage in the construction industry.
So MCGM has taken initiative. There are 2 facilities operating in Bombay right now, and they are doing extremely well. In fact, if you wish, you can visit them. At one end is Dahisar and the one is Kanjurmarg. Shri Harsha, you would like to add something on C&D waste management?
I like to know that you have projected in India, the 74 kg per person per year is the consumption. But what is the current value? What is the position in China?
Chinese data
Anyway,
specific.
so far my understanding goes that China is the highest. They have the maximum per kg per capita per year. But now the next question is that you have projected the production is more than the consumption. So how it helps? Does it increase the per capita consumption? And what happens if there is excess production? Are we going to export those steel? And if so?
So mainly, sir, they are going to be used for export. China, I'm believing it should be, maybe it's more than the global average. Means just intuitively what I'm thinking. I'm not sure about the numbers. But if you have more production, then obviously it's going to be used for the export only.
My next...
I just checked the number that you asked. In 2022, China used 646 kilo per capita, and this number went up to 669. Currently, it is 601.
Yes, sir.
So it's nearly 8 times of what we talk.
Yes, sir. That's why I was thinking intuitively it's going to be more than the global average.
Yeah, I have a question. May I add Sandeep Goswami? Sir, the discussion over here was talking about using of plastic, and we are also practicing design, because disaster resilient design, when we are talking about using sustainability. As I was looking for alternative to steel, TMT bars and all, there is a company called Tangent in the US, which is making from recycled plastic. They are making materials which is as strong as steel for construction. Do we have some kind of a program over here which this is happening, because we have enough plastic waste lying around? Thank you.
I am not aware about such like product which can match with the strength of say cement, the strength of steel. But there is one currently there is one project which is on geocells. By using end of life waste plastic, geocells have been developed which can be used in road construction, so that the thicknesses of pavement layers that can be controlled. But very high strength like material out of waste plastic, I am not really aware.
I will send that detail to Dr. Singh. Tangent, the company is in US. Its name is Tangent. Thank you so much.
Please, sir.
This time all of you. We'll move on to now Professor Bhattacharya's presentation. Yes, please.
Professor Singh.
Dr. Singh, I have to go.
Yes,
So
please. Yes, yes, sure.
Thank you.
Okay. Thank you. I'm not coming down.
Can I?
Should we start?
Professor Singh, can I have one more question?
No. Now during
No
lunch.
question, okay.
Well, good morning and welcome once again. As in the opening remarks, Professor Premkrishna has stated that the forum on infrastructure from INAE is working on a project or to come up with a document on sustainable infrastructure, and the outline has been given. So I want to touch upon two aspects on which we are trying to create some kind of ideas in this particular area, namely the construction materials. And if you are talking about sustainable infrastructure, you cannot rule out the materials part of it. This is very much in the heart of it. And second aspect, which is very important, is how do we disseminate the acquired knowledge that have been generated at different places to different stakeholders of the infrastructure group, which is, that's why we are saying that as an educational initiatives. Can you move to the next slide, please? Yeah, I mean, this is a standard thing which is known to every one of us who is present in this hall, is that the UN has prescribed the 17 Sustainable Development Goals. And as it has been stated rightly in the beginning, that we are focusing on three aspects, 9, 11 and 13, though there are many other areas where the sustainability of the infrastructure comes into picture as well, and we are contributing. But at this point of time, when we are focusing primarily on the infrastructural aspects on transportation and the building sector, we thought these three aspects are more important and we wanted to emphasize on that. Yeah, next slide, please. Well, when we talk about sustainable infrastructure, I think the two immediate aspects that come to our mind is the issues that are cropping up related to the energy and the issues that are cropping up from the material usage or material generation. And they are quite interlinked, intertwined, and I think we need to explore for that. And since I see that a large group of people who are working in these related areas, I'm sure that we will get more ideas in this than what we are conceiving at this stage of time. Yeah, when we talk about the material, naturally during the entire life cycle of the projects, from starting from its initiation to recycling process, at every stage we consume huge amount of energy. And that's where we need to put our focus on in the manufacturing, in the transportation of the materials, in the construction, in the operation. At every stage, we use huge amount of energy. And what we try to extract is that creating an infrastructure, how much is the embodied energy? When we talk about the embodied energy in a system, we try to talk about all these aspects, how much energy has gone into it, and how do we really compute it, and then in turn we try to come up with what is the carbon content and how much it is getting exposed to the environment. So there are issues related to the materials, but then at the same time, if we have to address the issues of the embodied energy in the materials, what should we do? We have two avenues. One is that we need to create some kind of material which we will have to come up with innovative materials which can replace the requirement of the energy to a large extent, and also the usage of the technologies that are going into the creation of the infrastructure. How do we address that in an innovative way so that we can cut down on the energy usage? So these are the two focus aspects that we are trying to put on. And this is a graph which very logically has been adopted. I think I have extracted from one DOE conference. It says that the carbon exposure is going up. So how do we cut that down? And I know we talk about the use of the renewable energy sources like solar, wind, or we do the carbon sequestration. That's one path of it. But as it has been stated that almost half of the carbon content comes from the built up infrastructural systems. So there is a huge scope that if we can come up with some innovative material, innovative construction technology, we can cut down the carbon content to a large extent. And that's where it's expected, and that's what is being focused, that by 2050, or when we are talking about that, in 2047, we like to achieve certain things related to the carbon, we will be achieving these to a large extent, and that should be our focus on. And as a civil engineering community, as a community who are working on the material, I think our focus should be on to come up with some innovative material, to come up with some innovative technology by which we can cut down the exposure of the carbon to a large extent. I think I have taken this from internet, and this is known to everybody, that if I want to make a sustainable system, I must address the issues related to environment, I must address the issues related to social aspects, I must address the issues related to the economical aspect. And there are several examples that can be cited where any two of these have been addressed, but really those are not sustainable. So if we want to really achieve the sustainability, and then we must address all three issues together. And there are several such examples where we can get into to say that yes, it could not become sustainable because this aspect was not addressed properly. So this is the focus that we need to give on. Yeah, can you quickly go on? Yeah, put one more. One more. Yes. Now, while talking about this, while talking about the material, all of us are knowing that, we are talking about alternative to the fine aggregates, coarse aggregates that we are using. The reason being that we are using extensive amount of the natural resources. When we are using the coarse aggregates, we are depleting the natural resources. When we are using the fine aggregates, we are taking the natural resources from the riverbed. So naturally, the natural resources are being depleted. So what are we leaving for the next generation? We cannot make use of entire thing and use it, for next generation to say that we don't have anything for our use. So time has come when we'll have to think that we will stop using these natural resources and we'll try to go for the alternative material. And that's where the community has to come up with the innovative material that's needed. We need to create systems which are durable, which can withstand the environmental impact for a longer period of time. If we can defer the life, if I am designing a structural system for 50 years, if I can make it for 100 years, then my requirement of the material also will come down. Thereby, pressure on the natural resources will come down, and the material should be able to withstand this extra long duration. The durability aspect is very, very important. And that's why, today if you look into the durability aspect that we have in the IS code, merely adhering to that is not adequate. You may have to go extra mile to achieve the durability. And that's what we need to focus on. That's where we need to understand that what are the aspects that we need to do. And finally, we must get the quality out of everything. And that's what it is. Incidentally, I was just browsing through the Facebook, and I saw this picture. So I was tempted to take this picture. I thought it will be ideal for this forum to tell you that. You see, when it comes to the quality, everybody wants to focus on that's the person who is looking into the quality. Or when we try to look into the functioning of the system, everybody says, look, this person is responsible. I am not. But let me tell you, each one of these group is responsible for the quality. Now, I had seen, I keep saying that the quality starts from the planning stage itself, because I know I had seen one flyover construction in a particular place where the planning was done, and by the time the flyover was in place, by the time the traffic volume increased by double. So the planning was such that they did not anticipate that this is going to happen. So that's not a quality planning. So planning starts, quality starts from the planning to the design to the execution at every stage. Whenever something goes wrong or failure happens, we say, well, the construction was poor, the material was poor. but nobody wants to take the responsibility, saying that, no, we are a part of it. So I thought this is very relevant and valid when we talk about the quality aspects in the system. Yeah, next slide, please. Yeah, these are some of the representative things that, the thought process that has gone up in our document. What we are saying is that we are trying to address each and every kinds of materials that are being used in the construction sector, and where do we stand today in terms of broadly, whether you talk about concrete, you talk about ceramics, you talk about bitumen, you talk about timber, and what is that we need to do so that tomorrow we get a system which we can say that will have a very positive impact on the environment, will have a net zero effect, and that's what all of us are trying to work on. And these are some of the aspects that we have looked into, and we'll be happy to get more ideas from you who are working in this material area to say that yes, what are the things that we are doing so that we can take these materials to a place down the line when we'll say that yes, we are net zero on this. So these are certain aspects related to the materials. Next slide. Yeah, there are some roadmaps related to the construction facility that are infrastructure creation that we have, the infrastructure that are created today, and what is that we can do in terms of addition of the materials, in terms of addition of the infrastructural system, in terms of the technology, so that we create future infrastructure wherein we will be able to claim that yes, we have achieved this. And these are some of the aspects on which different academic institutions, different research establishments who are working and trying to achieve to certain extent. To many material we have achieved certain goals that we had tried, we have done in several decades in the past, but then still we'll have little more ahead to go so that we can claim that yes, we have reached to that place, and that should be the objective of the activities that we are taking it up. Next slide, please. So summing it up, looking on the materials front, in fact, while writing this document, we had tried to collect the information from academic institutions, we have tried to collect the information from the research establishments who are engaged in these different kinds of research, and from the industries as well. And then we thought it will be appropriate that whole gamut of the materials we can define in 3 groups. I know that there are large number of materials wherein substantial amount of research works have been done and they have reached to a stage which can be used and is being used. But many a times what happens as academic institutions or research institutions, we feel that once the research work has been done on this and it is working, our job is done. But we forget about 2 aspects. One is its scalability, that whether the research that has been done on a particular material, can it be scaled up? And second thing is, which is very important, and I am sure the persons who are engaged in the construction sector, you will agree with me, if this material is not endorsed by the BIS, you are not going to use in the practice. So BIS has to come up with the standard saying that yes, this material can be used and it satisfies the requirement of this. And that's how you are going to use. Right. So there are some material which have been researched upon, which have been standardized by the BIS. So we have kept them in the group which are already developed and readily can be implemented. Second group of material wherein extensive research is being done in the academic institution and the research establishment, but it has not gone to that level as well in terms of scalability or in terms of standardization. So we need to take up those issues so that it can see the light of the day. And the third group of material wherein we think that yes, this can be used, but extensive research has not been done. So if we can categorize these 3 groups of material, then I think we can tell the industry, look, we have reached to certain stage. So with these aspects in mind, we have tried to jot down different aspects in our document, and we are trying to put down that, and we like to get more information from you. Second point, as I said, that what happens is many people are not aware of the kinds of materials that have already been developed, materials which have been already standardized by the BIS. So I think it's time that we educate people, and this education has to be done very systematically. So we said that we need to generate awareness amongst the stakeholders for the sustainable issues that are required, the sustainable materials and the technologies that are available with us and can be used readily in the market. And at the same time, we need to develop the skill of the personnel who are involved into the construction sector. And that has to be a continuous process. Unless we do that, because many a times we talk about the requirement of water in the concrete, but the persons who are working at site, particularly at the lower level, they do not understand the implication of it. So unless we educate from the bottom to the top, still there will be a vacuum. So next slide, please. So these are some of the ways which we have thought that we will brief in the document, that how this can be disseminated, how the technology can be transferred amongst the different stakeholders. There are quite a few programs by the government which goes on, like LEAD, IGBC, like Amrut, PMKVY, National Skill Development, and so there are government initiatives where some regular programs happen. But apart from that, I think it's important that time to time we, the stakeholders, keep meeting, talk about the things that are available, where we need more focus to be given. And this has to be a continuous process. It cannot be a discrete. DNC organizes one workshop and then forget about 3 years, again next workshop happen in 3 years. That should not happen. It has to be a continuous process. Then only people will be knowing what's happening. I know when I was in CBRI, the kind of materials that have been developed by the laboratories, and those laboratories should come up and tell, look, these are the things that have been done and you can And lastly, I think it's very important that we are talking about the engineering curriculum. It must be brought in the engineering curriculum so that the students from the institute level itself start getting this flavor of this, and they can take it up when they can go to the practice. So this is in brief is the outline, is the thought process that have gone in to prepare the document, and we'll be glad to get the feedback from you, and so that we can enrich this document through your input. Thank you very much.
So, Professor Bhattacharya, 3 things from my side. One is the transportation of the material, which are either naturally available or man-made. The biggest issue is that the transportation is something which has to be sorted out. This we have been trying through INAE, forum. Unless Indian Railways or MOST or, surface transport or water transport bodies come together and transport the material, this problem cannot be addressed really. So number one is the transportation issue. Nobody wants to spend money on the waste. You rightly said more and more awareness among the masses, and technologists and research institutes are doing their work definitely. But then what should be documented is how you are going to rope in the agencies which are going to make this material available. Beautiful example is Bombay Metro. And using the mug, MBPT, I think, you are here, Mr. Shekhar. So by using all this mug, you have created Jawahar Deep. It's a beautiful example of how island has been created next to, Bombay city. By using the mug which came out. Can you please would you like to speak something, Mr. Shekhar? Millions of tons of the mug has been used for creation of the island next to Bombay, yes.
Actually, presently one tunnel project is going on between OGPD to Masgo to Coastal Road. And that mug also we are going to use it for our...
Even Navi Mumbai International Airport for that matter.
Yeah, that's it.
Whatever hill was cut down, it was utilized. Yes, please. Dr. Nori, please.
What I would like to share is over the last more than 40 years, we have designed several bridges which have no bearings, which have no, at all, so they don't require any maintenance at all. Now, they're very sustainable. In fact, we never thought of sustainability, but it's a natural consequence of finding structures which are durable and which require no maintenance, and therefore they will last very long. In fact, all these bridges are still there and they're still doing very well. And this is what I would like to share. We should not depend on the codes. We should think beyond the codes. There is no problem at all, because we take responsibility for our structures. Thank you.
Thank you. Very interesting. Yeah, Shreya, please. switch on the mic.
Yeah, I would like to just add on to this presentation, considering our experiences in it. One more thing which we need to consider is commercial viability. So if we consider our plant, we will be doing pallets which can be used as alternate materials, and apart from that, we are also developing green energy. These all things, but the end of the day, the viability which comes is very low, and the demand has to be increased, which is possible by the awareness which is showcased in the presentation. That's what I feel. I mean, commercial viability is one of the points need to be considered.
Yes.
Thank you. That's important.
So, Professor Bhattacharya is an excellent presentation actually. I would like to say, research front, there are a lot of advancements, particularly in this side. Only challenge is when we go and approach, like for example, smart city, like as you said, Mangalore, okay, where I belong to, when we go to smart city, talk about, okay, this is a transformation tech we have done already, but there is no takers. Even there are some municipal commissioner, okay, they understand, but the biggest challenge is there is nobody like who comes forward to, for example, even the smart city, but tier 2 cities, C&D waste is hardly being managed. Okay, like so if you say the Karnataka, where I am the member of C&D waste management like rules for all the smart cities, only Bangalore is the only city where C&D waste is being managed. No other cities, okay, like it is being managed.
Yeah, we have MCGM officials here. And they are managing the C&D very well.
In Delhi,
would you like to?
In Delhi, it is being done very
I'm
well.
talking about the Karnataka. Okay. Not all of the like the part of the Bangalore is well managed, but when you go to the tier 2 cities, like okay, there is very difficult actually. Even
that's where my point is coming, is that we need to educate everybody. We will have to bring this. See, you will have to bring up that how C&D waste is going to improve their system. See, people have an inhibition saying that if I use the recycled aggregates, my strength of the concrete is going to go down. But actually, it's not so. You'll have to tell with your technology, saying that, look, this is what happens. And then only people will be ready to use it. And that's where the educational initiatives are to be taken.
Educate at different levels.
At different levels.
Not only from Anusha, she is working on.
Not only institutions.
Yes,
correct.
Anusha.
All stakeholders should be.
Organizations, yes.
Correct. Particularly those who are using it, they should be made aware of.
Come closer to the mic.
Not only just the users, what about the manufacturers? Because you see this, we talk about the standards exist, but the manufacturers, we never put everyone at the same table.
No,
So
manufacturers will have to achieve the target that is given. See, that's why the quality thing I am talking about. See, if I know that I'll have to produce this, then the manufacturer has to produce that quality material. Otherwise, naturally, that will not be acceptable.
That is correct. So the generators.
Demand. Yeah.
So the demand will come. The generators, we have to recognize the value and the wealth that exists in various kinds of waste of C&D is one of them, and a major one.
That's what I'm saying, that BIS has to come forward and say about the quantification of that. See, if you take this aggregate, that these are the properties that you must get in that, which can be used in your concrete. So if I have the blend of these two, the research output of this and stamped by the BIS saying that yes, this, if it is adhered to, then it is acceptable. So that's where we'll have to focus on.
So is BIS not part of it?
No, BIS is not part of it. That's why I'm saying the research establishment, the academic institute should know that we'll have to pass through that stage as well to make it viable for the industry.
So good. So I think we should get BIS.
The
Professor
BIS
Singh.
He is representing BIS today.
Yes.
So he will tell that.
But he's therefore keeping very discreetly quiet.
The additional Director General BIS is a member of the forum. He has
Yes.
not been able to come.
Yes. I mean,
What
just
I'm saying is,
yes.
what Professor Bhattacharya is saying is actually happening in the BIS, and more and more.
Madam,
And
I can
think,
give you another information.
Dr. Pradeep Kumar will be.
Yes, I
talking
can give
about
you
this.
another information, that BIS in fact has come up with a large number of materials which have been researched upon, which can be used, but people are not aware of. There are many constructors who are not aware of that these materials can be used. And BIS have come up. In fact, Mr. Pant was sharing that a large number of materials are available in their group. So people should be aware, and that's where I think our job is.
Yeah,
needed.
Professor, it's a good point. So, but I think debate is about performance versus acceptability of the material. Hello?
Yeah, we are hearing you.
So I think debate is about performance versus acceptability of the material. So I think if it is performing well, but we are not sure that someone will be accepting the material or not, and if it is accepted, we don't know about the performance. So I think this debate should be created, or it should be looked upon.
Incidentally, he is the person who has created man-made aggregates, very passionate about his research. From dead material, he has made artificial aggregates.
Yeah, so we are trying to create like aggregates from waste plastic from landfills and dredge sediments. But again, whatever debate is going on, so that would be a good.
So two things you will have to address to. One is that whatever you have researched upon in your laboratory, that can be scaled up by industry. That's number one. And second thing is that you will have to take BIS on board to tell that what properties you are giving is acceptable to the construction industry.
Agreed.
If you can achieve these two, you are going to get a
Some discussion have already started with Professor D.N. Singh's group. So because when we came to know about the development of the synthetic aggregates, so then a proposal has been given for using these aggregates for making bituminized roads. So to see the all the properties, and if this can be tested and the results is made public, at least to the authorities, Indian Road Congress, then it will get the propaganda.
Korade, please.
Yeah, thank you. Professor Bhattacharya, there is a small edit to your presentation maybe, in which you represented various conventional materials, and I'm happy to see timber being part of it, but conventionally not being used anywhere in the country. A small edit to it I would want to add is that probably you would need one more section with bamboo, because it's a grass, it's not a timber, and it's very widely available. Within 3 years it achieves full structural strength, right, coming from the ground to its full capacity. And the very rightly you mentioned about the fundamental pillars of sustainability, like the social aspects, environmental aspect, and the economic aspect. So it ticks all those boxes, and probably in my presentations also I will brief you the kind of work that is happening in this sector, and also being part of the Indian standard of 159182. We are looking at that, but in terms of getting it to the field, the major issue or challenge in that sector is that we don't have the cost of single pole mentioned in the DSR. So if at all it is to be used for the construction purpose, like in terms of designing as well, if say 5 poles are required, 4 poles are required, the cost estimation is where the whole buck stops. Correct. So maybe that you can look at. Thank you.
Balraj? Yeah, hello sir. This is Balraj here. I heard that there was a discussion about commercial viability of these products that we have been developing. Firstly, I mean, it has to be gone through the BIS standards and everything. But there is one more important thing that we should address, is the gains that we are going to get from the materials that we are using, and get out of a psychology of giving it to the minimum bidder. Right, it is always going to recycled plastics are always going to cost more, or recycled polymer is always going to cost more, because you are going to load double transportation on it. You are going to recycle it, you are going to treat it, and then you are going to put it to use. So anybody who is a wise person will always think that it is, yes, it is costlier, but the benefits of it that we are going to get in the future, the government is already giving carbon credits and all the details, right? So that benefits have to be passed on somewhere, and the entire system has to be made commercially viable. So I think it is also important that all these factors should also be added to the educational field or the system itself, so that the BIS can increase, be directly an improved version of what we are discussing right now.
He is the guy who has created crib.
Yeah, I think the point is quite valid. In fact, my next presentation in our is going to talk about life cycle cost analysis, and that's where we harp on. We say we do not stop at this. We do not say the material could be expensive in the beginning, but if you take the life cycle cost in the long run, it may not be expensive.
Give him mic,
I think
please.
Professor Pradeep.
You can just come in the front and speak. Yeah. Yeah, please.
Yeah, I'm also working in the similar sector, solid waste management and all. So we have also seen that recycled aggregates, since commercial viability and various things are being spoken. So already in CPWD schedule of rates, recycled aggregates are already mentioned, the costing, and I think I have seen in one of the BIS also recycled aggregates and sand is also mentioned. So government is also taking initiative. That's what I wanted to mention. Thank you.
Very nice. Yes, Sushmita, please. No, please speak in the mic because that's recorded then. It's on.
Use this. Yeah. Okay, I'm Dr. Sushmita from IIT Meghalaya. I wanted to talk about the infrastructural deficit since we're all talking about C&D processing here. So in coming from a two-tier city, so there are a lot of infrastructural deficits. So how initiative are being taken on that front? And secondly, as he very rightly pointed out that the cost of the recycling product is very high at the initial stage, how do we change the mindset of the common users to use such a product? Because in a place where I come from, natural aggregates are still widely available. So until that natural aggregate exhaustion is completely done, people will not resort to using a recyclable waste. So this kind of initiative have to be brought into the mind of the people. So awareness needs to be there. So from infrastructural deficit to awareness and then cost estimation, everything is lacking in certain areas of the country. So how to address that, we need to discuss on that too. And with that only I come to this particular forum to discuss.
But at the same time, you come from an eco-sensitive area. So don't think that you have a lot of natural resources.
Yeah.
That is also an important point. Yeah, they have a lot of bamboo. Yes, please, Dr. Singh.
Yes, sir. Hello, I'm Dr. Surinder Singh. So I just want to make a point that Professor Bhattacharya has mentioned that BIs need to educate people or make more awareness regarding the use of sustainable material. So what I feel is even if they are aware of these sustainable material developed from the waste material, many of them has some resistance to use that. So in my view, if we mandate or we make it compulsion that, okay, if you are doing for or you are going for a construction project, if you consist or you made 5 to 10% of material to be used for the construction, if there is any mandate or gadgets from Gazette of India where we can make them compulsory to use this sustainable material, I think that could be one additional point in addition to education.
Can we know that why this inhibition? Why they don't like to use the material?
Because I think in their view, it is there that the material that we are preparing or manufacturing doesn't have enough strength or durability or properties.
That's why I am saying that if BIS certifies and BIS says, look, if this material adheres to these properties, then it passes through. See, when you use a concrete, you produce a concrete, your standard is given that if you use M20 concrete, you will have to have these properties. If I have a material which satisfies the requirement of the standard, and if it is produced, then it should be, used, acceptable.
Sir, actually, on one of the forums, one
not I say all stakeholders, architects inclusive.
let me comment on that, Bandyopadhyay from ICP. See, if the quality is okay and as per certification of BIS, there is an opportunity by the authority to impose it as a mandatory. Like, for instance, if you know, the use of recycled plastics in food contact application hitherto was not approved, but universally now this has come, and in the EPR rule also the government has imposed that at least 20% or up to 30% recycled material has to be used even in food contact application. And for your information, whatever the PET bottle you are observing, these have been made by use of recycled plastics, of course with various controls, FSSI approvals, controls are there.
That's why you are having here.
Yeah, this is glass.
We have
Is-
replaced plastic bottles by glass bottles.
No, okay, fine. But the recycle, I'm going to recycle plastics, non-food application, there should not be any problem. Government to impose a mandatory rule that if the property performance is there, so 20%, even 50%
That's right,
recycled plastic has been, recycled material can be used.
Alpa, please.
So there was one slide in Dr. Bhattacharya's presentation which was very clearly saying stop depletion of natural resources, and I completely agree with that. And in fact, even one of the goals, that goal number 12, was ensuring sustainable consumption, right? On the other side, we are lamenting the fact that today we are using only 75 kgs per capita of steel versus average of 250 kgs per capita of steel internationally, versus China having 600 kgs. So basically, we as technologists, some of us being technocrats, we are trained to think that growth is consumption. Okay, so my question is a very basic question, that we are talking about recycling, valorization of waste, efficiency in use of materials, more efficient technologies, use of alternative materials, all of that. What amount of reduction in the use of natural resources is that going to really help us? It's going to be a delta change. That's the elephant in the room. So we may be able to, become more efficient by maybe 20% if we are lucky, or 25%, not more than that. Like, let's be honest. So really, one thing and one more slide which I liked of Dr. Bhattacharya's was that, he's saying it's social and economic, and, it's also about aspirations of people. But one of the things which is going on across the world, and it's not yet caught on in India, is it's a very simple thing that if we want to reduce and stop the depletion of natural resources, we have to also learn to consume less. So we have a very inequitable consumption. So we have in Meghalaya and in some of the, states of India where really the consumptions are very, very low, and the development is much lower and it needs to be raised. But we are talking about sitting here in Mumbai, sitting in Bangalore, sitting in Delhi, where today, for example, in Mumbai, you have 48 lakh houses which are vacant, which have been bought and not being used. In Delhi, it is 30 lakhs. In Bangalore, another 30 lakhs. So I'm just talking about, we as technologists just cannot be saying our role is just about engineering and bringing in efficiency, because that's going to bring a very small delta change. I think we need to be also engaging with the community at a larger level and get out of our comfort zone and, just about technology, because then we're not really helping this goal of making it sustainable. And I think we need to look at that sometimes I don't know how many of us as technologists will say that really this particular, I'm just giving an example, coastal road. I don't want to get into politics or controversy or anything, but what is a cost benefit ratio? Is it really required? How many of us have the spine to do that as technologists? Nobody. So I think I'm just saying, let's wake up and smell the coffee, and not just happy being in this conclave and, Dr. Dhyan Singh had a fantastic, just let's think about it, right? We have a larger role in society than just being engineers. Thanks.
Can I take this question, Dr. Dhyan Singh? I think it's very interesting observation which has been made. When we are talking about the, avoidance of the depletion of the natural resources, I'll give an example. In the infrastructure projects, if you really look at it, 90% of the carbon footprint comes from the cement and steel. It is 90% of the capital carbon. When I say capital carbon, before the use stage, 90% comes from the cement and steel. Replace the cement with the industrial waste. That's what we mean when we say the depletion of the natural resources. And also use steel, recycled steel, basically the scrap. You say, for example, steel carbon factor today is around 2 ton carbon dioxide per ton production of the 2.5. If you use the scrap and use the methodology or the manufacturing process using the EAF, electric arc furnace method, if you're using that, it comes down to 0.6 in India also. But unfortunately, there are problems in implementing it. There are problems I'll tell you, the code makers as well as the consultants' minds itself. If you are using the recycled steel, they say will not be allowing it to be used. And imagine 2.5 carbon factor comes down to 0.6 carbon factor. That means 75% reduction in the carbon dioxide emission to the environment. And not only that, your depletion in the natural resources for production of the steel is reduced. So when we say depletion in the natural resources, alternative materials, industrial waste like C&D, construction and demolition, has to be used, and also designed in such a way that at the end of the service life, that components can be reused. If you're going for a steel construction, steel components can be reused. Similarly, if the precast ultra high performance concrete you are using it, at the end of the service life, that can be reused. Precast, in the construction, it's not necessary. That is how it's possible for us to deplete, avoid the depletion of the, like this natural. So this is what we are talking about when we are talking about the natural resources. Another question, Alphaji, what I use, I forget now because I was.
No, to add to that, Mr. Hegde,
Yes.
in fact, what she was saying, that, consume less. Yes, for consumption of less things, you will have to address two issues. One is that, again, we need quality designer so that we don't just go by the requirement of the strength only. The economical aspect has to be looked into. And second thing is that's where I harp on the durability. Yes. If you can make the system durable, then, it can prolong, the life can prolong for a longer period of time, your reduction of material will come down. Yes. So, you'll have to address, yes, it is agreed that these are all incremental, but if we keep on incrementing this, one day we'll achieve the goal that we are trying to achieve for. That's what is the focus.
Yeah, another point, like this consumption steel kg per, I think it is just to indicate, it's not, we are not trying to increase the steel consumption to match with the China. That is not our intention here. When you are saying that, see, the thing is, China is producing the maximum amount of steel in the world. I think we stand second. That is the point we are making. But we are trying to, we are trying to justify it. Though we are producing more, our per capita consumption is less. That's only a justification. It is not trying to compete with the Chinese. Like we are producing most. That is not the idea when you are talking about it. Basically. That's what I think.
I have one question from Shavana, please.
Okay.
Sir, it's not a question, but the add-on with discussions what we are having. So if we all are from infrastructure domain, we must be aware that NHI and MORTH has also given, mostly they are sending the regulations kind of a note to all the contractor when they have been awarded the work, that 10 to 20% you can use the new technology product or a recycled product based on the approval of the authority engineer. So the government is already making certain initiative with respect to certain products whose name and the guideline they will be giving into the circular when they are sending it. I think we need to be more specific about regional wise consumption of these material, because every state will not be having the same issues what we'll be having in a metro cities. If we are concentrating on that where we have a larger infra development, we have a larger consumption of the natural resources, there if we come across with the more stringent guidelines, supports from BIS, and also as rightly mentioned by Balraj, about not giving always the L1 contract a very high privilege. If we basically moderately adopting these pointers, we are almost a step ahead. Like we are taking the steps in infra, we just need to push it more to adapt in a larger way.
That is not enough. I'm going to make that.
Agree with you, sir. It is not enough.
My next presentation is about that.
Yes.
We'll come to that. Before that, we have Dr. Yes.
China produces, Mr. Hegde, China produces maximum steel, but their consumption, per capita consumption is much higher than India. But India, I do not know, one has projected 75 kg. Just 10 years back, it was 36 kg per person per year. Now, at that time, there was no use of steel. Actually, everybody was scared to use the steel. In Mumbai, we could not use the steel because of the marine environment. Now, the weather is changing. Because one thing they are telling, the steel has a good recycling process, number one. Number two, steel is easy to fabricate and replace the steel anywhere, and its cost, because of the recycling, it is much lesser than the original steel, and it becomes cost competitive. Earlier it was not competitive, right? Now Mumbai is also using steel structures, right? So the environment is changing, and you are talking about the carbon credit. I still do not understand what is the, if I get 10 carbon credit, how I use it, what is the benefit?
Yeah, very rightly said.
Because
So-
DMRC has got the maximum carbon credit across the world, right? So how they will use it?
So this actually, Roy Saab, this discussion is going on another forum about carbon credits and all. So let's listen to this boy now.
Yeah.
Yes.
Just one. So, like, since we are discussing about recycling of materials, so I would like to introduce, like, at GRP, like, since 1974, we are recycling the rubber tires. So there are different components in the rubber tires, like we have carbon, like carbon chains, then we have steel wires, textiles, and different other components. So basically we are recycling all these components, separating it, and then we are again using them to manufacture new tires. And then we are also utilizing waste plastics to make polymer composites. So like I was fortunate to like enough to work on rubber utilization at IIT Bombay during my PhD. And now with the help of GRP, I am trying to implement it and making rubberized concrete, which is a very good product for marine environment, for extreme environmental conditions where very high temperature or very cold climate is there, because it has very good thermal insulation, acoustic insulation. So like this is where like we are like I try to connect technology with the implementation at field scale. And I like at GRP, like we are working at waste plastics, waste rubber, and then also C&D waste I am trying to implement in the rubberized concrete to create sustainable material.
Thank you. Sanjay, please.
I just have one suggestion, sir. Just wanted to share that you have been talking about the per capita consumption of steel has been 74, and compared to China, it's much lower. Using more steel is not a bad thing. Actually, using more steel is basically a progress of a nation. Any nation that comes under developed category actually uses more steel. For example, Korea, for example, uses 900 kgs per person, Japan. So the GDP of a nation is directly proportional to the consumption of steel. Steel was not used for a very long period of time simply because there was lack of awareness. Even if you now take it all the IITs, how many people who actually specialize in steel, there will be 1 or 2 or 3 IITs maximum who teach steel. So whereas if we compare to concrete, there will be people who would be working on pre-stressed concrete, precast concrete, advanced concrete, reinforced concrete. So the mindset of the engineer has been mostly driven towards concrete intensive construction. The problems with the concrete is that in a native state, it cannot be reused. Whereas steel can be reused. Once it is a 350 MPa steel, it can again be reused. So what we need to focus is design for deconstruction. So when we design a structure, we have to be taking into mind how can we reuse that 30 years. So is there a possibility we can remove the nuts and the bolts of the steel beam and the column and take it to another place, which has been done. So today, for example, in Qatar, they built a big stadium for football. After the football is over, what is the need for a stadium? So they pack everything, remove the nuts and the bolts, put it in a ship, a container, take it to Brazil for the next football stadium to be constructed. The only thing that you should construct is the foundation. Rest everything should be shipped, packed with the barcode. They know exactly which beam, which container it goes, and then they put it and get it done. So we have to understand that the structure should actually be reused at the end of design life, and how do we teach to the students, and that is true sustainability, because we are focusing a lot on making an unsustainable material into a sustainable material. On top of it, our country is becoming more seismic. We are slowly becoming from zone 0 to 1 to 2 to 3 to 4, now we have up to seismic zone 7, which is inevitable. 6, right? It will go to 7 eventually. Right. So if you look at it, it is a dynamic. The statement in the codal provision says that this is not the final seismic map of the country. It could change based on the earthquake that come.
Let me share some of my thoughts on this. Because there is people are saying that why our steel consumption is low. Let us show the elephant in the room. The primary reason why our steel consumption is low is because of the model of construction agreements that we have in the infrastructure.
Exactly.
All the projects mostly are based on EPC mode. In EPC mode, it is the initial cost of construction on which the contractor bids, and mostly it is the L1 who gets. Obviously, if you compare steel with concrete, steel will never succeed.
Exactly.
Obviously, it is unless you change the mode
Policy.
in a policy issues. Either you make mandatory in certain infrastructure project to have steel, or you talk about the life cycle analysis, life cycle costing. Today all the contracts are based on only the initial construction cost and the durability and the performance. Nobody talks about the carbon footprint. Bring in this carbon footprint in the decision making process, you will see more use of steel, and that is how we have to increase this consumption of steel.
I absolutely agree with you. There are many countries who have done that, but I think it's
another, just to supplement, it is not the steel versus concrete. If you really see the available material around, that we have and the demand, you will always find that there is no substitute to concrete. Concrete will always dominate.
May I?
But it is a add-on.
I think, steel versus concrete, you have to stop. Also, we can discuss that in the forum.
Mr. Bobby,
can I add, Dian, can I add one thing? Well, no. What I say is that what has been talked about, our president, INAE Patil Sahab said in the morning that don't use any unparliamentary language. So I'll remain within the parliamentary language. Now, the lady mentioned very nicely that NHAI, the procurement process and everything, even in the EPC, the contract says that you may use this, you may use that. But these are all may. It's all may. So therefore, obviously, the contract doesn't go into the may. He will remain only his thumb rule. And that's what happened. There has to be a kind of contract preparation where sustainable material should be the first choice. It should be given the first choice. If it is not available, go for other. So that is the way the policy should be drawn, and that's how things will work out towards sustainability. And that's what is my suggestion.
Professor Sikdar, the thing is slightly different. No, there are two types of projects. Projects being funded by the government of India or Indian, and the projects funded by the outside people like JICA or whatever it is. In Mumbai Trans-Harbour Link, I was involved for 3 project reports, starting from 70 till 2000, and we recommended, because at that time Mr. Bongir was there. They didn't allow any time to use steel because of the marine environment. And all our projects, all our alternatives were on concrete, both in situ and precast. Now what happened when it was finally adopted? It was funded by Japan, right? And Japan, they wanted to have a span fixed to their technology. And they used here, Mr. Bongir was up, nobody objected for using this steel, right? Mumbai Trans-Harbour Link. You didn't allow to use steel structure in Mumbai because of the marine environment.
Now, Dr. Roy, at that time, probably the 550 grade steel was not available, and that's why it was not permitted. Now it will be permitted. Material availability is also a point.
Please.
So, anyway.
Contract has to be changed because what JICA wanted.
Don't wait you just speak. Yeah.
Yes, so one of the things that comes in mind that we are all talking about, we are doing a lot of research, a lot of people here are working in infrastructure and sustainable materials, but still there is hesitation in being utilized. So one thing that is to be considered, that whatever codes we are using for building, they are actually very much obsolete. We are using codes which were written 50 to 60 years back, where there was a lot of natural aggregates present, and we are still looking at that standards. What thing that needs to be considered is, if our research is so much advanced and we are doing research every year, and we are doing new materials are being established and new materials are being innovated and introduced, then why not to constantly be using our codes also and then modifying them also. So then we'll be having standard for those materials which are being now produced. So that should be actually considered, that there should be a modification in the codes also. So the people who are now utilizing it for construction will be having actually some standards that yes, these materials can be used. That is one of the point.
Along the discussion of steel, concrete, again, I have a very humble submission, in the sense not literally to the major capital infrastructure, because there are other ancillary infrastructure also. So steel consumes nearly 2 tons of carbon per ton of production. Cement consumes 1 ton of carbon for 1 ton of production of cement. As against that, bamboo basically absorbs 1 ton of carbon as against 1 ton of production of, so it's fundamentally a negative carbon footprint. And in our presentation, we'll be showing one building as a whole construction as a negative carbon footprint construction, which is possible. And again, coming back to my previous submission, just one state in Northeast produces nearly 28 lakh tons of bamboo per year. And the only issue is that because that single pole is not in the DSR rate, the constructions are not possible. And again it's related to the scalability aspect. Prefab, precast construction with bamboo are also possible. So that is a humble submission. Thank you.
Okay,
Yeah,
I think now,
no,
just please. Now, see, we have exactly 1 hour, and lunch would be ready exactly at 13:30. And before that, we have 6 presentations. So my suggestion is, we have already exhausted ourselves in discussions. Now let's quickly go through all the presentations, preserve your questions. During lunchtime we can discuss, and after that also we are meeting, if you allow.
I may also add,
please,
that very interesting discussion has taken place.
That's right.
Some very new ideas are coming.
Correct.
But if after we see all the presentations,
correct,
some of these questions will be already automatically answered. So I think it will be a good thing.
Yeah, I think let's run through all the presentations now. Hegade sir, are you ready? Yes, please.
He's been ready.
Actually, I can't see him here.
Yeah. Thank you very much, Dr. D.N. Singh.
Sir, you need not to thank me. You have to thank INAE.
Yeah. So I'm going to talk about, like the environmental impact as well as the life cycle analysis. Regarding the environmental impact, most of you people are aware of it. And I'm just going to sort of put into a perspective so that I can stimulate the thought provocation. That's the idea when I'm talking about the environmental impact. I'm telling you the life cycle, so many discussions have taken place about the commercial aspect of the various kinds of products, and life cycle analysis is the only tool which is available perhaps with the policy makers to implement the sustainability in their procurement processes. I'm going to demonstrate that in my presentation, as you people can see it. It's not working? No, I think it's not working, is it? Okay, next slide, please. I don't want to say next slide, that's why I just wanted this anyway. And basically this particular slide is, most of you people are aware of it, as when I'm talking about the environmental impact, I'll have to talk about it. As you can see on the left hand top corner over here, basically the carbon dioxide concentration in the environment started increasing in from the pre-industrial era, that is from 1900 up to 2018. Correspondingly, the global average mean temperature also from 0 degrees centigrade to 1.1 degree it increased. And the manifestation, as you can see on the right side, in terms of the changed precipitations, the extreme events, so many extreme events that all of you are aware of it. And Professor Parida has spoken about, like this, the financial outlay on various infrastructure sectors very much in detail. It worries me quite a lot because, like the way you have almost around 1.1 lakh crores altogether, I could see that financial outlay you have predicted. If it really happens, what will happen? Because already, if you really look at it in India, 52%, according to my calculation on the right side, the 52% carbon contribution to the environment is coming because of the infrastructure sector. And on the left-hand side, you can see almost around 42%. That's why nearly around 50% is attributed, carbon contribution, carbon footprint in the world is attributed to the infrastructure sector. So we engineering fraternity and civil engineering fraternity has to do something to combat it. It's quite obvious. Next slide. So in India, particularly if the environment impact analysis which has been done for a transportation sector, especially for the bridges, which you can see here, in my opinion, almost around 1980, basically this the climate change effects started taking its toll. That is demonstrated by the study of Dr. Garg et al. And in his study of the bridges, particularly of the failed bridges, he comes to the conclusion that 90% could be because of the natural disasters as well as the material deterioration. And 80% is because of the natural disaster, as well as 10% is because of the material degradation, basically. That's almost around 90% can be related to the climate change effects, as you can see here. Next. And what are the climate change effects which lead to this climate change risks to the infrastructure? Climate change, temperature and humidity, warming seas, rainfall shifts, sea level rise, extreme flood events, and severe cyclones, snow cover changes, wildfire and droughts, secondary seismic and wind risks, and landslide and avalanches. All these things have been already taking place, especially you can see in the northeast as well as Himalayan terrains, subterraneans. I think it has been manifested quite obviously, and that leads to the risk to the infrastructures like material degradation, geotechnical degradation, heat-induced risk, long-term deformations, cover risk, landslides and avalanches, foundation settlement, drainage capacity overloads, wave and impact, wind impacts, floods, cyclones, and collision and accidents, as you can see here. Some of the combative measures sector-wise which can take, next slide, can be seen here. That is implement integrated water resource management, establish integrated coastal management strategies, strengthen hydrological forecasting systems, enhance monitoring system, foster transboundary cooperation, especially with China and Pakistan. I think perhaps it's necessary for us to have some sort of an understanding if you have to combat with the climate change, upgrade it and climate proof for the coastal mountain environment, incorporate climate resilience, reassess hazard zonation maps, develop robust early warning systems, improve disaster preparedness plans, mainstream multi-hazard risk assessment frameworks, etc. Some of the, like the expected outcomes by implementing these combative strategies have been, enumerated on the right side. Because the paucity of the time, I'll not just go into that. Next slide. And also, as far as the code is concerned, as I said, I suspect that the climate change effects has started taking its toll since 1980 in India, because of natural disasters as well as the material degradation which are taking place. So the most of the codes, in my opinion, is not the climate adapted design codes. Basically, most of the codes have to be recalibrated on the load factors on the action side. Many of the actions have been intensified. I think it's necessary to really recalibrate the load factors on the action side, and to account for the material degradation, perhaps even the safety factors on the resistance side, also it's necessary to recalibrate. I think in my opinion, there are a lot of, actually we are conducting this particular, like the conclave here in IIT Mumbai. I think the institutions, technical institutions have got a lot of research work to do, in my opinion, to recalibrate on the load factor side as well as the safety side, because I personally feel the codes are not climate adapted design codes. It has to be changed now. Otherwise, we'll be in problems. Apart from some of the combative measures which I have explained earlier. Next slide. So that was all about the life cycle, the impact, environmental impact. I say that the life cycle cost analysis is the only tool which is available with the policy makers to implement the sustainability causes. Basically, when you are talking about the life cycle cost, we are not just talking about the life cycle economic cost. We are talking about the life cycle economic cost as well as the life cycle carbon cost. When you combine together, we talk about the life cycle cost. As you can see here, life cycle cost is a key tool for achieving sustainability, durability, and performance-based design. Without the life cycle cost analysis, it's not possible to implement even in the procurement processes unless it is specifically said the life cycle cost analysis has to be made and your quotation has to be based on the life cycle cost analysis. It is very, very important for us to implement that. Next slide. When you are talking about the life cycle cost through this IA infrastructure forum, we are trying to make it simple, life cycle cost analysis. What we are doing is, on the basis of the life cycle stage analysis for the carbon footprint creation, similarly, we are trying to calculate the life cycle economic cost. As all of you are aware, it is around 100 years. That is called the use stage and end of the life stage. After the 100 years service life, end of the life stage, that has been represented by the module C here, C1. And module B1 is the use stage, as you can see here. Circularity stage, basically it's represented by the D. That is where the residual value cost, extended service life cost comes into the picture, and we just account for it. And there are three types of the cost. One is the capital cost, second is the operational cost, and the third is the user cost. I think what we have done is we have aligned with the carbon life cycle stages here. That will be capital carbon and the operational carbon as well as the user cost carbon. It is very easy for us to life cycle economic cost on one column, life cycle carbon cost on the other column we can put it, and for the different modules we can just compare where we exactly stand. That's how the calculation of the life cycle economic cost will be done. Next slide. When you're doing the life cycle, this is just the same thing, like that I have represented in other form. Basically the product stage, the capital cost, product as well as the construction process stage, capital cost is created. User stage, up to the refurbishment, use, maintenance, repair, replacement, as well as the refurbishment, capital cost is created. Operational energy, operational water, other operations during the service stage, operation cost is created. In case of a transportation projects like bridges, it is the user cost, the user utilization cost, what we can talk about. End of the life stage, because of the deconstruction, transport, recycling, disposal, the capital cost is created. That's how it is created. Once all this is done, say for example, if you have got a steel, I think you have got a residual value of the steel. The scrap is there, and that you can use it as an input credit. And also if the project infrastructure project has to be discontinued before its service life. Say for example, in case of one of the bridges in Patna, after 40 years it has to be replaced, superstructure has to be replaced, and for that like the replacement cost has to be done, and the extended service life will be there. That also comes in the circularity stage, as you can see here. Next slide. Presently, we propose to use the net present value and the discounted cash flow approaches. I think it's very well known. I don't want to get into the deliberation of that. Basically, the life cycle economic cost is the summation of the life cycle cost that is C0, cost of the module A up to the construction before the use stage, cost of the module A, and the Cn is the cost, future cost in year, cost of the module B and C. Module B is the user in use stage. Module C is the end of the life stage. So basically, that is where the future cost is calculated. In the future cost, we will use the discounted cash flow, as you can see here. Next slide. The discounted cash flow rates, presently there is no single prescribed national discounted rates available. NABARD has a proposal that is called the social discount rate, that they suggest 3.72% from the base year, and also the Niti Aayog study on the basis of the general the study sector differentiated rates, it proposes 6% for the 50 plus years projects, infrastructure projects, and below 6% for climate change mitigation projects, where already it is there. That's what it is suggested. That's what our infrastructure supports. This proposal approach, we propose that. Next. Now the life cycle carbon footprint. It is similar. We have got various life cycle stages. Instead of capital carbon, capital cost here, it will be a capital carbon. Actually, at the different stages, we work out what is the carbon created, and the use stage, what is the carbon footprint which is created. End of the life stage, what is the carbon footprint created, and then we come to the circularity. If the components, say for example, the steel is used, then you will get the input credit for that. Whatever is recovered, that we can use it ultimately. And also, if the recycled aggregates are used, I think again the credit will be given while calculating the life cycle carbon footprint, as you can see here. Next slide. Next slide. I don't want to get it. It's the same thing, like what I explained to the life cycle economic cost. Similarly, life cycle carbon footprint calculation, and also. Then comes, I think we'll have to convert this into the monetary values. Basically, we'll have to convert. There are two ways of converting into the monetary value. The carbon footprint created can be converted into a social cost, and also carbon footprint will be converted into the monetary value by multiplied by the carbon pricing. Basically, when you are talking about the social cost, because of the carbon footprint calculation, there will be health impacts, there is the loss of the biodiversity, there will be a climate adaptation cost because of the climate resilience. I explained how the climate resilience measures can be taken. That will incur a cost that will have to be calculated, and a water stress and the productivity decline that has to be calculated. These are all the social cost. If it is not available, social cost is available, you can go for the carbon pricing. In India, right now that there is no carbon market. I think carbon credit, somebody talking about, Niti Aayog suggests the shadow pricing. You multiply the carbon footprint by the shadow pricing and convert it into a monetary value or the economic value, basically. That's what it suggests. That is basically what it gives is the economic cost of the emission is converted into the monetary value by multiplied by carbon price. And the shadow carbon price which has been proposed by the Niti Aayog is as it is. As you can see here, up to 2,450, 7,000 rupees, and also in terms of the dollars it is given 85. So now carbon emission, carbon footprint is converted into a economic value. Now finally, next slide, finally we come to this, life cycle cost analysis. Life cycle cost is equal to the summation of life cycle economic cost plus the life cycle carbon cost. So it is very simple. If this life cycle cost analysis concept is used actually in our procurement processes, just imagine, suppose say for example, if you are using the recycled materials, you using the bamboo, say for example, the carbon factor of that is very less. When you convert into a monetary value, total life cycle cost, that comes, even though the economic cost is higher, the bamboo, or say for example, if people are saying that this construction and demolished, material is costing more, that's why it's not used. This concept of converting that into carbon footprint into a economic value and convert to a life cycle cost analysis, if it is imposed upon, if it is forced upon in the procurement processes, and that should be on that basis the quotation has to be done. I think it's a way to achieve the net zero, what we are talking about, and there is a need to do a lot of climate resistance, climate resilient actions to combat the climate change. I have explained earlier, and also particularly, come back, Colonel, particularly this particular model which I have given, there is a strong need to work for the climate adopted codes and standards, which is lacking. Actually, the climate change effects have started taking its toll since 1980 itself. That's why we hear from this. Earlier days, we used to design bridges and used to last for 100 years. Nowadays, whatever we are doing, it is not lasting for 20, 30 years. Mind you, could be one of the reasons could be the material degradation as well as the disaster which is taking place of the climate change. That also could be a contributing factors. I think that is this is where I take the pause. Next slide. Let us save our world for posterity. Thank you very much.
Thank you very much. Now, Alok ji, 7 minutes.
Yeah.
We have discussed already enough on this topic, please.
Yeah. So, can I have my slides, please?
Yeah.
Yeah. Oh, thank you. Okay, so we have heard number of eminent speakers, and that made my job little easier because some of my slides are already explained by eminent speakers like Mr. Hegde as well as Professor Bhattacharya. So next slide, please. So this is the broad, next slide, please. Yeah, so this is the broad outline of my presentation, very brief presentation. First, the need for building robust and resilient infrastructure, and what are the enabling climate resistant planning, design and construction for infrastructure, and a brief conclusion. Next slide, please. Next slide. Next slide. Yeah. So the first and foremost, let us understand the need. India has signed an agreement, Panchamrit, which is a 5-point climate action, which is based on the SDG 17, which was in COP21. And if you note, 4 out of these 5 commitments are ending in 2030, and one is 2070, that is net zero. If we go through in detail about all these 4 commitments, the first one, India will reach its non-fossil energy by 500 gigawatts by 2030. This is, as per current situation, it is easily achievable. Maybe we will achieve before 2030. But the other 3, India will meet 50% of its energy demand by 2030. India will reduce the total projected carbon emission by 1 billion tons. And by 2030, India will reduce the carbon intensity to less than 45%. All 3 are challenges which, if we want to fulfill, it would require commitments from civil and structural engineers. Our design and construction practice have to include these, and it is a gigantic task. Next slide, please. I think this slide, the construction industry is responsible for almost half the global carbon emission. We have heard this in previous slides as well. So for sustainable development, even the identification of the carbon emitters, the quantification of that, and ways and means to reduce the carbon is a challenge which I think must be reflected in our codes and standards. This slide also, I think Mr. Hegde has deliberated quite in detail. No, please keep it there. Previous slide, please. Yeah, so what the current codes and standards are definitely not climate adaptable, as Mr. Hegde mentioned, and the codes and standards have to change. And in this regard, I must mention that we can take recourse, or we can take help of development around the world. Internationally, the FIB Model Code 2020 on concrete has addressed majority of the issues related to concrete, And I think our Indian codes, be it BIS code or IRC codes or IRS codes, they can take a lot of things which has been internationally practiced, the things which are important for us. And after all, you see, the practice is very much influenced by the codes and standards. And as Professor Bhattacharya also mentioned, that in material also, the new innovative material, if you want to bring it to practice, you have to get it through BIS. So unless and until we actually increase the pace of improvement of the codes and bring this into practice, in real industry will not be able to sort of follow, because after all, any infrastructure project, you have to follow the codes and standards, and any departure from the codes and standards will have a lot of resistance from getting it approved. Next slide, please. Now, what you see, if you consider from the sustainability perspective, all our requirements stated in the codes and standards and practices and specifications can be put into these three pillars: social, environmental, and economic performance. Mr. Hegde deliberated in great detail about the environmental performance requirements as well as the economic performance requirement, how important is life cycle assessment and life cycle costing. Even on the social performance level, there are a lot to be introduced in the codes, directly or indirectly. So all whatever is mentioned here in red, they needs more emphasis in the improvement of the codes and standards. Next slide. So technical challenges in design, in short, traditionally we have been taking these into account. Next slide, please. But what we need additional consideration to account for sustainability are following. I don't want to read them, but it is very clear that the climate change, increase in the loads in bridges, there has been significant increase in the loads because of the change in the Motor Vehicle Act, as well as otherwise overloading, man-made hazards. We are seeing the impact in recently in Uttarakhand, in Kashmir, and many other places. Locations with harsher environment, need for longer service life. Today we are talking about 200 years design life from durability considerations and life cycle considerations. Shorter construction schedules. We have our planning for Vikashit Bharat means 2047 we have to be a developed nation, and almost the construction pace has increased, and this has also been reflected in many accidents that we are seeing during construction in our sector. And then the concept of design for reuse, recycle, these sustainability concepts, they have to be brought in the practice. Next. Now let's come to the enablers. What is the enabling climate resisting planning design? Next, please. So basic framework, conceptual framework for climate change and mitigation is given over here. We have many challenges which are put as a limiting factors, but the mitigation and adoption strategies are given on the right side, and primarily these are the broad bullets on which we have to work in the industry. And next slide, please. So let's go by the mitigation and adoption strategies. First thing is the green energy, and mainstreaming green energy will reduce AOD, which is a major trigger. And of course, out of these, can you keep it back, please? Out of these, I think India is doing a lot on the solar energy, on the wind energy also, and also on the geothermal and small hydroelectric power. I think there is some progress. Next, please. Yeah. So in terms of sustainable building materials, there are many innovative materials which we are discussing. Today also we have discussed. Many input we have received from the audience. This list is only growing, but these have to be actually well researched and put in the BIS code to bring it into practice. Next. Regarding the high-rise living building elements, high-rise buildings are there in urban infrastructure. We are seeing a lot of growth in these high-rise buildings, which can reduce the loss of biodiversity. And we have also been seeing living building elements which can facilitate the adaptation of plants, animals, and species. What you see in this are some photographs taken from Tokyo, which I visited in the month of May, and I was amazed to see this kind of infrastructure at 13th story of a building. It looks like a ground floor, but it is actually up above, and you can see that another vertical garden in high rise. Next slide, please. About the innovative design and construction methods, I think I will be able to address some of the concerns raised by Ms. Alpa. She talked about, we are building things which are perhaps many. I mean, we are using or having many buildings which are not used, lying vacant. So I think the optimized use of material is the most primary requirement, and I think the consultants and this fraternity needs to influence the clients also. Many a times we need to influence our clients to convince if certain things are not required, infrastructure is not required. I think we have to bring it, flag it, and whether we can reduce the quantum, whether we can build it cleverly and build it efficiently. All these issues will definitely bring down the carbon footprint. Next slide, please. And this is a step further. In the initial stage, at the planning stage itself, you have to do maximum kind of thinking to ensure that the impact is maximum. As you grow, as you go from the planning stage to the design stage to the construction stage, your opportunities to reduce carbon footprint keeps reducing. So therefore, this slide shows very beautifully as to if you, at the planning stage itself, if you really think about the project and sort of explore whether this project itself can have an alternative route. For example, I have seen many flyovers which we sometimes wonder as to is it required. You are only shifting the problem from one crossing to the next crossing. So the build nothing is the first concept that needs to be discussed. Many a times the projects are political in nature and we really need to convince. The second is build less, maximize the use of existing assets, optimize assets operation. Alpa was mentioning about many buildings lying vacant. And if you have to build, when it comes to the design, you have to build clever, design in the use of low carbon material, streamline delivery, and minimize resource consumption. And in the construction, you got to build efficiently, embrace new construction technologies, eliminate waste, and make a safe construction. Next. And then about the sustainable disposal of recycling and used waste, I think there are many eminent people sitting here knows more about the waste management than me. So I think next. So to end my presentation, I would say there are 4 R's to be followed in planning design: refuse, reuse, reduce, or recycle. I think we follow this concepts. I think we can do our job as a carbon reducer. Next. So durable structures require adaptation of service life design, integrated design and material innovation. Continuous monitoring and proactive maintenance extend design life beyond 200 years. Innovation in material and technology will push the boundaries of structural longevity, like ultra high performance fiber reinforced concrete, CFRP, cathodic protection and long life coating. And today the civil engineering and structural engineering is a multidisciplinary activity, and this is key to success. We can't practice in isolation. We have to involve many stakeholders. Thank you.
Thanks so much, Alok. Just one quick thing. I was bang on with the 20% efficiency. I'd just given a number, but you proved that you can get maximum 20%.
My request is that we are only 32 minutes away from the lunch. That's more important than the discussion now. Okay, let's go to the friend. Yes, please. Pradeep Kumar.
4 hours was really wonderful. The 4 hours. Yes.
One, Professor Singh, can I speak something?
No, sir. Lunch is there. Please.
No.
1 hour lunch. No. Let's Pradeep Kumar. Yeah.
It will not be a long one. Now,
sir, just a minute.
My
Professor Khan,
presentation.
Professor Khan, please. Lunch is there. 1 hour lunch we have kept. Okay. Yeah, Pradeep Kumar, please go ahead.
Yeah. So, good afternoon.
Yeah, over lunch we'll discuss.
Yeah, good afternoon all. Actually, my presentation has 2 presentations, so I need that much time.
Choose
so,
one of them.
Dr. Pant's presentation is also there.
Choose one of them.
So, yeah, let me start. So, what I'm going to speak is, promote the use of sustainable infrastructure. What are the policy recommendations? That is the main thing what I'm going to spend time. So around 10 minutes, 1 minute of philosophy. Just wait. So a bit of philosophy I want to give for 1 minute first. So what is policy? Policy we call in Hindi as Niti. So that has 3 parts. One is Ardhaniti, second one is Rajniti, and third one is Dharmaniti. So these all three nitis revolve around wealth and well-being. Okay. So first one is Ardhaniti, it is about economics. Second one is Rajniti, that is about governance. And third one is Dharmaniti, which is about rightful utilization of the wealth. So that means we have to keep everything in mind when we are producing, creating something, maintaining, and finally when we are disposing it off. So now what are the policy recommendations for that? Those are the things which I am going to touch upon. So now next. So fiscal incentives, preferential bidding, regulatory measures, and finance incentives. So these are the things which I am going to touch upon. Next. So as you all know, click. Let full slide. Just wait. Next. Yeah, just wait. So as we know that construction sector is major consumer of raw material. So that means it is meeting the demands of human being, and which is having now the very high carbon footprint. So we ourselves set as a target that net zero by 2070, and through this SDG 2030 goals. So what, like from past many years have been feeling that in SDG 17 there are 17 goals. One goal need to be added, which is the most important thing, that is SDG 18, that is sustainable human being. And in bits and pieces it is added somewhere, but as a standalone goal, sustainable human being, because सारे फसाद की जड़ वहीं पे है. Next. Yeah, now coming to what are the measures, policy measures. As I said, to build a resilient, inclusive, sustainable infrastructure ecosystem, we need these 4 things which are policy level decisions. Next. Yeah, so fiscal incentives. So first is tax. So how do we encourage, say a person or a firm is using recycled material, sustainable way of designing. So what kind of tax incentive we are giving? So that has to be spelled out very, very clearly, because finally thing come to be economical, L1. So what we need to understand is L1 doesn't work. So we need something new term we should coin, that as S1 or something like that. Next. Yeah, next. Yeah, and then like we need to promote this a lot in tier 2 and tier 3 cities where it is slightly easier to do it. Okay, encourage recycled aggregates, low carbon cements, bio-based materials. But how? Through subsidies. Next. Yeah, and then this creates low cost credit support system also to be introduced. So to build greener construction ecosystems. Next. Yeah, coming to the other second item, that is preferential bidding. So what is a preferential bidding? If a contractor is using all the sustainable way of procuring the materials, utilization. So that contractor should have an edge over the other contractor. So that is very, very important. So this brings to the reforms in tender processing. So that has to be worked out properly. Next. Yeah, and then before that, pre-qualification and standardization is very important, otherwise it is not going to work. So BOQ templates have to be prepared and people have to fill, companies have to fill in that only. So especially this can be tried in, say, smart cities, PMAY, metro projects, all these things. Next. Yeah, and then align with Startup India and Make in India goals. So these things have to be introduced and encourage competition beyond cost. This is what I was talking about, not L1, S1. Next. Yeah, and then mandatory disclosure about the total carbon footprint in the entire life cycle. So LCA tools for accurate footprint measurements. So these templates have to be worked out and they should be robust and integrated. Next. And then, yeah, BIS, I have a few more slides, I will talk about that. So material passport and standard, track, this we need to track. Say something like a state in south is sourcing material from say 2000 kilometers. All that has to be included in how much energy and how much carbon that is using. It doesn't it should not allow that I am wealthy, I can use any amount of I can emit any amount of carbon. That should not be a valid thing. Yeah, and BIS should create such kind of standards. Next. Yeah, then next one is this certification expansion. It has to encompass all these things. Okay, next. And then the fourth one is this financial and insurance incentives. So we need green finance, we need to include that, and low interest rates for the certified green projects. So if somebody wants to take loan from the bank, it should be reduced. Loan means interest should be reduced. And then we need to introduce green bonds, and then SEBI should promote these things. Next. And also the last point, just go back. Yeah, just wait. Yeah, the last point, this sovereign green bond framework to state level projects. Presently it is central level projects. State level projects has to be introduced. Next. Yeah, and then insurance risk guarantee and enhance the bankability and the investor confidence. Next. Yeah, so with this, so one is physical reforms for greener material and cost competitiveness, and then preferential bidding. Next, create like demand driven markets, and regulatory and certification framework ensure standardization to create a level playing field. And the last one is improve the bankability and reduce risk. So this is my first portion. Yeah, go forward. Next. Yeah, next, I'll spend say 2-3 minutes on the standardization, which is actually on behalf of Dr. Sanjay Pant, who is Deputy Director General, BIS. I am making that presentation. Next. Yeah, so we have a lot of categories, means categorization of all the building materials. This is alphabet wise. There are many, 20 plus materials are there all. Go to the next one. Yeah, go to the next one. Yeah, so these are all material categorization. Next. Yeah, so now, see, these are the standards available for major building materials which are in recycled in nature. One is fly ash. Actually, this fly ash, when say government asked fly ash should be utilized some 20 years back, there was a resistance like current sustainability. But now fly ash is almost adopted everywhere. Maybe maximum fly ash, maybe 90%, more than 90% we are using fly ash is actually not available also. So demand. Now what is going to happen for this sustainability is maybe in next 10 years or 15 years, we'll get used to that. But what I am thinking in future something else might come is inconvenience cost. Because of this large infrastructure project, how much inconvenience we are causing to public, it might come. And that also slowly we need to integrate into it. Because large projects, when they are happening, there is a lot of inconvenience to society. And generally, means downtrodden people will be more affected, then wealthy people will not be that much affected. So maybe these kind of things might also come in future. Now coming to fly ash and slag based cement, gypsum byproduct, all these things standardization is already done, but only thing is popularization of such standards we need to make from our side. BIS anyway doing its bit. Also we need to take this and penetrate into the community that these standards are already available. For example, recycled concrete aggregates, IS 383 is already available. So it is giving provision for that. Next. Yeah, so like hollow concrete blocks, lightweight aggregate concrete blocks, stabilized soil blocks, standards are already available. Next. Yeah, NBC, in NBC that part 11 is approach to sustainability. It is a elaborated, it has already given lot of things. It's already more than 1 decade. So this chapter is in existence and it is now getting revised. See, Suresh ji is working on that very much. Yeah, he will, yes, next. Yeah, go back, last one. So some new building materials and technologies towards addressing sustainability, that is LC3 cement 18189 and packaged dry mix concrete 18685, biodigester 18150 and packaged sewage treatment 18797 and geosynthetics. So various standards are available. Now what is important for BIS is presently large number of many committees are academia participation is lot, so industry also need to contribute its bit for development of these things so that we will have our standards up to date. Presently many standards are getting revised, they are up to date, and then we need to take these standards into public for its right utilization. So with this I would like to stop here. Thank you.
Thank you very much. Now we can hear from Mr. Suresh, please.
I did not come with a structured presentation like all of you. I thought we had to just talk, but in any case, for you to get the idea, if somebody can load that, I'll try to go through like a bullet presentation. After Hegde's presentation, as well as Saab's presentation, which was so beautifully done, Bhattacharya's presentation, as well as Pradeep's presentation, mine will be a follow-up on that. Mine is to talk on sustainability and net zero goals in a very large way. All the SDG 2030, everybody knows what's all the goals there. Also, we know a commitment to the COP. We are now no more net zero carbon at the level of 2050 as developed world are, or not 2060 like China, Saudi Arabia and Vietnam is doing. We have put our goals towards 2070 because our country, while developed countries' population is dwindling down, negative growth is there. We already increased 100 crores to 145 crores in the last 20 years. So we're going to build the housing, build all the infrastructure required for that new population there. So therefore, we have kept it at the level of 2070. That's one aspect we should know that. And we already have the provision of the National Building Code 2016. So I just try to put some area before I get into those particular one which will be now brought down. I'll take a minute more to talk. The National Building Code 2016 version and the latest 2025 version just been finalized. Work of nearly around 22 committee members, 22 panels, around 1,300 experts have worked on that to bring the National Building Code 2025. Lot of thrust on the climate change agenda has been brought. That's the good news. While sustainability was put as early as in 2016 there, wherein life cycle costing was put, but then as Hegde's are put in over there, you can't just stop at life cycle costing, has got to take during the operational period of the thing of the life of the particular period. Very rarely incorporated so far. They only talk of today, the type of cost that is involved there. And also the Energy Conservation and Sustainability Building Code is another document equally important, which is also brought out this year. The environmental impact assessment by the Ministry of Environment, Forestry and Climate Change, which is where all the EIA clearance comes over there. So all these regulatory documents have got to be put together. And of course, the wonderful work done by the Alpa's team on criteria for design, earthquake design by Dr. Murthy, or wind load from Ravi Chopra and the team from here. So all those things are all undergoing change simultaneously in the year 2025, including tall buildings on which they are working on. I just thought I'll give that background in a very large way. Just to also give a reply, incentives already have come. If you really go green in a very large way, green building and green built environment, not only building, infrastructure will cover not building, but green, it's called the built environment to come, including all the infrastructure, the roads, bridges, flyover, bypasses, metro, all will come together in the built environment sector. Large number of states already have given additional incentives into the 5, 10 or 15% of additional built up area to be provided, water tariffs to be brought down, or the energy tariff to be brought down, etc. Green financing also has come as a reply, 1% less for loans which are taken for housing and building and other projects, if that is going the green path on that. So just to give a little background. Now, I like to rush through the particular one. Can you just put it on, sir? Most important thing is we have always been doing on in terms of the greenhouse gas emission, only working on 1 and 2 so far. We have never worked into scope 3. It's very necessary for us to understand that as builders and developers and engineers and architects and all that, we have only been covering what is under our control. We never used to worry. As long as a good structural engineer give me steel, concrete, I'll do it. Nobody is worried about the steel is going to have so much amount of carbon, cement is going to have so much amount of carbon per ton of it, or glass and aluminium and ceramic ware. Does not worry at all in the minds of either the architect or the civil engineer or the structural engineer. Let's understand that. Today the situation here, it was not a concern. Embodied energy of the building material was not the concern. That will all come under emission, scope 3 emission. That you produce, where you produce that particular building material it was never taught. You only be taught how to design a good structure on that, how to construct it, how to complete it, how to commission that. It was never a mind concern of anybody in the mind, including the institute. Just now only after the climate change agenda, which has come in a large way, discussion of COP25 to COP30, suddenly this new animal has come into the picture, namely embodied energy of material. How much amount of energy that will go in the production of steel, glass, aluminium, plastics, ceramic ware, all the building materials that are there, they are guzzlers of energy. We have only been worried about the operational energy of the building, namely how to save on lighting, how to save on air conditioning, how to save on lift installation, all are operational energy. We never got into the embodied energy of the material. Therefore, one first thing that you should understand is that we never so far worked on scope 3, we worked only on scope 1 and 2. Please kindly go forward. So since my theme was sustainable net zero, there are 4 major areas. One is to do on net zero energy. While green building by itself takes integrated energy management, water management, waste management, by each building that are rated either under Graha or under IGBC will bring 30 to 40% energy saving, around 30% water saving and waste management efficiency, and also make it green. So you get either a silver, a gold or a platinum rating, or a 3-star or 2-star or 4-star Graha rating. But net zero energy is an ultimate where you are trying to get into all the energy requirement for the particular building. The idea is to bring in the net zero energy component by designing the lowest energy demand, high energy efficiency to be brought in over there, and then also balance to be done by renewable energy in a large way. A lot of step-by-step approach has been identified, enhancing the energy performance through approach or passive and active design. Architects does it, engineers does it, the structural engineers does it in the maximum over there, and adopting strategies to maintain the most important thing of comfort level condition, and then renewable energy, how we can bring in. If we can have the whole of airport of Cochin, today they want about 38 megawatt of energy required, they produce at 54. So all the energy required for that big airport project is met entirely for renewable over there. So we have a large number of initiatives where net positive is going to come in, net zero energy component coming, and that can come through on-site renewable energy project, power purchase agreement, as well as procurement of green energy through various other methods. So a lot of inputs are there, a lot of benefits that are coming are phenomenal there, including the over 50 odd projects have come on net zero energy only. In addition to normal certificate of building to cover water, energy, waste and all put together, that is integrated. So this will be an exclusive one only on the energy segment that's coming over there. So it's a very useful particular goal to do that. Of the order of around 264 kilowatt hour of energy offset is coming as a result of that. The next component is going to be on net zero water. Water is one of the most important component there. While water utilization in terms of rainwater harvesting, aquifer recharging, wastewater recycling, very rarely done. Primary, secondary, tertiary treatment, recycled water to be used for not only for flushing purposes, very rarely used over there, to use it for air conditioning water, construction water, landscaping water. In fact, like Singapore, 100% of the wastewater, sullage and sewage is recycled. 100%. No Indian city has got that. Now, that's the type of level you have to get into it. So they're called, don't even call recycled water. They're called as a new water. NEWATER. W being common for new as well as for water. So new water is an approach towards 100% recycling of water, and the water is recycled to a level with the right level of BOD and level for which then that can be utilized in a very large way, including of course the desal water with a substantial amount of water there. So this is a very major area, including that will cover a series of initiatives, including water conservation methods that will be done using the type of fittings and plumbing fixtures which are later. And I told you integrated water management system there, and alternate water source to be done for treated water, and series of initiatives there. That's how a building will get a net zero water rating. Zero liquid discharge is the mantra that has got to be adopted in a very large way. How do you do that? We can do maybe at a campus level of an IIT with such an amount of space. You have control over everything, but individual buildings may not be able to do it, and cities can do in a very large way. Now, cities have to convert 80% of all the water that is being given is becomes sullage and sewage. We do not have recycling of the water in a big way like 65% of Chinese cities do it. Whole of Israel does it. I told you just now the good case of Singapore does that, except for Bangalore, a small initiative for recycling for a small segment. About 16 mgd out of 80 mgd of water is now recycled on a small segment, and the recycled water is being given for various use. So we need to do that in a very large way in the case of water management. So benefits are phenomenal, as already known there. Of the order of around 20 odd projects have already come there. And the next major is net zero waste. So after net zero energy, net zero water, next one is net zero waste component. Very rightly brought out by the 4 R's, whatever. Now this will cover all spectrums of the waste component. The idea is zero waste to go to landfill. The whole idea is that. Here, everywhere, your topics, everywhere you think that waste is there, go and take it to a sanitary landfill. Your landfill available, go and dump it over there. Don't even give it as a proper sanitary landfill by layers and layers and all that. Just dump it over there. That approach has got to change into a very large way. Ma'am will be particularly interested because that's your area of interest there. Net zero waste, so whole elimination will be there by a multi-pronged approach of nature-centric design, reducing debris. C&D waste becomes an equally important component. Construction demolition waste alone can be a major component. We thought only biodegradable waste and degradable waste, hospital waste, electronic waste, and various other wastes are there. C&D waste is also very, very major component which requires to be utilized in a very large way. And how do you handle those waste and transport it and have the particular recycling plants to come becomes a very, very important energy. Here also waste to energy, a lot of good initiatives. I discussed with many people in this room itself. There are about 4 or 5 people who are doing major initiatives on converting the waste, including the refuse derived fuel to be done with fuel pellets to be made out of that, and then also to use waste to energy into a large way. Good examples are there, people sitting just around the table here, and that's going to be a wonderful initiative. India requires major initiative of this major formula: refuse to resource, and trash to cash or trash to treasure, and waste to wealth. And this should be a type of a mantra that has got to be pushed through into a very large way. Now, a lot of good initiatives. Maybe we can't get more than 4 out of 10 in any global initiative of a clean, green city for any of the Indian cities. See, Indore is good. Surat has done some good work there. Lucknow has really, this is a very good effort. coming from 41 level down to number 3. So there are some cities which have done phenomenally good initiatives to deal under this particular area. So this is going to be net zero waste is going to be one. That will bring us to the fourth major component on which is the most difficult job. Others are all easily. Net zero energy can be done. It is done all under scope 1 and 2. Net zero water can be done, net zero waste can be done with a little amount of effort, design and a good strong will. But net zero carbon, as rightly brought out by Hegde Saab, it is just not the issue of the present current level of energy being used over there. You're going to talk into the root cause of embodied energy. So when everybody is committing, when Europe is committing, America is committing, they'll do net zero carbon by 2050, and we said we'll do 2070. Embodied energy is very, very important, and that's 28%. 28% is on the manufactured material. No structural engineer wants to touch it. Architects don't want to touch it. He said, that's not my baby. As long as you give me the material, I'll design and give you a good product. But to say, how do you do that? You're given an answer, sir. How do you make green steel? The new things come in green steel, green cement. So that means in the manufacturing processes of each of the material, either cement or steel or glass or aluminium and various other products, or using industrial waste into new building product, from fly ash to thermal one into fly ash for one, or fertilizer factory phosphogypsum into the new products over there, aluminium factory red mud to be used in the new building products, etc. A lot of new products are coming over there than the conventional, the waste to wealth transformations happening. So this is going to be a very difficult area. Now, very rightly brought out, Saab said mandatory disclosure. Very interesting point that is brought out. Mandatory disclosure of carbon on a project. Europe is already doing. No project can go for approval to any authority, a building planning approval or infrastructure approval people, unless the amount of carbon that is going into that project. So they should know the amount of steel, the amount of glass, the amount of aluminium, and the amount of all products that has gone over there, and we know the amount of carbon that goes per ton of that each one of material, per square meter of the development or per length of a kilometer of a road. They got to give a disclosure. You will not get an approval for that plan unless this disclosure is given of carbon over there. Now we are talking for the first time, no more energy of real carbon amount of the material used over there. We are way behind. What I'm trying to say is, American Society of Civil Engineers, American Institute of Architects, they are all working simultaneously. How do we achieve? We are in 2025. By 2050, what type of reduction come? We can use the material effectively, efficiently, economically, by the best possible design. The best structural engineers can do all those particular things of rationalizing the design aspect in the best possible way. Consumption level can be brought down. That's already happening. How much per square feet or square meter of the construction, the steel level, all things can be brought down. Even though you're making a passionate case to do more steel for making GDP to increase over there, that's how it is mentioned. That's another aspect. The steel component to be introduced as a larger level for construction, as against it's the Calcutta versus Mumbai acting on the steel was predominantly Burn, Jessups and Braithwaite team work, whereas concrete was 40s, 50s and all that, whereas concrete was what was coming from this side, but it's a combination of both material, including composite construction. Whatever it may be, it's about roughly of the order of 21% of all the construction is incidentally cement and concrete, sir, it's just construction. About 9 to 10% is the steel component that's going into the whole construction level. So we can reduce that to some extent, but more important is energy level. I like that particular figure. 2 to come down to 0.6 is a very major issue. If that itself can bring down the carbon component in the production of steel. Similarly, I'm very happy and proud to say all the cement manufacturers in India, globally I'm telling, the amount of energy required or carbon footprint coming out of cement production, India is now the lowest, because all of them have really evolved a series of initiatives to bring down the carbon footprint. Something like steel has happened. I just thought you should, I'm sure you have the information. Yeah, you are aware of that. So these are all, that means many things are not under your control. not under the control of your architects or engineers or builders or structural engineers or the infrastructure builder that Saab is talking about, because he has no problem. He has got the steel, he has got the cement, he has already indicated in the beginning of the meeting. But that's the conventional one. But for such a major projects amounting to tons and tons of that, how do you get all the cement manufacturers and steel manufacturers and all the other aggregate manufacturers, very major area, how they can come into it becomes an important component. So therefore, we'll have to really achieve the building code 2025. You'll be very happy to know for the first time has got into all the net zero goals which has been beyond part 11 on sustainability, including waste circular economy component. They also try to give in the issue on how do you bring embodied energy. It's not going to be an easy thing for practicing architects and engineers to say that you cannot use. It's not that saying don't overuse it or use it effectively, efficiently, economically. That's a larger message that's going over there. Of course, we have 45 years now from 2025 to 2070. But how do you do in a phase-wise manner? Possibly what would be as a recommendation that's going to come Singh Saab is that we should have an immediate phase in the next 2 to 3 years time, a short-term phase up to 2030, a medium phase up to 2050, and a long-term phase of 2070. How this embodied energy of the common wish for which you are hearing for the first time. If you ask, she has given the figure of 26,000 structural engineers. Am I right, man?
It's okay.
Uh,
Am I right? And you have about 11 lakh civil engineers. And you have 1,35,000 architects. You ask them embodied energy building material, not even 1% or 2% will be even aware of the particular thing. It's not even their concern.
Okay, I think Mr. Suresh will have to stop here for the sake of brevity. What we'll do is, you should talk to my research scholars. There's a big team of people who is working on
Not a problem.
energy transition, and because you are here...
Not a problem. Net zero carbon is not an easy thing, because since your topic was sustainability and net zero goals, it's an area where all have to work together with a very big multidisciplinary approach to be done over there, and the presentations done by both Hegde Saab as well as Saab has done very well. Thank you.
Okay, now let us listen to Jiwon Chun. Can you hear us?
Yes, I hear you.
Okay, please continue. Take 7-8 minutes and let us know about what's happening in India in the name of, World Smart Cities. He is the director of World Smart Cities Initiative.
Thank you. Okay. Thank you very much for inviting me to this valuable event today.
Information.
I'd like to share with you about the Smart City project being promoted by our organizations called World Smart Cities Forum, based in London and New York. Currently, I'm in South Korea due to my family concerns here. So what we're doing right now is we actually building up the Smart City projects across the continents. We designed the Smart City project for the first time back in 2015 in London, which was called the Cognicity. In other words, it can be translated as AI Smart City in London at the financial district in the eastern side of London. But at this, after that, we also designed a smart city in South Korea and Ukraine before the wartime, and also in Africa and the Middle East. So we actually focusing on some areas, basically prioritize energy, property, technology, mobility, and healthcare, waste and water, and utilizing the cross-validations on technologies and services and solutions.
Even here.
As we discussed, I just just saw a little bit about the presentations earlier. We do focusing on the circular economy in it. Can you just, the next page, please? So we have a contract with the municipalities together with the central government of the country. Then we building the two different types of the projects. Each project is called Twin Cities, where 16 metropolitan cities around the world joining these programs. And another one is called ASCA, Africa Small Cities Alliance, and basically Africa Small Cities and Townships Alliance, which is really important for the countries like developing countries in Africa and India and the Middle East. So we're trying to, regenerate the reasons how they can actually maximize the values of the life as the citizens in the township. And at the same time, we're working on the tech sandbox. I'm going to actually mention about the collaborations between PSA Office of India, principal scientific advisor to the government of India. They actually have some programs called the Mantan and RSPC, root tech programs, and from the Prime Minister's office. And we're basically collaborating with them at the moment. So we're trying to engage Indian solutions and technologies from the labs or universities and combined with the South Korean one and also the US and UK, and deployed in India and African projects is called ASCA. And basically, we're also engaging some of technology commercializations transfer. In short, we say technology transfer like Israeli model. And some of the companies, they will be very successful by participating in these kind of projects as well. And the next page, please. So our concept is a human centricity, because most of the conventional way of building up the small city is about technology centric or building centric. But we don't believe that kind of the way. We put the people in the first, and we're trying to utilize the city and infrastructure, how we can provide the solutions and services from people. And you can see that later on. So back in 2015, I mentioned we designed the AI small city in London. Next one, please. And we nurtured about 350 startups internationally back then. And some of the very successful companies graduated from these programs. You can see that easily the name eToro, Revolut, BlockDocs, and TransferGo, TransferWise as well. And they became very successful. Some of them they become unicorns. And also the South Korean government named as the master planner for the South Korean governmental driven smart city projects, which was a $6 billion project in Busan. And I was a master planner there. And the major thesis and themes is basically water. So water, how to utilize the water into the city. But this is a greenfield project. So we're trying to utilize the water as a one energetic and principal the models to support the smart city. Next one, please. And 1 year before the war started in Ukraine, the Zelensky government, we had a contract. It's called the Ukrainian Smart City National Project. So we started from Lviv and Kiev and Vinnytsia. So we were basically working on the projects with the municipalities in Ukraine. Unfortunately, the war started there, and that's why Twin Cities project was basically born based on Ukraine. Next one, please. And then 2023, 2024, we opened discussions with the Indian municipalities starting from Uttar Pradesh and Mumbai. So they have multiple projects in it. But some of the programs we are actually interested in is how we can transform the city as a net zero driven and also the technology driven cities, because you need to have a showcase. Because Mumbai is, getting bigger and bigger. At the same time, you have a lot of issues and problems in the city, like Delhi. Every time I visit Delhi and Mumbai, my health was not really good because the air pollution is getting worse. And so you need to rethink about how to design the city and how to bring the kind of the values into the city, because you need to develop city much more valuable to the citizens, the stakeholders. So we're basically building some kind of conceptual model, starting from some of the spot from Agra in Uttar Pradesh and Mumbai. It's called the Origin Smart City in Mumbai. But we basically prioritize sustainable energy solutions and mobility and AI-driven governance and green spaces and artificial channel, which is water. And the residential, industrial, IT is kind of zoning process is a little bit different way, but it'll be very successful and very impactful for the cities in India. Next one. Yeah, so Mumbai project is something like already smart city I mentioned earlier. Next one, please. So now I'm going to talk about ASCA. The ASCA is Africa Small Cities and Townships Alliance, but the role of India is very important because we prioritize the reasons connecting India and Middle East and also the East African side. It's called the Indian Ocean Belt. So even though we're talking about Africa, the role of India is very important because we are bringing a lot of ideas and solutions and technologies from the IIT, for example, or second tier, third tier universities throughout Bhutan that PSA's office actually is prioritizing right now. So the twin city concept is how we nurture the Indian entrepreneurs and techpreneurs, individual startups or something. We can actually, those scattered ideas and the resources, we can put it together for the purpose of utilizing them, their ideas and their tech into the city. So we have a showcase, for example, like I mentioned, the Mumbai and Uttar Pradesh. There will be some kind of tip of the showcase of the city, how this city can show to the world, and this will be the right choice of the municipalities and government can maybe spend more money. So tech cluster, we are going to go through the R&D level and to the commercialization. So everything is actually happening alongside with the projects smart city in India as well. Next one. And of course, AI data-driven smart city is a key because a lot of money coming from the developed countries like Korea, Singapore, Japan, EU, and United States, they all bring in the pockets of the money, how they can actually just access to the AI data centers and solutions and services. As an example, service solution experience for the stakeholders and citizens, we basically maybe starting with the water and waste. And I just saw that a lot of people talking about the waste, landfill, and net zero, everything. So that is the kind of platform we can actually have a showcase there. Next one, please. And the environment-friendly city in India is, I think that will be very, very valuable as the Indian government perspective. Next one, please. And some infrastructure is kind of required, but you can actually benchmark something kind of already deployed in the developed countries, but at the same time, the Indian government and municipalities, they need to see something different way as a platform, like a new kind of for the future generations infrastructure. As an example, the Elon Musk ideas about the, can you just go back to the previous page, please? Yeah, you can see the last one is called the Hyperloop kind of things. That will be maybe reduce a lot of energies and also cost, and that will be kind of examples we can display. Next one. And so triple helix model is absolutely important. Most of the cases of smart cities is basically based on the triple helix model. In India, I know the Indian government is very important, but at the same time, you have to open the doors from the other countries already done many different things. I probably strongly would suggest the UK and Korea and probably some other, the countries as well. And industry, of course, is very important, but the startups and corporations, you have to have open door places like, for example, if you have 1,000 companies, so that you can actually test them. And one of the great models, solutions can be provided, implemented in the small city project in India. You have opened the doors from overseas as well. And academia, of course. I know the IIT is very valuable universities, labs in India. At the same time, IIT can collaborate with some other, renowned universities and labs. But probably maybe in UMDP, UM6P in Africa, or maybe KAIST in South Korea, or maybe Seoul National University, MIT. Then through that kind of model together, we can actually have a showcase of how we can nurture the Indian-based startups working together with international tech companies and SMEs. That will be actually happening in India, and also the project will be done in Africa under the name of ASCA projects. Some of them you can actually see maybe the Indian-born unicorns from Delhi or Mumbai, even Chennai. So this is kind of the attracting model to attract more investment or maybe grants, utilizing EDCF fund or ODA fund from those developed countries as well. Next one. So yeah, we have a lot of themes, but some of the themes we are going to specify some kind of the models priorities and for each one of the cities. And for some of the models for Mumbai, another one is for UP, something like that. Next one. So yeah, this is kind of our next focus. So from Africa to India. So this is kind of the future market, and also the future infrastructure should be built. And what we're trying to do is we are going to attract more, the fund or grants, and also the attention. And so what should be done in here? Because a lot of people mentioned about the net zero, the ESG or something. So everything should be done, should be built from that point. And some kind of master plan should be required. But also, if you actually travel to Africa, you can see that kind of maybe the low level of technology level. You can see it. Sometimes they need kind of high qualified models, the technology level they require. So we need to bring some of the ideas and solutions from Indian side. And so this is something that we're trying to do. Next one. That's it. So I think it's more than 8 minutes already. But if you have any questions, I'm happy to, speak to you.
Thank you very much, Peter. I'll pass on your email address to everybody here, and then hopefully they'll interact with you. You can invite them to attend this Kenny seminar, which you are organizing between 10 to 13th of September. I can pass on that invitation to everybody in India.
Thank you.
Okay, thanks a lot. Thank you very much. So I think with the permission of the chair, we'll close the session. the one who is sitting behind you. Okay, so we'll close this session now. Thank you very much for cooperating with me and keeping the pace of time. Shall we meet at 2:30 sharp? 45 minutes lunch break. You can leave your belongings here. The room is quite safe. Lunch is arranged outside this place. We can come back at 2:30 and then start the second session.
you.
So good afternoon, everybody. Shekdar Sahab, Mr. Shekdar, please be seated. Shekdar and Shekdar both. See, we are already 3 minutes late. I hope you enjoyed lunch. Hopefully. Thank you very much. And those who are online, I'm sorry I could not offer you lunch. But whenever you are in Bombay or IIT Bombay, please do come and give us an opportunity to host you. So, with the permission of chair, can we start? They have to decide who is the chair. Professor Prem Krishna. Patil Sahab. What I'm saying is, with the permission of chair, can we start the second session?
I think morning we agreed there is no chairman of the committee. Everybody is addressing to you, so आप chairman हो अभी.
I am the most common worker. Anyway, so I think everybody is there. Thank you very much for assembling after lunch. Now we are going to have a rapid fire session in the sense, session in the sense that we will be presenting. There are 36 presentations and I don't want to disappoint anybody. I hope you'll agree with this. So with this spirit, what we will do is, we will run through the presentations and please note down your points. At 4 o'clock around, if we get time, we'll have some sort of a discussion. Then there's a wrap-up session from 4 to 4:30, which Professor Shekdar is going to lead. That is the time when you can speak out your points, suggestions and comments. And 4:30 we wish to close the session. Because for Bombayites, it's very important to leave the campus by 5 o'clock. Because today is also Visarjan, and unless they leave the campus at 5, it will be very difficult for them to travel in the city. So thank you very much. You are ready? So you just start from the first one and keep scrolling, and the presenter, if he or she is here, just raise your hands. Who is the first one? Mr. Jan. Yes, please. Yeah. No, we have everything here. So we'll keep on moving the slides. And wherever you think is pertinent and very, very important point, you can just...
Well, I have prepared a few vanilla slides without any picture, without any graphics.
Sure.
So just to highlight the subject,
please.
I just want to highlight one fact that India is generating huge amount of solid waste, right, which can be recycled into marketable products. So just to give a rough idea, the urban areas, in Mumbai, in India, are generating something like 62 million tons annually of the municipal solid waste. Of that, is that my presentation gone, Dr. Singh? Okay, sorry. So it says a rapid fire. I thought rapid presentation. Well, So out of the, if you see Mumbai generates about 9,000 metric ton of waste every day. Of that, about well, okay. So go to the next slide, please. Yeah, so this we all know. Go to the next slide. Now, I was just mentioning that we have to get an idea about the waste which is available for processing, recycling and marketing, so that we can reduce the carbon footprints, right? Now, in order that to happen, we have got a national policy. We started off with solid waste management rules 2000, post that plague in Surat, etc. And that is the time I got associated with the subject. Now, in 2014, I would say a landmark policy development took place in the form of Swachh Bharat Mission. And what the Prime Minister did was to kind of bring it on the forefront, the subject of solid waste management. The solid waste management rules 2016 and the other allied rules, they do provide for waste recycling and sustainable waste management, not only of the pure municipal solid waste, but also plastics, e-waste, biomedical waste, and C&D waste. Now, they all talk about the sustainable waste. Next, please go to the next slide. So when we say sustainable waste management, is based on circularity and zero waste approach. Of course, we don't have, the refuse idea is not there, but to reduce, reuse, and recycle. And today the new concept emerged was refuse. So we should avoid creating waste itself. Next slide. Now, we all know, and this is being propagated through different rules, through practices, through technical presentations, that whatever is the waste available, it's either biodegradable, which can be composted, or it can be vermicomposted. It is open to anaerobic digestion, and which, through anaerobic digestion, we can generate CNG, which can be used for cooking and other uses. Next, as far as the non-biodegradable materials are concerned, everything can be recycled, can be processed and recycled. So plastics into recycled pallets, road material, plastic, lumber, etc. Paper to new paper, metals can be melted and reused. Steel can be reused, we all know. Glass cullets can be used for new bottle. C&D waste, I'll particularly highlight this aspect. It gives us aggregates, bricks, paver blocks, etc. My point is, just to stay on this slide, though everything is doable, is it really happening? That's the point. And where I think there are a few gaps. One is that I would say there's a technology gap. Because whatever we are doing, whatever material, recycled material is being generated, I think it's far more inferior to the virgin material. That is the general impression, which I also partly share. And I personally feel that we have to have some kind of addition of the either virgin material or some kind of supplements in order to make them compete with the virgin material. Next slide, please. Now, I want to highlight on this particular aspect. Now, why municipal solid waste is not being managed properly in our country? Even in Mumbai, you can see waste littering, every corner, etc. So one of the reasons is that though waste, every component of the waste can be recycled, it's not happening because it's mixed waste. Segregation is not happening. And despite almost 20-25 years of the first rule that came into existence, hardly 50% of the waste is being segregated, and that too is segregated by commercial organization or large societies. So end of the stream, we get mixed waste. If you go to Kanjur site or Devnar, for that matter, the waste which is coming from different wards is highly mixed waste. Can there be a technology answer to segregate the waste at the end of the tunnel? It's not a proper solution. We should have segregation upfront, but that's not happening. We have waited 25 years. So can we use some kind of, highly sensitive optical segregating machines, etc., which could pick up waste by color or whatever? I think I'm told that there are technologies available, but either they are too expensive or they are just not there in the country. So that is where I'll request the researchers at the IIT Mumbai to guide the policymakers. The enhancement of recycling technologies, now for example, RDF is being made by Antony Waste. but it can be only used as kind of a raw material for the waste to energy. It cannot be used in other industrial furnaces. So can some upgradation be done so that these RDFs or pellets could be used for other furnaces? Even for thermal power plants, it cannot be used. NTPC is using some RDF, but then it is only from agriculture waste, not from the municipal solid waste. If that could be done, I think waste management will be far easier. At the moment, RDF is being transported from Mumbai to all the way to Karnataka in different cement, factories. But the transportation cost is huge. So it's a loss-making item. So can we find an answer there? Ensuring the quality and competitiveness of the recycled products. Now, currently we have two waste recycling plants for C&D waste in Mumbai. They are generating soil, they are generating aggregates, and also making sand. But is that sand comparable with the natural sand? The answer is still no. So maybe, as I said, that is the first point which I wanted to highlight, is that we need to do a little more research in order to make this product, competitive. I've already talked about this thing, upgrade RDF. So this is what I thought I will highlight, and 2 points now at the end I will highlight. One is there's a good case for technology intervention or technology integration in segregation and in improving the quality of the recycled product. Unless and until that happens, I must say that people are not going to accept it. Recently, I was attending a workshop somewhere, and it was on sustainability and participation of the community. One point which came, and which was a beautiful thing, somebody said, for promoting sustainability, we have to address 3 stakeholders. One is, as they say, Samaj, that is the community, which community also includes different consumers. The second part is that we have to address Sarkar. So, Samaj, Sarkar. Sarkar is there in terms of making regulatory, decisions. They have to make it mandatory to use the recycled material. At the same time, organizations like BIS, they are doing, you have to prescribe the standards for the recycled products. So the participation of Sarkar is extremely important. And the third point, which is very important, was Sanchar. So Samaj, Sarkar and Sanchar. You have to communicate. So whatever we are discussing in this hall since morning, I don't know it's known to the world outside. Even in BMC, where I worked for 4 years, almost 20 years back, hardly anybody will be knowing that this kind of technology innovations are happening. So we need to interact with the different communities, including the government, the policy makers. And last point is Bazaar. So Samaj, Sarkar, Sanchar and Bazaar. Whatever we produce has to be sellable. It has to be commercially viable. Otherwise, you may say, then we should use products which are net zero types, but as a consumer with limited resources, I won't be inclined to do that. So that's the whole problem. So ultimately, at the consumption level, it has to be competitive. So if we could address all these 4 factors, all these 4 stakeholders, I think we can head towards sustainability goal much faster. Thank you.
Next. Thank you very much, Mr. Jain. We'll move on to now the second presentation. Alpa has left. So the third one. Dr. Nouri, please. You can cover Alpa's points also as a structural engineer.
Good afternoon. Whether it is bridges, railway stations, urban planning, barrages or houses that were built during the British era, they have faithfully served us. Sustainability seems to have been natural to all the stakeholders of that era. If some buildings have become dilapidated, often it is due to unscrupulous alterations and additions. Now, it is not easy to trace the reasons for the steady decline in the quality of civil engineering structures that we observe today. We must learn lessons from the existing infrastructure, maybe bridges, stormwater drains, sewage drains, etc. These structures were generously dimensioned. Sadly, no one bothered to maintain them till they began to suffer damage. Next one. Next one, please. Yeah. Now, the stormwater drains were large enough, having faithfully met the demands of the increasing population for several years. An unwarranted increase in the floor space index resulted in the larger quantity of stormwater flowing into the brick arch drains. Consequently, the drains were damaged at a few locations, and the existing manholes such as were too small, unclogged using pumps, but such drains could not be retrofitted, but the manhole was woefully inadequate for lowering the graniting equipment. The Municipal Corporation of Greater Mumbai invited bids from the contractors that included their design proposals. Such works may not be spectacular for the layman, but of primordial importance to all of us. Next slide. The increase in FSI has resulted in traffic congestion. The roads were widened by reducing the width of the footpaths. Unlike other cities, Mumbai has an excellent rail and bus transport system. Today, our city has become a home for car owners. This is not sustainable. New Bombay, conceived in 1965 by Shirish Patel, Charles Correa, and Praveen Mehta. Their thinking was about decongesting South Bombay. They were ahead of the times. From 1965 onwards, many tall buildings came up in South Bombay. Finally, New Bombay began taking shape in July 1970. So, we have ended up with more flyovers that would accommodate bigger cars. Next slide, please. In 2019, 10 bridges were declared unsafe by experts, and bids were invited for reconstruction of these bridges on a lump sum basis. We visited the site, the Juhuzara Bridge. Previously, it was raining very heavily. We observed that the rainwater was flowing freely without flooding the neighborhood. This is just a 3-span culvert. The bridge was constructed about 47 years ago. Stone masonry piers and abutments were resting on hard rock. Now, the bridge was even load tested, and yet the bridge has been demolished. This is certainly a good example of wasteful expenditure with no regard to sustainability. Next slide, please. See, most engineers today have no interest in preserving and retrofitting old masonry bridges. We have over 10,000 railway bridges that are still in use. Some may need retrofitting. Every country has many old bridges. There are thoroughly documented guidelines that are freely available. Now, the Tilak Road Bridge in Dadar, most of us know in Mumbai, built in 1925, that spans across both western and central railway lines. This bridge is a lifeline for both commuters and vehicles. Now, retrofitting steel bridges is much simpler than retrofitting masonry bridges. Whatever it is, it was not even attempted, I think. It may be unfair for me to say so, but then at least the best solution would have been to invite proposal for retrofitting this bridge without disrupting the traffic. Unfortunately, the new cable stayed bridge that is being constructed by using the existing bridge as a base for erecting the new one. So even the width of the footpath has been reduced. This bridge has become even more congested than earlier times. There are many accidents happening even today. Next one, please. Another example, Malabar Hill Reservoir, known as Hanging Gardens, is about 120 years old. It was constructed in 5 stages, and they're all built in random rubble masonry. Sometimes the roof was a multi-span plain concrete arch, and so on. I won't go into the details. And, some structural engineer was appointed. The conclusions of the structural engineer, he used some software, are based on brazen, unscientific thought process. Even the NDA test confirmed everything was in good shape, and yet it was declared unsafe. Now, it is well known that lime mortars are inert. Unlike cement mortars, the roof and pillars were also in good condition. So we could conclude that the 5 tanks were generally in good condition. Some routine repairs were required at few locations. Since they are below the ground, they are not subject to weathering like those old bridges. The matter is still hanging in air. Next, please. Another problem that in our city has faced, it's a long story, I won't go into that. After all the mills closed down, the huge amount of land was available in the central area. Now the proposal was the landowners could keep 1/3 of that area, they could do whatever they want with it. 1/3 would be given to those people who are working there for their housing, and 1/3 will be used for community centers, sports grounds, schools, and so on. Unfortunately, this proposal did not come through. Instead, they gave 2/3 of the land was handed over to the mill owners. Now, and the rest of them to Slum Rehabilitation Association called SRA. The outcome was several high-rise multi-story apartment buildings with very little open space that have been come up, and the residents of the lower stories could never see the sunlight. This adversely affected the indwellers. It's obvious that we have no concern for the slum dwellers who must commute to their place of work, and schools and hospitals. That's all. Thank you so much.
Actually, you should write down few important points and pass it on to Professor Bhattacharya, Alok ji, and Mr. Hegade. I think that would be very good because you are raising very important issues. Thank you. Anand? Yeah.
Hi, good afternoon everyone. My name is Anand Ghadge and I am representing Normet India. I'm heading specifications for Normet. Since morning we spoke about buildings and bridges. I am going to take you to tunnels now, and we have some sustainable tunneling solutions available with us. Available with us, and there is an interesting case study that we did nearby from here, around 6 kilometer from here, which is Sahar crossover case study, where I'll go get you through those case studies. You will be
okay. We'll manage.
Yeah. Next.
Next.
I'll skip this. I've already introduced Normet. It's a Finnish organization with 60 years of experience in tunneling, mining, and infrastructure solutions. We manufacture equipments, construction chemicals, and services of those equipments. We have our head office in Delhi NCR. The carbon challenge in tunnel construction industry, you'll be amazed to know that at this point of time, total length of tunnel under construction, existing tunnels and planned tunnels is around 3,600 kilometers. Around 60-65% of tunnel is with irrigation and hydropower. Remaining 30% is with railways and metros and other road transport organizations. So what are the carbon challenges in tunnel construction? The conventional RCC lining is very concrete oriented. It requires a lot of heavy rebars. Thick sections are designed for existing linings. There are formwork waste also. We know that per cubic meter of concrete, around 300 to 450 kg of CO2 is emitted, and steel is also a major contributor in carbon emission. So if we calculate around for conventional tunnel lining system, around 15 tons of CO2 is emitted into the environment. I think the number is more than that. It is on a very conservative side. So what do Normet have to replace this conventional system? Next. So this is the system that we have implemented and executed at Sahar crossover, where we replace the secondary RCC lining with a sprayed concrete lining. So you can replace the existing steel reinforcement with a steel fiber reinforced sprayed concrete system. So what are the advantage of that? It's a very fast system. You don't require all the big equipments and gantries or continuous large labor is not required for this. Simple machines can spray this thing onto the surface, and The next advantage is the thickness of the section, entire section. Conventional system, if it is around 400, 450 mm, so we can reduce it up to more than 30 to 35% thickness can be reduced. So you can imagine the amount of concrete, the amount of steel that we can save in by doing all these things. The table at the bottom, you can see the amount of concrete saving in that project. Around 36% saving was done with the new design, and CO2 emission was reduced by around 23%. And the entire system was designed by Normet and our partners. We have executed this work for Mumbai Metro in association with J. Kumar. It was, and I'm glad to share with you that it is the first successful PSCL K1 execution in metro projects in India. As of now, there are no execution done like this in India. Next. I'll give you the details of those. So this is, I was talking about, around we can reduce the sections. We have thinner section, almost 25% thinner section, because you don't require continuous big equipments, gantries, shutterings and all. So you can quickly execute this job. Around 40% faster construction. CO2 reduction was 23%, and the most important, the contractor or the government authority were interested in executing this project was because of the cost saving that we projected. And after implementing this project, the actual cost saving for the contractor was around 1500 per cubic meter of saving was done for the contractor. If you see the amount of concrete, it was around 90,000 cubic meters. So you can calculate the amount of amount that has been saved by the organizations. And durability wise, we have designed this system for 120 years of durability life. These are some of the pictures. So this is the first excavation, and you can see the first primary lining, which is common in both the systems, conventional and this. This is the unique waterproofing membrane layer on the first primary lining, which this is called TAMSIL 800. So it's Normet's product. It's a EVA membrane, spray applied EVA membrane, followed by the secondary lining of TAMSIL 800. So it bonds with the primary lining as well as the secondary lining, and on the left hand side you can see the secondary lining, which is permanent sprayed concrete lining, which is admixed with steel fibers and various admixtures. It was a very and the final finishing layer with the fireproofing layer. It was a very challenging job because the execution was at Andheri, Sahar crossover, and J. Kumar's batching plant was at South Bombay. So we have to design the concrete mix accordingly so that it should not set, it should have the proper workability. And my entire team was there at the site during execution, during QC control, and right from the design stage to the execution stage to the handover stage, the entire work was under Normet's Normet. So this sets the benchmark in sustainable tunneling. So we want to replicate these kind of work in ongoing and upcoming tunnel projects in India, because it supports net zero and circular economy goals of India, as well as we want to have a wider adoption in metros and railways and highways and road tunnels, as well as other tunneling projects in India. We have a good technology record with the globally available in the industry, and there are various global standards also which are available, which are supporting this. So we have designed this by taking European standard as well as British standards, which were considered during designing of this project. We would be happy to get in touch with any of you who are interested to know more about this. We have our manufacturing unit at Khopoli, Jaipur and Howrah. So you all are welcome to visit our factory and to know more about this kind of solution. One more thing which I want to highlight is that we, Normet as a company, supports sustainable practices. So we are also working on, we have collaborated with one of the company where we are proposing solutions with the GFRP bar, where we can replace the initial steel cage with the GFRP rebars. So and the thin skill lining. So those kind of systems are also there with Normet, including low carbon concrete for buildings and tunnels. So thank you very much.
Nice presentation, Anand, but just a small point. Is the word, use the word permanent not an overstatement? Is there anything which is permanent?
So it is designed for 120 years life, so we should mention that.
That doesn't mean permanent.
And what is the thickness and the durability of this new gunniting methodology as against the conventional one?
So we have designed it for 120 years, sir, and the thickness was reduced to around 300 mm. We can still optimize the thickness, but as it's a government or the metro project, so the authorities were more conservative. But we can have more thinner linings than the 300 mm as
So where
well.
they are implemented, wherever it's implemented, England maybe. How
India,
many years
in India we have implemented,
how many
sir.
years it has stood?
Sorry?
How many years it has stood?
I think it's, I'll have to check, but I think
20 years?
the company is 60 years old. It will be more than, I would say, 20 years.
20 years. That's what we can design for 100 years.
Yes, yes.
Durability, but then
We have some credentials, old credentials with us.
credibility at the end of the day is how long it can.
Yes.
So I think Anant, you should be in touch with GMLR team.
Yes, yes, sir. So we are already. We are
No,
already
no,
in touch, sir.
I just wanted one clarification. You have an RCC liner, on top of that you are spraying it, right?
No, sir. We initially
The photograph is showing some liner earlier. On top of that, you are spraying it.
The system is like initial after excavation you have a primary lining shotcrete spraying. On top of that you spray the waterproofing system which bonds with the primary lining as well as the secondary lining. So we replace the secondary lining which is in conventional system this secondary lining is in-cast situ like concreting work. So after waterproofing they lay the cage and then put the shuttering and then they'll pour the concrete. So this is typically used in NATAM construction, NATAM type of tunneling.
What you should do is
Can I
Show the
add one
photograph. I
should
think you see it
invite,
looks as if there is an
should
RCC
invite
liner.
Mr. Hegade.
Okay.
What is the rock class? Rock
Right.
classification?
I'll get back to you, sir, on all the technical details.
Mr. Hegade, what I suggest is, Mr. Hegade,
It's in Mumbai, so I think.
can you please visit his site? You are doing some work, is it not there? Near is that Puri or something?
It's over now.
Anyway, just take him along with you.
I suggest.
Okay, so let's move on to the next
I
slide.
suggest one thing.
Yes, please.
The Mumbai Line 3, which is the longest.
They are doing.
Right. Okay, you are from Line 3. So it has lot of NATM works. So what I suggest that you are from Line 3?
No, they are from
Anyway,
Jimla, but
so what I suggest, because what you are doing, you can also have a what should I say? You may approach the MMRC,
right,
and you can have different types of activities there too, because each and every NATM had created problem.
Yes.
So their solution, you may go through it.
Yes.
And the lining anyway, it has to be more than one, because it is practically you have to have preliminary lining. So whatever you have shown is good, but one thing I am really very I must thank you. There are two tunnels approach with one net. Am I right?
Yeah, it's a crossover, sir.
Right. That is one of the most complicated issue and is very difficult to
execute.
To continue with the safety works.
Yes,
So
sir, absolutely.
That way I must congratulate.
Yes.
Thank you, sir.
It's really good.
Thank you.
Anand, another Anand.
Yeah, after one Anand, back to another
More and more Anand.
Good afternoon. He spoke about tunnel, the technology, and I think we may have worked together on many projects, because Trimble provides the tunnel guide, the TBM guidance, and then your tunnel. Hello. And the monitoring, the structural health monitoring, and I am happy to say that on Hutatma Chowk section of L&T in this Mumbai metro project, when there was this case of High Court where the structures, they were, people reported that because of the vibration, so Trimble was the company which worked with L&T in providing the, geotechnical sensors and the geodetic sensors and recording that vibration. So anyway, so since morning we heard about a lot on material, and I would say a lot of that was new to me. Yes, people are talking about alternate material. There were discussions around how ministry and NHAI or others can mandate it. So I have some experience around that, and I would be happy to share. So we'll be talking technology, which is at the intersection of the experience that all you have. We don't have that experience, and the data which is getting created somewhere, right? So we are at that intersection, and we would try to combine, integrate. I heard a couple of times this word, integration of the information. So I was a little surprised. Since morning, nobody spoke about the word BIM. Nobody spoke BIM. Information modeling, information management. It could be construction information modeling, construction information management, because while the basics are known, you know that with your experience and the academia, and you are doing a lot of research, but then how do we combine all this information on a project? This is what, probably I'll try to take a couple of examples here. I was telling sir during the lunch that L&T was the first company where we showed on the earthwork for Bangalore airport, where we had doubled the productivity with L&T team. Typically a grader does 1,000 cubic meter per day. And we were able to put the IoT systems and connected devices on that, and the productivity was doubled, more than doubled. I'm saying conservatively doubled, but it was more than doubled there. KV Praveen was the project, the TI head at that time. So we have done similar in the vertical construction also. The India Habitat Center, which was again done by L&T, and the Central Secretariat, where a lot is happening. Even the Parliament building, which Tata Projects did, the verticality of the wall and the smoothness of the wall, that was ensured by the technology that we provided. Now you would say what it has to do with sustainability, so I'll come on that part. So next slide, please. So this is an example, a pilot that we have done with NHAI. We are in the process, because I am taking these challenges one by one. I have spent 30 years now in this segment, and I would say the progress was very slow. I mean, we have not yet seen the tip of the iceberg in terms of the technology adoption in construction. 9 years back, I joined Trimble because somewhere I was only with the software industry, Autodesk, Bentley. I came to Trimble because Trimble provides hardware and the software, design software. Just to give some reference, what is Trimble, because many of you know or not be knowing. Tekla is our product, SketchUp is our product. There are other products also in this space around the building and the structures. And Chenab Bridge was all done by WSP in Tekla. FCons did the construction. Similarly, anything to do with steel or specific structures, Trimble has a role in that. And then we are combining it with the scanning and the robotic total station for the precision layout, because whatever is modeled, you can appreciate different things, alternative materials and other things you can see, and you can see the impact on that model. This particular example we have done with NHAI, because after doing the mandate on machine control that came on 23rd of June, I have shared with you, sir, maybe you can share with others. So 2,000 kilometers of ministry projects have been mandated, and they would be evaluated with the specifications inbuilt. So there is no question of, because even if L1 would be there, L1 would be with that denominator. The specifications are there. The project would be monitored in real time. The data is coming in real time, that what was the design parameter and what is the actual which is happening. Layer by layer compaction, how much thickness of the earth is done, how much compaction he has done. This is for the alignment planning, because most of the times we have heard the quality of DPR, and we have heard the minister, Honorable Gadkari ji, talking in every forum about DPR, quality of the DPR. I think in one of the forums somebody stood up and said, sir, authority भी आपके पास है, engineers भी सारे आपके पास है, consultant भी आपके पास हैं. अगर आप ये बार-बार कहते हो, it doesn't look nice because you are the only one who can make it good. So there are few steps which have happened around this, and when we went to NHAI after doing the mandate on machine control, I said, okay, let's do the alignment optimization and alignment planning. So this is a slide where I'm putting on the planning, and then I will move to the design, and the last would be on the construction. So we have given based on the data that was there, and unfortunately we did not get much data. We were told that take KML file, Google file, take that file. Then finally we said, okay, give us the cost parameters. What is the cost of the bridge per 100 meter? What is the cost of tunnel per 100 meter? Because based on this software is called Quantum. It's Trimble Quantum, QUANTM. And what it does, it is a rule-based integrated system for only road and railways, 2 types of projects only. And what it does, it takes all those parameters into context, and it will, what speed you are designing, all those things it will take, what curve, what is the information, what areas you would like to avoid, defense installations or, other things. You put constraints, and because of, some reasons you would say must pass through this, because it's not about going from A to B, it's, fulfilling those parameters, and it will give you multiple options. And based on this, we can decide on, which are the 2-3 options which are fulfilling those criteria. And so in this NHI project, we have narrowed down on these 3 alternatives. So in the first one, I don't have, because I was allowed to have only 3 slides by Professor Singh. So in alternative 1, it was the number of structures, we optimized it on the vertical alignment. In option 2, which I could not put here, but I have slides, if somebody wants I can show, which was the shortest route, but then a lot of structures were coming. And in the alternative 3, there was a possibility of optimizing the structures, and it was going through the tunnel. And, so it takes into account that best would be to optimize the cut and fill. So the material is not coming from outside. So it will give you all those options. And wherever tunnel is possible, that the best would be that it will give you that option also. And then we can freeze on one, and then do the further iterative. So alignment planning, then corridor check, because then it could be that somewhere there is a temple which is coming up in the corridor, or there are some parcels which are not available at any cost because of some litigations or others. So project delays can be avoided. Now again, somebody would say what it has to do with the CO2 optimization. So by doing that, and by minimizing those things, there are projects where we have been able to save. One is that during the construction, 40% of the carbon footprint. And then there is also a possibility where you can say what type of traffic will flow. So heavy traffic, and then what is your estimation on, diesel vehicles, petrol vehicles, electrical vehicles. So the operational carbon footprint on that particular alignment, how, it does. I have the data on that, and I can share whosoever is interested.
Very good. So what I suggest is, Anand, why didn't you conduct a...
2 minutes or so.
Oh, I thought you were going to stop here.
No. I have just covered planning.
Okay, good.
The second is about the design. Now, we spoke about embodied, carbon footprints, embodied energy. So the softwares, they are available. And I would now mention, it's possible in many software. Let me take Tekla because that's our product, right? It's possible that you can do the carbon, evaluation, and you can do the alternatives by taking the alternative materials. You can see that in the analysis, in the design phase, as well as when you do the 3D modeling of that. And then somebody spoke about communication and collaboration. So it also helps through the cloud, various stakeholders can collaborate, and then it is a collaborative journey to come to a decision. It's not about one guy doing everything. Can we move to the next one, please? This is about the one that is mandated by ministry. It's about the word is AI and MC. If you search on Google North, it would be AI and MC. So it's automated and intelligent machine control across the various stages of a road or a rail project. And you can see there, I would only stop there with that. There, we have, as I said, that we have doubled the productivity on the L&T project. Imagine the project was planned with the 21 graders, L&T did it with 9. Same work with 9 graders, fuel saving was huge. So there was a huge impact in terms of the carbon. And I am all taking the Indian examples. As of now, I'm not taking any outside examples because there is no point there. So in this slide also, if you see, there is a 43% saving in the diesel footprint if you talk about the entire project. Other thing which I spoke about, you can optimize on which are structures, what you want, what you don't want. So there is a possibility of integrating all the information and the experience of the people, right? Now let's come to the next one where we have overcome some challenges. The next slide, please, the last one. The challenges that we are facing and we faced, and चलता है. आप कॉन्ट्रैक्टर के पास जाओ, बात करो, वो बोलता है मैं मिनिस्टर को जानता हूं, मैं हटवा दूंगा, तुम लोगों ने डलवा दिया, right? So we are facing that challenge. There is a huge knowledge and skill gap. I spoke about all that. I don't know how many people in this forum are aware that this is available. So I'll start from here. So there is a huge role of the academia in terms of filling that gap. We are here in India and we are doing all these things, and we have now got the mandate also together. Us, Hexagon, Topcon, all 3-4 MOBA, 4 players are there in that space. We have also identified, because construction is all about measuring. When you do a survey, it's measuring. When you construct something, it's measuring. Thickness of the slab or whatever. I took all the example of scanning, placement and all that. Whatever cannot be measured cannot be improved. We firmly believe, and that goes in our internal evaluation also. I will not get an increment if something is not measured, right? Technology is not used in majority of the infrastructure projects in India. Even if we have put the mandate, कॉन्ट्रैक्टर हमको धमकी देता है, मैं हटवा दूंगा, या अगर मैं 10 ग्रेडर चलाऊंगा, एक पे लगाऊंगा, 9 को मैं ऐसे ही चलाऊंगा. So we are all facing that thing. Adopted under compulsion, not by choice. So that word may will not work, may use will not work. First it has to be mandated, then the compliance has to be followed on top of that. So now we have got our assurance with the member project that शुरू के 3 महीने बहुत problem होगा. We have to do it as a culture development. Maybe we need to work very closely, to take it forward. Thank you so much.
Seminar, web seminar on this, and invite everybody. You take 1 hour. Some other
know how passionate I am about it.
Yes, please do it, because it's a very good topic to learn, and I'm sure everybody will get benefited. Raisa, please take care of this. Okay, thank you. Balraj.
What a waste is not what I say when I look at the waste. So it's the quality and what I can get out of it that does matter to us when we look at certain things. Next slide, please. Basically, our mission is, to upcycle whatever is been thrown away as waste, basically inorganic waste. Now, why to use that? It is basically maintenance proof. It is weather proof. Water absorption is 0. It's bug proof. It's more sustainable. You're using waste. So it's basically what we have been talking all over this morning. And I don't think so I'll be adding anything more to whatever has been said before. Next slide, please. What we are trying to do over here is what we are trying to do over here is where we can use this. The thing is, basically, me being a civil engineer and a geotechnical engineer, I've been involved in the infrastructure industry for, say, not that long, but yeah, a bit of long time. So the thing is, we have been trying to develop a lot of things out of waste. We've not found our ground yet. We have not said, okay, fine, this is the actual thing that we are going to get. And that is going to be the course of our journey. You never know what you end up doing, right? Firstly, we have started our own type of retaining wall, or not our own type of retaining wall, it is just a replica of a timber crib wall or a concrete crib wall, right? But what is new to that? all the plastic waste into it. We are constructing a wall right now in Jalna, so we are doing an actual project. And we know if a wall is 5 meter high, 200 meters long, we are saving somewhere around 40, we are utilizing 40 metric tons of waste. And that is only the fascia element, not the geogrids part. So even that is more efficient in whatever we do. So this is step one. There was a step before also. This is not what, yeah. This is not what we had thought. We were doing benches, then we were doing paver blocks, and whatever we ended up was having properties very good. Then whatever structural properties or whatever properties of concrete and the concrete or the steel structure. We have arrived at a compressive strength of 18 Newton per mm square and a flexural strength of 34, which I guess is very good as far as any beam or any flexural element is considered. Again, we have just started. It's been only 1.5 years, so we have ended up with a project. We are doing it. And it is kind of a journey now that we have begun upon. We are looking for sheet pile walls to be introduced with polymeric waste. We are looking for a lot of other applications that we can be introduced into the market. But then again, like what was discussed beforehand, like the psychology has to change. We have to bring in something which is more effective to the table, right? Price cannot be the factor of choice. It can be one of the factors. But then utilizing it and the carbon credit, carbon emission credits have to be made very flexible. I think my most humble request would be to all of the entire committee and all of the members over here that give it a chance. It's going to be more easier for everybody. The more you use it, we don't know. I guess when DN Singh sir came to the factory, and he asked us what is the capacity of the factory, and I said like 1.2 tons a day. And I said, no, that is not enough. We want like, come on, 10,000, 1 million tons a month. And I was like, even thinking about it is shocking at this point of time for me. But yes, this is the start of the journey. We can go miles ahead. We can go beyond. Any civil engineering application can be done using lumbers, using boards, whatever it is. You can use the joints. You can use it anyhow, right? You were using wood before. You can use these lumbers right now. So it's basically very sensible to go ahead. And apart from that, it is contributing to the society by reducing the waste content and everything. And I think that's it. So thank you very much.
You should have shown some photographs.
Yes, I have it on my phone.
A phone nobody is going to see. You should have presented here. Anyway, so he is a young entrepreneur who has converted the plastic waste from municipal solid waste, landfills, into crib walls. So it's a very interesting technology which he has developed, which has to be promoted and upskilled. You should have shown some. Anyway, send some photographs. I'll share with all of them. Thank you very much.
Thank you.
Any negative issues on the product?
Sorry, sir?
I don't think so. No negative issues. Only thing is he has to upscale it.
Polymer as a material.
Yeah, so he is doing extrusion process.
Yeah. One thing we have observed that.
Shall I start? No, sir. 1 minute. We'll come back to you. Yeah.
One thing we have observed that
polymer as a material.
During the testing of these materials, you cannot get uniformity. So you have to play with standard deviation.
No. You can get uniformity.
But
if
then
he says ill effect, it could be environmental.
Environmental
toxins.
Mine is toxins.
Yeah. So see, uniformity you can get. We have got enough uniformity. Yeah, so toxins are an issue.
Yeah.
For that you have to design special scrubbers. That can be done.
Okay, sir.
So
you should have highlighted that.
Tell one thing.
I can start.
Just 1 minute. I shall take 1 minute. With regard to recycle of materials, in Mumbai there is a big problem because the construction materials in Mumbai are quite high, the demolished material. Now the government of Maharashtra, they wanted to use the recycled materials. But the problem is that in Mumbai, one has to, all the waste they have to, what should I say, deposit outside the Mumbai area. So taking all the garbages to the outside and coming back, it's a lot of transportation cost and hazardous.
That's true.
So it is not being done. Now I had a discussions with MMRC. So what was the suggestion that instead of going outside, so government, if the government permits, that there should be 4 centers, east, west, north, south, so that all the construction materials that can go to one of these places, then the transportation will be less, and screening can be better, and they can use the right materials at the right cost. So because one of the slide I have shown that the competitiveness is a very critical item for the use of materials. So that is what I wanted to.
Sure. Thank you.
Thank you.
Mangivar sir, yes please.
Yeah, basically, you may be aware that Government of India has announced a policy of Jal Jeevan Mission, that every village and every household in a village would be given pipe water supply at the rate of 55 litre per day. Question is whether we can offer a cost-effective solution. So my topic is cost-effective, structurally efficient, and affordable elliptical spillway. This is the design which we evolved in the last 5 years and is being implemented to basically to solve the drinking water problem of the villages. Next. Basically, it consists of, a ellipse-shaped arch to be fixed permanently to the bridge to create storage of 2.4 meter. In a particular village of 600 population, we were surprised to see that the water level rose by 90 feet and people are doing 250 acres of irrigation. It has solved their drinking water problem also. The best part is our cost is 50% of the norms of the storage structure prescribed by government. The cost is also less, and if you work out the irrigation cost, it is 22,000 rupees per acre. In the minor dam, it comes to 1.5 lakh to 2 lakh rupees per acre. Next. This is another case of black cotton soil, where there is a backwater of 1.5 kilometer. People grow harbara because it requires only one watering, and in the BC soil, water doesn't get percolated. And as a result that they got a harbara agriculture produce worth 150 lakhs. So I was so happy that we have just spent 40 lakhs in this structure, and people are getting 4 times of that benefit, not 1 year, 2 years, every year. So this is another benefit of the technology. Next. Basically, these are the advantages of the new technology. Cost of the structure is 60 to 70% of the norm service storage structure. For small natural water, the slope is very steep. As a result, that once the rain stops, the water gets drained off, and it doesn't help the ground recharging. The material required is 60% compared to the cement plug or VR or alternate small dam, which is being implemented by irrigation department. We have developed the precast technology to complete the structure in just 1 month. It can be even adopted where there is no bridge. Bridge is not a requirement. Villages can be made self-sufficient at their own location with the cost of 50 lakh per person, again 150 lakh which the government is spending. We have improved the design, so even the silt would get automatically first line. The PWD has already prepared a standard drawings, etc. They are available on PWD website. The Government of India also has recognized these standard drawings, and they themselves have said it is better to create a storage near the house rather than bringing the water from the last site. Now, for the semi-urban area, of maybe 25 or 30,000 population, they bring the water from the dam, long distance. The result that it reduces the scope of the dam. But there are always some small structure of maybe 30 or 40 meter. If you construct the bridges there, then there is no need to this, and the scope of the dam would increase. So this technology has got tremendous application. The best part is on the National Highway and PMJSY, I repeat, the Government of India has taken a decision. If any state want to do or convert the bridge on existing national highway or the project in undergoing, all the funds will be given by Government of India. MLAs and MPs are very keen to fund this because the question is they can show the result in 1 month instead of waiting for 2 years, because every village is connected by some bridge or the other. What we do, just convert that in a month period, and they can easily show the result. Very beautiful. Thank you very much for giving opportunity.
Bongirwar Sahab, IRMIRI, Indian Rubber Research Institute, they are making now rubber dams. That is the latest. Rubber dams. They are making rubber dams. I think you should talk to them. I'll put you in touch with the director of IRMIRI. Rubber. They go at the side, they just pump in water or air, they dilate it, it becomes a dam within few hours. That is a part of the system. Okay, so let's move on to Professor Manish Kumar, please. Can you please introduce yourself?
Good afternoon to you all. I'm Dr. Manish Kumar, an associate professor here, and I'm pleased to present this technology on seismic isolators that we have developed. This is for structural applications to protect the structures and their component against seismic effects. Basically, if you look at the rural and urban infrastructure in India, and if our past memory serves us well, many of the structures are quite vulnerable to basically the effect of earthquakes around pan-India. And if you look at, even very seismically active areas, I've shown you the view of Shimla town. If you look at and try to imagine what would happen in case of an earthquake, and if the recent history has been of any indication, there are so many pre-shocks in northern India that we have observed. So we cannot even fathom what we could do. What would happen if such one of the major earthquakes actually strike one of these towns. Now, seismic isolation as a technology is well established. There's not something new. But how do we implement in India for mass scale is what we are looking for. And conventional seismic isolators, basically you can see the concept of it. The whole structure is supported on basically multi-layer rubber and conventionally using steel shims, and that allows the vertical and horizontal stiffness. Mostly we import this technology. We have some Indian suppliers as well, but typically one isolator will sets you off by say 3 to 4 lakhs rupees, a typical size. What we are looking for mass implementation, we cannot have such expensive technology because a typical house, let us say 2-story, will use at least 15 to 20 of such isolator. But one thing is well known, that it will protect your structures. Probably one of the most promising and well established technology, that it can protect the structure existing as well as new structures. So if you go to the second slide, we'll look at that what we are looking for the mass scale implementation. What you see here, these are by 2 manufacturers in US. One is dynamic isolation system, which is rubber based, the other is sliding based. And these have been used in some of the biggest structures around the world, especially Japan, New Zealand, US, and all the seismic reactors. The problem is it's very manufacturing extremely complex. The cost is very high. These costs are more than 20-25 lakhs, the sliding bearing that I'm showing you. So the idea is that in India, how we can use for multi-pronged solution, one that is aimed at components and the other that is aimed on large scale structures. So in terms of simplifying manufacturing, making using it for some of the application, for example, overhead water tanks, which lead to significant failure in terms of many of the houses that we have in an urban setting. And then small houses, 2-3 story buildings in even rural setting or the non-engineered construction as well. For that we are targeting. So for the components, if you go to the next slide, we have something which is developed basically fabricated using waste tire materials, in which we take radial tires, we cut it in the shape, and we don't input a lot of energy in fabricating it. So it's not like we are making it powder or doing some sort of things and fabricating something. I mean, overall the energy input is still high in that. So we are just cutting it, and then we are using it with natural rubber, and then making basically that rigid rubber tire which gets stiffened over a time as a reinforcing layer to overall the isolator. And the final product we have tested here in our lab, and the adequate, what I would say that it is suited for small components up to 5 MPa of load. That 5 MPa of load, and the size is restricted for 200 by 200 mm. So this is most suited for equipment, components, what overhead water tanks, small pedestrian footbridges, all those type of things which are more of a smaller or lower requirement. The other that we have been working on is on lightweight high performance isolators, in which basically the overall performance is increased significantly by using some fiber sheets in between. These could be basalt. Right now we are using basalt, considering it's more environment friendly compared to carbon and glass. But for benchmarking, we have also used glass and carbon fiber sheets to reinforce it, and the weight is significantly reduced. At the same time, the capacity is very high. Now the isolator I showed you in the last slide, those are for typical weight more than 2 to 3 ton. What you are looking here is around 10 to 12 kg even for a similar capacity. So that's significantly increased actually the portability, the transportability, the installation, all those things, while keeping the manufacturing process still as sustainable. And with this we are targeting for differentiated applications for different type of structure, which is we are hoping as a technology itself, when we use seismic isolator, your demand on the structure is significantly reduced. So the sizes of the structure in a typical case would be significantly reduced. So that in turn leads to the saving of the material as well as the overall structural, all the other structural requirement. So we are hoping that we are planning to do some demonstration construction on this structure and looking for wider scale applications. This is one of the INAE seminar that I had presented in Raipur, and there we had shown this for because Raipur has a lot of scope of those kind of applications. Thank you.
You can also talk about your innovative solutions for the Indian Army.
Yeah,
ballistic.
I did not include that, considering it is more of a sustainable.
You can just speak about that.
So basically we are developing modular structures. In modular structures for high performance against missile and impact and blast and drone attacks, those kind of attacks, in which instead of, if you look at all the forward areas, there the accessibility and the constructability, all those are a big challenge. Right now what they use the locally available stones to create a gabion wall, and the top they use the normal tin sheet, corrugated sheet, and then they use ISMB sections. Now considering, I've talked to many of these people who are actually doing this. These are by our soldiers only, not there's no trained mistri or other mason or other type of professionals there. Just to carry an ISMB section, which is a large steel section, top of the hill, it's a big problem. So what we are, and that even after that does not provide adequate performance. 1 meter thick of wall does not provide adequate performance. So the challenge we had is that how can we build something that is easy to assemble in the remote site, so they don't have to use the local material. Performance is enhanced. At the same time, the constructability and the erection time is significantly reduced from current around 15 days to 2-3 days. So we did a pilot project on this one, in which we constructed the way that they're doing it right now. The other one using ultra high performance concrete, in which the motor was replaced by the ultra high performance concrete using ready mix. And the third was basically the pre-casted components, each of less than 20 kg of weight, which can be assembled as a Lego block kind of a thing. and still able to provide much higher performance that what the current state of practice therein provides. So they were able to construct that within 2 days because it was more like stacking it, and the interlocking patterns provide higher energy dissipation as well as the portability and impact performance. And we tested against 80 mm caliber high explosive round using rocket launchers and other type of artilleries, and the test was done in one of the army range, all the 3 ones. 900 mm thick or 1 meter thick wall was actually penetrated up to 700. This took 5 shots of the 80 mm caliber round, and then it was only able to penetrate out of 225 mm. So I forgot to mention, from 1 meter thickness wall we are able to reduce 225 mm, less than 1/4 of the thickness, and it was able to take 5 loads without any kind of visible damage. Damage was there, but it was not able to penetrate. This especially takes importance in the context of current scenario where we are looking at many of these what we call these loitering ammunition, where these cheap drones are used to target, and this is used as a final or the passive resistance against stationed personnel in those sensitive areas, which would serve to enhance our defensive and offensive capability both. So that solution I've already proven. Now we are going for a larger scale. Soon we are hoping that we would be actually doing another construction in another forward area. So we're looking forward to that.
Rai sahab, any suggestion, any comments?
For the second one? No, seismic is not a concern there. No, second one, which I just verbally said, I think protective structure against missile you're talking about. That one is against missile, drones and explosives. Yeah. Yeah, the first one we have tested on shake table to a smaller one. Now we want to increase the payload. We would soon be getting a 10-ton shake table in our institute only, which with the support of our colleague, I have fought hard for the last 7 years. So once we have that, we'll build a 10-ton specimen, a masonry structure, and then we'll testing full scale. Yeah, I know. I've been there many times. They don't have shaking table. They have very big, this is strong and floor and strong wall. They have tested 3-story building, prefabricated building. Yeah. Thank you.
So what is the standoff distance?
I'll share one use case because there was a topic around defense. So for defense, there are people in the room. So with BRO, when in the winter, when there is a snow, you can't differentiate between road and, the other areas, where is the valley and others. So with the Trimble, we have provided the technology to the BRO for a snow cutter on the dozer. So the dozer was knowing when it's removing the snow, that what line I am following with the precision positioning and the height, so that the dozer is not falling in the, in the valley. So that's one use case. We spoke to I think last week there was a conference around AEC forum where people from defense were there, and the BRO DG was also there. So the DG himself presented this use case.
So Manish, what is the standoff distance for that 80 mm caliber?
Sorry?
Standoff distance.
Standoff distance. This was to direct in contact. They were basically calibrated. So this 80 mm round that was fired, it was in contact, supposed to detonate when it hits that one. So these will have these rounds, 80 mm caliber or that other artillery that we use. At the tip, they will have this mechanical device that they will either target. So a delay fuse is there, or the contact fuse is there, or there are different. So this we did it on contact, which is the worst possible scenario. So it detonates as soon as it hits. So the impact and blast both actually combines to give you the maximum effect.
Great, congratulations.
Explosive weight was 3.2 kg inside it.
Good afternoon all. Myself Prasant Gajvi from ICOM. So since morning we have heard eminent speakers, and it was a very exciting, and it was a new learning for all of us to hear the opinions and new things about how we can build sustainable steam infrastructures. So I am not going to take much of time because there are other many presenters. So I will skip some of my slides. Yeah. So it is a only brief introduction of this. What are the sustainable infrastructure? So sustainability in civil infrastructure means designing, building and maintaining infrastructures in a way that meets current needs without compromising environmental, social, economic resources for future generations. So we have to look in means when any infrastructure becomes sustainable socially, when it serves all, not a group of not a particular group, when it enhances the livelihoods and well-beings of the communities. At the same time, it promotes gender equalities and there is no non-discrimination. Similarly, when a infrastructure project becomes economically sustainable, when there is when it is designed in such a way that there is no overburden on the government or of unpayable debts. Instead of that, it creates jobs and boosts the economy. So that's the way infrastructure can be called sustainable economically. In a similar way, when a structure we can call sustainable environmentally, when it limits the pollution and conserves the natural resources, right? So that is what about the basic idea about sustainability of the infrastructure, because social, economics and environment, these are the base of sustainability of any infrastructure. So how we can do that? So we can do that by preserving the resources, reuse of materials, energy efficiencies in improvements, longevity and flexibilities in the infrastructure, selection of innovative materials. So like we heard that there are developments for the artificial aggregates which are being developed in the development phase. So okay. No, so okay, that's fine.
Then I think we should clap for you.
We can go on the last this
Okay, thank you.
conclusions, last sheet. Yeah, you can proceed. Thank you all.
Thank you very much.
Good evening, everyone. I'm not sure which presentation we are going to put on.
Excuse me, sir. Sir, one thing I would like to highlight here.
Other one.
Yeah. So, So there is a competition today for L1 projects, for infrastructure projects. So, like sir said, that there should be a criteria of S1, that means whichever the project which is having most sustainability point of view, that should be considered as a L1, not in the only the point of cost. We should consider it as a viable. So there is some criteria. There should be some amendments so that we can consider projects like that. Yes, definitely. Correct, sir. Because last 2-3 months I read in news where in the Karnataka one contractor bid around 50% less than the cost of the project, and he got the project.
I think there's no point in saying unless. So as a company, AECOM, you send them the recommendation and let it be limited.
Right, sir. Right.
I think we are all facing this problem. Shavana, tell the story quick.
I have very less stories because it's a very shorter version of the presentation. I wanted to elaborate more by looking at it. What am I going to speak? I think everybody is aware about the geosynthetic product. So Strata Geosystem is all making geosynthetic product. Synthetic product is right now is being utilized extensively in infrastructures where the consumption of the natural resources are being reduced. How are we doing that? If I need to talk about sustainable construction material, role of geosynthetic products, reducing the natural aggregate, if we are having a graded granular material as a drainage filter media, and if we are replacing it with the geosynthetic material called drainage composite, we could use quite amount of natural resources, reduction in the carbon, time saving, resources saving, and quite a lot. All these products are already BIS standard specified. These are there in the Ministry of Road Transport Highway book. Indian Road Congress committees have formulated many guidelines regarding different kind of a geosynthetic to be utilized in infrastructure. With the help of propagating these products extensively on highways, on mining, on railways, water resources, we can achieve a quite amount of sustainable construction. We do have many calculations where for the different applications we do check out how the energy consumptions are when we are basically reducing the extensive number of trucks of aggregate with a simple roll of geosynthetic material. The transportation energy is getting saved. Apart from that, consumption of the resources as well as labors are getting saved. So we have many graphs, we have many calculations pertaining to that for all applications on infra projects. So this is something which I have just jotted down the pointer, like support ASG groups as well as and a green building certifications what we have in our factory for the product, CO2 emission and construction waste. If I'm just going back to the last slide of it, I have talked about something with the waste management also for the landfill. When right now we're talking about zero waste to landfill. But as per Swachh Bharat Mission 2.0, when we are collecting the waste, processing the waste and taking the waste to the final destination, what do we call as in landfill, there are always an inert waste which we need to dump it some or the other way, that we are dumping in a sanitary landfill. In the sanitary landfill itself, the role of geosynthetic product comes in a tremendously extensive way. We can use as an impermeable liner, we can use drainage composite for the graded granular material replacement. We can replace a 0.9 meter geosynthetic compacted clay liner with just in 5 mm compacted clay liner. So in this way, the waste management also, synthetic material have given a quite an extensive role, and it is being used from very long. I think from past 20 years we have been dealing, and I'm sure professors and everybody has been dealing these products long back than 20 years. This is the small submissions about geosynthetic product. Thank you so much.
Thank you very much for being very crisp and to the point. Bandyopadhyay sir, we have been hearing you since morning. So what is that new which you are going to show?
I have not prepared any formal presentation, but
then just speak it out in 1 minute.
Brainstorming point.
Just 1 minute, please speak it
So
out.
this is waste management. The concern is, take it to the second one. These are the various types of solid waste and sludge, and municipal solid waste is one area. Next one. Next one. Okay. The one concern is in India about 62 million ton is the solid waste generation, and out of which collection, CPCB is showing the collection is over 90%, but treatment is maximum 30%. This is the concern. So treatment in some of the European countries efficiency level is about 100%, if close to 100%. So the gap is too large for India to attaining the efficiency of the treatment level. Once treated, in case of plastics, I have a separate one. The plastics, one particular point is, in India, rigid plastics waste does not pose any concern to the environment or the authorities for the waste management part. All concerns are with the flexible plastics. The total plastics consumption is about 20 million ton, 22 million ton in India. Around 40% goes for packaging, 40 to 45% goes for packaging. And in that, bearing 10%, rest is flexible packaging. And this flexible packaging, in total, it comes to about 30% of the all plastic consumption. So this is posing problem because there is no value of collection. So, but plastics are 100% recyclable, 100%. Even thermoset plastics also are recoverable, energy is recoverable. But if it is not collected, then is a problem. So our concern is collection. This is one, this has to be overcome. And I wanted to show on this, the use of plastics in road construction. This has been established. Indian Road Congress has given elaborate standard also. But the implementation is problem. Although Government of India has given circular, but still it is not being implemented. I won't blame the PWD the sections. It is not available to them at the time when they required it. So that is the one particular concern. And quality of recycled plastics is due to the improper segregation. So this segregation has to be improved. So that is the main points. Thank you.
Iqbal. Yes, I know. Out of 36. No, it's actually important to hear to everybody. So now only thing is you have to cut short a bit, if you don't mind, but at least everybody should speak, yeah.
I think this is the time a dignitary should be here present and bear me for the moment, because these slides are very non-formal. And I would like to say to Professor Singh, बहुत नाइंसाफी है, लोगों ने गब्बर काइंड ऑफ प्रेजेंटेशन दिए हैं, and you have made me in one slide you can tell the world behind. So anyway,
नाइंसाफी नाइंजूर है, ना मंजूर है.
So the Goregaon, I'm being very particular to a project. It's not about the tunneling, it's not about the one project, it's about linking the project or development items with the concurrent technologies, which is very much required nowadays. And what are the lacunas that has been discussed since morning, right from the policy to the government and the implementation and evaluation system that being heard from all the dignitaries. And I would very much praise to a few of the participants who were very vocal, like sir, I don't know the name, but his question was very perpetual and he has initiated. And one friend from L&T and the Bhattacharya sir, he was totally into the trap of discussion like debates. So he bear all the time to all our questions. I'm very thank you. So I'm not here to praise this one particular projects, because many, many places these tunnelings are, ongoing in India. And as far as somebody raised the question that we should not target 125 years, we should target more than that. Some of the dignitaries inquired, some of the participants. I would say the 100 years is enough for any technology to get it obsoleted. Like in Europe nowadays, there was a tunneling before 70s or 60s. Now they are demolishing those tunnelings or underground structure, and they are facilitating, now they are going through tunneling. Earlier they have created all the infrastructure above the ground, right? Like superstructure. So I made some mistake, consider it. And here we have started in India. This is the first project which we are covering through the Griha 5-star tunnel rating. And the TBM technology, EPB, is the earth pressure balance or slurry, two kind of TBM is there. If there is a rock, we'll use EPB. If there is a clay, we'll use slurry. So these are the technology in fashion. 85% quieter than the conventional tunneling with real-time settlement analysis. These are the technical terms, but I would say understood by everyone. A transformation of infrastructure initiative, reducing travel time, cutting emissions and all. So the beauty of this tunneling, there is a up inflow of 210 meters to water reserves, which they are supporting the city facilities for meeting the requirements of drinking water, right from this side of the Mumbai and the other side of the Mumbai, Thane as well. And in this tunneling, we are creating one water pipeline for the future prospective use. Although we have the water pipeline facility exist by the BMC in Mumbai. So zero cutting, it means the cutting not in line with the SGNP area, because if you see the complete lining, the blue area is under the SGNP area. That's a 6.3 kilometers, because we have from the corners, we have escape our plan 6 meters ahead. Keep the slide one fast, sir. Back. Sorry. Yes, sir. Okay. So this blue line is our 6.3 kilometer radius, and the green line is our eco-sensitive area. In the phase 2 location, you can see the phase 3 is our tunnel area. Phase 4 is the exit area at the Mullen end. So and the phase 4 is around the rotatory. I want to see there is a TBM. It's largest tunnel dia road capacity. 14.2 is the final finish, and internal finish is about 13.1, I think. So the final structures move like this, because we have the covers of 160 that we have shown the bottom down there. There is one picture, so so you can see 160 is the maximum cover, so we can save this hydrological study. And these studies for carrying capacity of the SGNP and saving the hydrological infrastructure that exists naturally is being dealt with the studies and the expertise of IIT and BHNS altogether. So we are here not to facilitate the project development, but equally we are promoting the continual studies to find out what are the perspective, how we are going to deal with the carrying capacity of the SGNP, and what is the requirement of our communities around. So these studies are continuing. Next slide, please.
Iqbal, I'll help you. If you can throw more light on how to construct infrastructure in eco-sensitive, ecological regions.
Yes.
I think your experience in this context would be very useful for everybody.
Yes, sir.
Can you just speak it out for 1 or 2 minutes?
Yeah, for that we are
the type of clearances which are required and all those things.
Yeah, still we are hearing the sustainability, which comprises the ESG factor. All 3 frameworks are there. But the one part of the environmental framework is transformed into the wildlife protection framework, which is internationally recognized. And we are internationally pressurized to complete it, because it is not being dealt with the national, it is altogether being dealt with the international IUCN and all those factors. So if you are working very close to any forest regime, you have to take care of the current study of that area. What are the communities? If the communities does not exist on the paper, I mean, as per the Schedule 2 of the Forest Act 1980, if some communities are there, and there means as per the evaluation system of that law that says before 2005 that somebody should be present or their ancestors should be present since last 50 years. So if you can check the entire SGNP area, whatever the encroaches are there, they are actually encroaches, not they are the tribals. So the government policies and their benefit is to coincide. We have to correlate. So these are intra-political interruption can be, can be separated through early or pre-stage of, survey in the construction regime. And also, once we are completing this project, we are going to save the travel time. It is more than 50%. This time we are reaching in 1 hour from Goregaon to Thane. And on that time, when the tunnel will be facilitated, we are going to reach by 15 minutes or hardly in 10 minutes. The carbon reduction is one factor. More than 38,000 ton will save annually. And the emergency responses, because the IIT Professor Singh Saab, they have recommended we have the cross passage at every 300, or we are under the discussion to make it by 500. But as per the emergency requirement, preferences are between 300 to 500. Decongestions impact like 15 to 25% of the traffic reductions from western corridor to eastern corridor, because these are the connector point where we are connecting this tunneling facility to the VDCR facility, that Warsaw-Desel Coastal Road facilities. And as we talk about the wildlife protection framework, this is the India's first project which we have received 24/7 practices, because our TVM is equipped with the latest technologies. We are taking care of the project with the Industry 4.0, where we are going to inbuild all the AI system, all the embedded system for IoT, time-lapse camera, taking care of the community and studies. So this is how we are complying and advancing this infrastructure for the people here in Mumbai. So we are getting solar powered ventilation system, moreover 60% area, or the energy use reduction will be in terms we can calculate here. And the AI predictive wildlife conflict tools we are going to install in the project in nearby. Innovation and expansion is all related to AI tracking system for the wildlife protections, and also the facilitation of construction with the 5M barriers, like separating our work area for the coexistence of the working people and the inhabitants of the forest alignments. So these are the practices we are promoting. This is, you please do not think like there are many people. I would not say there are many companies who they are working the similar kind of fashion, but what they are doing, what we are doing is totally different. I commit here. And since morning I have heard everybody. I have one suggestions. I'm a little child if you want to add my suggestions. So I would say, sir, whatever the discussion happened, we are discussing on a zeroth level for recycling. If we talk about the R3, R7, R5 or R3, right, we are talking about the first item or the second item. And as far as our countries are concerned, I mean, especially the construction or development industries, they are running with a very obsolete technologies in India. So we need to advance first the standard of the industry for the participation. Don't think about who is going to win the L1 or L2. First, the company should standardize themselves with our certain regulatory parameters set out by the governments, that if some company is coming, they should have this kind of implication. 10% for the energy saving factor, 10% for the technology enablement. So this kind of principle should be there by the government, and that should be mandated. Nowadays, people got, any black money, they would become a contractor. They would come us.
Iqbal, it's over.
Thank you. My suggestion to you. Thank you. Sorry.
Okay, Meera and Jay, I think both of you should present together.
Very different topics.
Really? Make it one. Actually, we have to finish it off at 4:30 sharp.
Yeah. I'll just take
Meera.
1 or 2 minutes because a lot of the things are already discussed. So I am Meera Raghunandan. I am Associate Professor at IIT Bombay, and I wanted to use this opportunity to talk a little bit about life cycle cost assessment, which Mr. Hegde also talked about in the morning. So we have developed a framework here where we have a sustainability incorporated life cycle cost assessment. As these things have already been discussed related to why there is a need for including sustainability in our construction, and why there is a need to have sustainable development to meet our sustainable development goals where we are taking into account climate action, we are having a responsible construction, we are having sustainable cities and communities. And in order to have that, there are a few things we have to take care. We have to make sure whatever we are constructing, it is not just economic, it is sustainable as well, not just in terms of monetary values, but also in terms of the environmental impacts of it, the social impact of it. So if you could go to the next slide. What we have worked on is we have proposed a framework. It is called 3P-LCC framework. It integrates 3 pillars of sustainability in the life cycle cost assessment. So as was already discussed in the morning, life cycle cost is the cost incurred by a structure or a system during its service life, and it can be kind of broken down into 3 stages. One is the initial stage, then the use stage of the building, as well as the end of the life stage. And during these 3 stages, there are many costs that are incurred, and they can be put into 3 pillars of sustainability. One are like straightaway costs, economic costs. There are environmental costs, which are often quantified using carbon emissions or embodied energy. And then the social cost, which is injuries, casualties, which also becomes very important when it comes to natural disasters. So what this framework we attempted to do was, because often life cycle cost assessment is done either like a social life cycle cost assessment or life cycle assessment or life cycle cost assessment. So they are done in like 3 different parts for different pillars. So we try to integrate everything together. And also natural hazard related life cycle costs are normally not incorporated in this framework. They are normally investigated separately. So we try to bring everything together. And another thing which we felt was very important was everything is measured in same unit and it speaks to the stakeholder. Because often when we talk about environmental costs, people talk about, okay, what are the carbon emissions? Or when we talk about casualties during the lifetime of a structure, we talk about how many people are injured, how many people died. So we try to assign a monetary equivalent metric to each one of the components and add everything together. And what we get at the end is the total life cycle cost, which can be then used by different stakeholders depending on how they wish to use. So if you are a policymaker, you are more interested in, okay, what is the cost of, to the environment or the society due to the carbon emissions that are incurring due to initial construction or use stage or end of life stage. Or if you are a contractor, you are more interested in the monetary equivalent. The objective of this framework is to provide a tool which can help you take these decisions. There have been a lot of discussions today related to use of different types of material, different types of sustainable construction practices, different type of structural systems. So all of these can be assessed using a framework like this that integrates every aspect of sustainability and just not looks at the initial cost, but what is the impact of that during the service life of the structure. So next slide. So just to summarize it, what we wanted to do was this contains all pillars of sustainability. And the social cost of carbon that we have integrated for converting cost of environmental emissions. The good thing about that is in that you can also incorporate climate impact. So if you are having very bad climate practices, your social cost of carbon goes up. So again, all of these things, this framework has the flexibility to have, and you can use this for comparing structural system with different building materials, different types of construction practices, choosing between sustainable retrofit options. And I have also, I think these slides will be shared also. So I have also, if anyone wants to see more in detail, we do have a paper on the framework also which can be seen. And at the moment we are using this framework, expanding it to different applications because it has to be modified slightly depending on the application, and investigating, let's say, comparison between steel versus concrete buildings or bridges, and some of the work we are doing at the moment. So I hope, Professor Singh, I have summarized in a timely manner. Thank you.
Thank you very much. Jay, I think you are going to speak the same language.
there?
No slides, just
No?
introduce yourself and
Yeah,
speak
yeah,
for
that's
1 minute.
that's good enough. So I am Jay Ghosh. I am an associate professor in the civil department, and just picking up from what Meera was saying, my work related to sustainability, we are primarily looking at structures in the north and the northeast part of India, and trying to look at different types of retrofit devices and how it would bring down life cycle costs. So I think one thing which we or facilitates the today's discussion is that to not look at how things are happening today. For example, some of the discussions where that regarding that L1 bid, that why should it be only the lowest cost, it should take into account the sustainability metrics as well. So the work is primarily on that aspect. So what we are looking at over here, the slides are up, so I can just take you through that. So if you look at the top right figure, we are looking at a typical framed structure where you have a structure, you have the masonry, which is the bricks and the openings, and those diagonals that you see, BRB 1, 2 and 3, these are the retrofits that what we are looking at. We can go to the next slide. So please go ahead. I think, yeah, so we are using a very well established peer framework, which takes into account the hazard component, then the seismic response of the structure, then we do the evaluation of damage and how we all aggregate it together towards the estimation of losses. Can we go to the next one? Yeah, so this is the overall framework. So on the left side, we have the regional specific, the ground motions, which informs the hazard curve. And at the center, you see the four types of structure we are looking at. One is the bare frame, which essentially has no masonry and nothing at all. And typically all the cost analysis are done assuming that, while ignoring the effect of infills, and as well as we are trying to see that how implementing those retrofits, it helps to bring down the loss estimation, which is in the bottom right part. So in addition to the repair cost, we are also calculating a 50-year carbon dioxide emissions and embodied energy. And all these are actually being done for real existing structures which are out there. So this is not hypothetical. These are structures which are there. What can we do to the structures now? So whatever the remaining life it has, it will be beneficial for them and beneficial for the environment along them. Next slide, please. Yeah. So this shows some of the reductions of costs, carbon emissions, and embodied energy once we had implemented some of these retrofit strategies. And another thing which we are doing, as we know that right now we are sitting inside this building. So in addition to the structural components like the beams and the columns, you have many non-structural elements as well, right? So the focus has been like to take all the carbon emissions, embodied energy costs for the whole structure, and again bifurcating them into how much comes from the structural part, non-structural part, and so on. And typically for the non-structure, when we see a building damage, we see the whole building has damage and we go really crazy about it. But a lot of the cost of the structures actually comes from the non-structural parts than the structural components, all the claddings and everything that we put. Next slide, please. Yes, I won't go much into the details of this. This is exactly what I was saying, that if you see in the horizontal axis of the plot, that really tells that how much of the total costs, carbon dioxide emissions, and other sustainability metrics can be split into structural, non-structural components are drift sensitive, some can be acceleration sensitive, and the contents and the total. Next slide, please. Yeah, thanks a lot. Thank you. That's all my presentation.
Hi. It was an very interesting presentation. I'm impressed. One thing I like is that life cycle is taken into account, not only structural, because wherever we are taking life cycle one, we always taken only the main structure. The non-structural finishing and services are not taken because their lives are lower. Your electrical, your plumbing, your air conditioning is only the main structural element. We have a 100-year life or whatever, especially on building related. So if you're taking that,
yeah,
it's
sir.
good.
Yeah, I mean the cost are higher, and also I think the contribution to cost are a lot more higher than the structural part.
I'm interested, very interested.
Yeah, I'll be in touch with you, sir. Thank you.
And one last question, since you did Northeast, are you simulate for Zone 6 because all of them are shifting from Zone 5 to
No, right now we are at Zone 5, but that's the
2025 makes
yeah
all
Zone
those
6.
area,
Yeah.
JNK, Uttarakhand,
Right.
Sikkim, and Northeast from zone 5 to zone 6.
Right, right. So the framework is ready. So once that new
Yeah, you
code
can
kicks
simulate
in,
that.
yeah,
Okay.
thank you.
Hi, I'm Mirza Beg. I'm Research Technology Development Head of VH Group. We have developed, can you please slide it a bit? Second slide. I am not going to touch this slide at all because you have all been knowing since morning about the global plastics and all those things. We have developed an technology from 2011. We were working on a technology that could decompose the plastic as such. It is not incineration, it is not waste to energy wala project. It is something different. So I don't know whether I have a time to completely disclose the technology, but in order to make it short, what we get at the end is basically a decomposable material, and we have been able to make it its use in as fertilizer as well as in the construction domain. So we have, can you please skip one more slide? We have got its patents. Its patents has been granted various jurisdictions like USA, Canada, China, Japan, India, Saudi Arabia, and it's under prosecution in Oman, Australia, Europe, all the jurisdictions. And we have one beautiful thing over there with the catalyst which we are using. We have trade secret part 2 in it, so it can be applied globally later. Even if we get only for these 11 jurisdictions the IP patent rights, we could apply it to the whole jurisdictions to all over the world. So we have done its SWOT analysis and all those things. What currently the technologies are available in the current scenario in the world, it is completely different. It is the end product which is, it is ROHS compliant. It's we basically thermally bake the plastic with our catalyst. Yeah, and the beautiful thing is co-mingled plastic. We don't need to segregate, even if it contains the organic matter too. But for the sake of not to waste the catalyst comes with a price. So we don't want that organic part to be put with the plastic. We just need somewhat like that of an RDF material from the landfills. We are not hitting any recyclers over here. We just need the RDF material and we can convert it into the decomposable material. That decomposable material readily is inert material and can directly be used in the construction material. I would be showing it into the next slide how we have used it. And from that we can basically also, we have some trade secrets where we convert that inert material into somewhat like that of a fertilizer. It's soil enhancer. We have been tested. We have taken the Euro compliant certificates all over the labs in India as well as in Europe. We have tested it. So now, second slide, we have Kroll.
Has it been approved by CPCB?
No, sir, 1 minute. We have at a stage where we will be, from 2026, we will be basically deploying it. Before that, we would take the CPCB permissions and all those
How
things.
many years it takes for testing that it is toxicity level on?
We have been in the R&D for this particular product from
You have
2011.
tested, for the testing authority, usually biodegradable plastics, they take 2 years time for giving you the test results. So that, keeping in that mind, unless you get that approval from the government, you cannot use it.
Okay.
So you might have tested it
Yes.
in many countries, but for so far as India is concerned, Central Pollution Control Board has to give you the approval. And
Okay.
at present, the biodegradable plastics are available.
So
It is
what I
not-
suggest,
it is not-
what I suggest is to both of you,
Yes.
Mirza,
After
you please sit with Bandyopadhyay sir.
No. I'm just cautioning him.
Just a minute.
He say that he has tested. So from the government of India, testing also is required.
You please groom, groom him, because what he is trying to do is something very interesting. You please be in touch with Mr. Bandyopadhyay and then work together.
Okay, sir.
Because he's an expert in plastics.
No, not for that. I'm talking about the testing part of it. No?
You guide him.
So the Kroll, which is basically our technology evaluator, they have Kroll is from USA. They have evaluated it, and they have evaluated it for some.
My advice is just approach CPCB.
No problem, sir. We will be approaching.
Through him.
No, not.
And the job is created.
Just for
job
your
is to be
information,
done.
I am in the panel in the drafting of the biodegradable plastics approval committee.
Yeah.
So that's why I have some information which I've shared.
Sir, we have an MOU with NCL.
Talk one to one. Hello.
Yes,
What I'm suggesting.
we have an MOU with NCL where we tested it from last 5-6 years. Well, we will also come with you, no problem.
Yes.
Not
So I
We'll
think
take you
now,
on board, no problem.
you approach CPCB and get it for the benefit of your organization.
Okay, sir, please help him.
Yes.
Because this is a project which, he wants to shape up in a big way. So let's
this
give
is
a big hand to both of you.
Sir, 1 minute, only 1 minute. So the technology has been independently valued by Kroll, which is about 17.2 billion for the whole world jurisdictions. And we have back slide, please.
Okay, I
Back
have
wala,
to
sir, ek
ask a
minute
question.
We have made back wala slide, please. We have made, these are our machine models. One is on wheels model, which we are basically taking to, in September, we are taking it to Tungnath ji for the trial purposes, and where we will basically decompose the plastic over there because of its eco-fragile materials. Eco-fragile environment is over there, and the output, the exhaust is below detection limit everywhere.
What is the projected cost of this mobile item?
Oh, bhai, please discuss all this later.
It will.
But now,
Okay, 1 minute.
where
I have to clap for everybody.
there is no lunch now.
So one request, it's already 4:30. We were supposed to close the entire session at 4:30.
Okay.
If you are ready to stay here up to 5:15, then I have to tell the tea guys to wait until 45 minutes. Otherwise, the second option is, what I would request is that those who are remaining to present, they can just maybe introduce themselves, say a couple of words about themselves, and I think we can wind up in another 10 minutes.
That's better.
Choice is yours. Tea is ready. Snacks are ready. And the second choice is we can be here up to 5:30. That's not an issue.
We have to all catch the flight.
So if anyone have any question, they can take my email and just.
I will
send
pass
it
it on to everybody. Don't
Thank
worry.
you. Thank you.
So thank you very much. Charu, I think you have introduced yourself enough. Just say one word.
Maybe just if you can roll.
No. That we discussed just now.
No, because
Just you speak. Everybody knows.
sir, in bamboo, seeing is believing. So unless they see it, they won't believe it. So I won't speak anything. Rather, you
Only
can
show.
just
Okay, just
scroll it.
please. Charu. Promise you are not going to speak.
Unless somebody asks some question.
Just give him 1 minute.
Sure.
नहीं प्रॉमिस क्या करना है आप क्लैप कर देना
Sir, I sent you something on your WhatsApp.
अरे ये ठीक है चलो दिखा दो.
Okay. Well, so this is a bridge project.
He's doing excellent work actually. If you have time, please come and visit his lab.
Yeah.
And the center, bamboo
Not today,
center, which he
not
has
today.
created. Yes.
So this is a bridge project in Nandurbar where accessibility is a major issue, and there are nearly 400 such locations which get cut off during the monsoon for 3-4 months. So this is a bamboo arch with just 3 bamboos and 2 such arches, and it is able to take 2000 kg of load. And this kind of arches we are planning to prepare a bridge. It's a 6.5 meter span, and in each span, in order to cater to the Indian standard guidelines, there will be 8 such arches deployed. So it comes to around 8 ton of loading. Each arch is able to take 1 ton of load, and this is only for pedestrian traffic. The width is 1.8 meters only. Next slide, please. Next slide.
Very good work.
Excellent. So Pratyusha, please.
Just
Charu, it's over. We have clapped for you.
So just roll it over one
Like
side.
the counter.
Okay, second one, quick.
Yeah.
Slide is not
Yeah, so again, this is a bamboo cafe which we built and we demonstrated the carbon capture and storage in this, and it has offset the complete construction carbon. So over here, all beam, columns, slabs, and all structural members are with bamboo. Thank you.
Thank you. Pratyusha.
Devender,
Oh, yes.
I have to say one sentence here.
Oh, I'm sorry.
All
I
this,
have
no,
said
no, that's
something
okay.
wrong.
I'm Indrani Malkani. Good evening. Just wanted to, because you see, here is a technology experts from all over. And so many things since the morning we have been hearing, and waste, etc. Technology of every kind has been discussed ad nauseum over here. I'm sure a collective strength will enable the august body here to take forward a most crucial part by way of all of the good things that are being done by all of you into actual working. And that is to bring about an integration of the fragmented policies. Unless the policy framework is properly integrated, there is nothing that will actually sustain. I am not bringing in a word of pessimism, I am just bringing in a practical statement. We talked about waste management. Mr. Jain was here. He is quite an expert in waste. He is not here. As you all know, that different kinds of waste have got different sets of rules. Now, if that isn't confusion confounded, what is at the implementation level? I am a layman. I am a citizen's voice over here. End of the day, each one of you, ladies and gentlemen, are citizens of this country. So each one of us have a duty towards making things possible to happen. Technology you will all have, but that technology is not transferred. I mean, it is happening in silos, but will the silos bring about a cohesive working? Your Brihan Mumbai Municipal Corporation is a prime example. We talked about waste. And we can talk about the whole day, you can have as many conclaves. End of the day, civil society has a huge duty if any of these sustainable practices are to actually take shape in the right scale up as you are be all talking. So on that note, I would appeal to all of you, in your own ways, please make it possible for all the policies to get integrated, especially when you talk about standards, you're talking about CPW. I know about all the rules, and all these rules, the administration, the authorities, each are working in silos. And who is left confused? No wonder there is no segregation. That is the very first start of any waste management. On that note, ladies and gentlemen, thank you for giving me this opportunity to share my thoughts.
You grabbed it.
Maybe just you can introduce yourself, and that's good enough, or you want to say some few words?
Yeah. So I'm Dr. Pratyusha from IIT Andhra Pradesh.
Yeah.
Adding on to all the points that have been discussed from morning about the policy making and all. So once policy making is done in this era of things where everything is available on mobile through apps, you can order food, groceries, etc. The proximity analysis of all the materials which we are saying would be the sustainable materials should be available through an app to the end users who are the contractors. We have actually started, like we have worked on BTech level project where they have developed a basic app where they have made the agricultural based materials available in few states of India. So this can be generalized and made it available for the entire nation so that the stakeholders will be benefited. So they will know when to use, or for the location where they are working on, like in highways, they know what material is available to them. This will be beneficial both for the contractors or NHAI as well as the farmers who are actually creating these byproducts. And the other problem which I have identified in our location is abandonment of dump sites. So they are clearing the waste and they are just converting them into construction layouts. So this is what is not acceptable in terms of all the geo-environmental pollution they do. So rejuvenation and reclamation or remediation of such sites are very much required. I think this is not a problem persistent only in Andhra Pradesh. I think it's there all over the nation. So these are to be taken up very soon or as a part of the policy making or implementation. Thank you.
SRM University, Andhra Pradesh. So I will not take much time, only going to discuss about what could be this possible solution. As since morning we are discussing about the recycling 4R system, which start from refuse to recycling. So the last part which we are having it, discussing about what kind of materials can be recycled and how it can be. So my focus area on e-waste management as well as in plastic waste. So what we have done, we have taken the battery, which is a very, very common thing, what we can do after completing its life cycle. So the battery material, which is very critical because it is containing critical and rare earth metals. So this is a lithium ion battery, which is having a precious metal, critical metals. So what we did, we have done the recycling and following the rule of circular economy and life cycle assessment, we have completed this and identifying what kind of material can be recovered. So the all critical metal, nickel, cobalt, as well as lithium, manganese, along with the graphite can be recovered, and we have refabricated this to manufacturing the new battery material. And we have identified when we are going with the virgin material, which is coming out from natural resources, and when we are recycling it, the cost is reducing as well as the impact is also getting reduced. Next slide. The another work what we are having it with the plastic, though everyone is talking about the plastic, how to manage it, and it comes with the different type of recycling tools, primary to the quaternary. When we talk about the RDF, it is going to be the last option when we are not able to recycle as well as not able to degrade this material. So when we talk about plastic, it is recyclable if we are able to know how to discard this waste. And another problem what we are having, if it is getting contaminated, we cannot do the degradation process as well as we cannot recycle it. Then the last option will be the RDF only. So here we have done the degradation of the plastic which cannot be recyclable, and then we have identified the degraded, it is going to be intermediate product for the manufacturing the new product which can be having a worth. So this degradation has been done, partial degradation has given the component which can be utilized in the fertilizer as well as in the pharma industries. So this here I am concluding it, and thank you so much for the opportunity.
Dr. Sushmita, please.
Hello everyone, I am Dr. Sushmita Sharma from IIT Meghalaya. So what I want to bring over here is the regarding constructional demolition waste. So recently we have studied this topic, so where we have identified Meghalaya and we have converted it into 3 hotspots, major regions where construction demolition waste can be generated. So what we have interestingly found out that looking into the TFAC from 2001 to BMPC 2018-21, we have found out that there has been highly inconsistent values in regards to finding out the total amount of the waste generated throughout the country. So this is one area which was one of the motivation why we started up with the work. And secondly, although policies and practices are still in practice in most of the municipalities, but the implementation is a bigger problem. So this is where actually I wanted to highlight 4 points. That is, first is infrastructural deficits which exist in Meghalaya. So lack of the processing plant and no specified designated dump site is there. The second point is the policy and regulation which exist but proper implementation is not there. Then awareness of and the technology barrier. The local urban bodies are not aware of what is constructional demolition waste and how it can be taken care of. So with this into practice, we found out and we have used a methodology to find out the total amount of the waste that is being generated. So we had found out that Meghalaya on its own generates around 75.6 kgs per capita per year. But the problem is we are finding difficulties in validating it in the field scale because no such kind of report is available there. So this is where I would request if anybody would like to help me in this regard to create a policy framework for Meghalaya. Thank you.
Madhu, please. Madhu. Oh, yeah. You can just speak about yourself and your work. Oh, that's good enough. Yeah, yeah. It's there already. It's there.
You can show that picture.
Okay, yeah. Show the picture. Oh, you should go to Dahisar also. Dahisar is much more operational. Yeah. Yes, please, Madhu.
Yeah, good evening. I am Madhu Ganesh. I am showing here a 2 tons per day rotary kiln based gasification plant. This was funded by the Department of Science and Technology as a technology demonstration project for stakeholders to come and see that such a technology is possible. As per DST, as per the MOEF, for up to around 500 tons per day, gasification is the preferred technology for converting plastic to energy or any waste to energy, and above 500 tons they are recommending incineration. This is a working plant, and if any of you want to know further details, I am looking for partnerships to spread this technology across the country, so we could discuss this offline. Thank you.
Thank you.
This is operative at which place? This plant is operative where?
This plant is in Coimbatore.
Yeah.
So I think now, Professor Rao, you can introduce yourself. Archak, you can introduce yourself, please. Archak, just introduce yourself. What happened?
Good evening, everyone. My name is Archak Mittal. I am an assistant professor at Civil Department of IIT Bombay. So I work in the field of intelligent transportation system. So here I'm heading a team of more than 200 students, which is a combination of PhDs, postdocs, masters and BTechs. So here we are trying to establish an entire ecosystem where we can develop a concept to a deployable products. So we are starting from a concept to theoretical models, then testing them in simulation models, very realistic simulators, and then working on a small scale prototypes where technologies can be developed, tested, and can be copy pasted to a real vehicles, real infrastructure, real IoT devices that are going in the field. So with that, if anyone is interested or have more questions, feel free to contact me. Again, my name is Archak Mittal, assistant professor at IIT Bombay. Thank you.
Rao sir.
Good evening to all. My name is Hanumantra. I'm an associate professor in the Department of Civil Engineering, that is School of Infrastructure at IIT Bhubaneswar. I'm working in the area of valorization of the tailings and industrial byproducts. In this regard, we recently, especially I came here to share the information on development of an artificial sand using the two material, or we can say linear economy model or circular economy model. We have developed artificial sand in the particle size range of 4.75 millimeter to 75 microns. First, using the ash alone by the process called as a geopolymerization together with the pelletization. Then we also extended the same thing because when I use the ash alone, we require some kind of the elevated curing temperature. So to overcome that one, then we refined the technology by introducing the another material, that is a slag. There also we could able to successfully do it, and in the second case we did it at ambient temperature. No additional energy is required. In fact, we filed for the patents of these products. For one patent we got the comments after 1.5 years. Second one we are waiting for the comments, and we have also submitted this project to Ministry of Mines. Unfortunately, they transferred it to Ministry of Coal, but the Works Department of Government of Odisha, they came forward to go for the pilot scale, because in the laboratory scale we successfully completed at TRL4. Everything has been validated at the laboratory scale. Now we are looking for the pilot scale project, where we are looking for 2 to 5 ton production of sand per day on the pilot scale basis. Once it is done, the technology can be transferred to MSME, all MSMEs or whosoever are interested. So collaborations are most welcome from my side.
Thank you.
Thank you.
Professor Vibhuti.
Good evening, guys. So it's already
This is the problem with the artificial intelligence.
Yeah.
The system knew that the session gets over at 4:30. You must have noticed. And so it's logged.
And everybody tired.
Now you can't retrieve it.
So myself, Dr.
Electronic board is logged.
Yeah.
4:30.
That is AI.
Yeah. Look at this. Okay, yes, please.
Yes, so I will, by just 30 seconds, okay, I will take. I am a professor at National Institute of Technology, Karnataka, Surathkal. So I am a alumni of Environmental Geotechnology Lab, but my work is into the concrete actually. So over the time I developed very few things, like one is more specific is a climate resilient concrete, where we talked about beyond sustainability. So this project was with a collaboration with University of Leeds. And for this project, actually, I also was felicitated by the British High Commissioner of UK in New Delhi last year. Actually, this is one of the specialized award I got actually. So what we work actually is sustainability through using the local available materials. So that is the primary actually goal. So many things we use nanotechnology, we use geopolymer technology, we use even we have now come into the concrete as a potential carbon dioxide storage material. And last is, I think we talked about here is the 3D concrete painting. I think we can achieve sustainability in a larger way through 3D concrete painting actually. So we also are doing that actually. So with this, thank you so much.
Thank you very much. Apurva, I'm sorry, but
hello, this is Anubhav Saxena. I am leading the ESG and sustainability initiatives for K. Raheja Corp. We are into commercial development, hospitality development, retails, and residential development. For a commercial portfolio, we have a development approximately 60 million square feet development. And actually in the presentation, we have a case study for the 30 million square feet, especially related to waste intensity. What kind of construction waste we are generating, and the number is coming around the 40 kg per square meter that we generate the construction waste. Operational waste intensity number is 1.654 per square meter in a year that we generate the operational waste. And the third one is the demolition waste, which is coming approximately 400 kg per square meter. Apart from this intensity number, which like to also discuss on the construction and waste management law, which had recently been introduced in 2025. And once, so after this law, there's a lot of debate is happening across our construction site where to get these registered vendors. And once we are discussing with these registered vendors, we are come to know that a lot of other challenges are there. That one, that there are dominant recyclers are there in local market. We don't allow the other recyclers to come into that market. And then the transportation cost also plays an important role. A lot of time these C&D plants are outside the city limits, and so the transportation cost is increases. Sometimes the waste is not generating that much amount that they can collect it in one stretch. So all this type of practical challenges that we are facing at the site level. And the major problem is right now with respect to that government is introduced EPR certificate. Now the transparency about this EPR certificate, how to get this EPR certificate, recyclers, and everyone is looking little confused that all these questions that are coming from the contractor side. Okay, how can we do all those things? So this all the challenges are that we are facing right now as for construction waste management.
Thank you very much, and thank you for taking I'm sorry, as I said, it's already got logged electronically, and they are trying their best to reveal it. Thank you so much.
So one question, can we take one question?
No.
A small question.
AI says it's over session. Professor Singh, please.
Me to part of the rapid fire. I am also part of the rapid fire. Okay. That's right. Well, everything has been spoken during this forenoon session as well as in the rapid fire session. So I don't have to say all this again. But I repeat one thing, that Mr. Bhomik said that don't build. or build less or build minimum. But our lady from Meghalaya is saying infrastructure deficiency. So how do you overcome that? Because there is development required in certain areas and infrastructure will have to be built. So that has to be done sustainably. That's what is the message.
But Professor Sikdar, I think you should realize that, see, there should be some non-rehabilitable area notified in the country. Look at what's happening in Uttarakhand.
Yeah, Uttarakhand, yes, yes.
I think we should learn from that.
No,
Why
it is
Meghalaya should be rehabilitated?
Why buildings or the marketplace was there in the delta of that small river? And that has been washed away.
Correct.
So obviously this development control is not there. Just like the policy is not there from the government, development control is not there from the local authorities, as a result of which all these disasters are taking place. Yeah. That's right. And to minimize this carbon and all, what has been talked about, the modern concepts and technologies, what our friend was telling from Trimble, that there is BEAM, AI, ML coordination, the whole lot of predictive analysis is there in the construction industry itself. Using that, we can minimize the losses or any kind of carbon emission, etc. Now, also, environmental product declaration, etc. is there, but most of these are becoming voluntary at the moment. Mostly, all these things, what is happening in sustainability in our country are either private initiative or voluntary initiative. The government's directed policy and kind of regulatory requirement is still missing. That's what is to be promoted, and then only we'll be able to achieve probably the sustainability the way we want. But question is, very interestingly, it is seen in the entire group that there is, all the stakeholders are vibrant. They are, very enthusiastic to take up things the way it is required for sustainability. Every industry or small scale industry or the startup, everybody is trying for that. Now, sorry? Yeah, that's right. So what I mean to say is that most importantly, what our Director CBRI, Professor Pradeep Kumar mentioned, that we need kind of policy to be taken up with the commitment for our targets, Panchamrit targets, 5 things. 2 of those are actually the energy related, 2 of them are related to carbon, and the last one is, of course, 2070, net zero. So most importantly, fiscal reforms, preferential bidding, he suggested don't go for L1, go for S1, sustainability best sustainability you take. Then regulatory certification needs, and then of course financial engineering, insurance, etc. are required. Now these only will take us to the realization of kind of sustainability, and that way we can think we can have a safe journey to the next century. Thank you.
Can I just make a comment? You see, at certain point of time, there was an issue with the prefabricated system. Because of the lack of policy, prefabricated items used to be equated as the product. And as a result, people were not able to, implement it because of the cost effectiveness. But over a period of time, people pressurized. Now it has come to that people are able to implement it. I think time has come where we need to put a thrust saying that sustainability issues are of concern. It must be implemented, and we have no other go. And otherwise, all talks will be confined within these 4 walls. Nothing will go outside this.
Yeah,
that's what is important.
Yeah, it has to be done with deliberate policy, like GST advantage is to be given for sustainable materials. Whole lot of taxation issues, what has been talked about by Pradeep Kumar. All these are required. Without that, we can't go forward, because there is extra cost, and there has to be mandatory kind of bidding where life cycle cost will be considered with the design and not only the initial cost, and that will make the advantage, and it will show the advantage, and we can proceed. Thank you.
I will start after Dr. Singh claps for everyone now. So suffices for me to thank Dr. Singh and of course IIT Bombay for I would say hosting all of us, and the kind of control which Dr. Singh exercised. Thank you so much. Thank you so much. On behalf of INAE, I want to go on record that the first technology conclave that we did was, must say, a learning for me. And lots of things obviously need to be done, although our forum has done a lot of work. But what I was hearing from Professor Prem Krishna right sitting next was that lots of additions which we obviously will take away from today, and of course concise version will then be ready. Thank you so much. So you want to say something?
Who will first stand up?
After hearing all these, very nice and august talks on sustainability, the one question comes to my mind: there should be a debate on development versus sustainable development. Development means more consumption, economy going up, everybody happy in seeing 7.8% or something of GDP economic growth. The moment you start doing it sustainable, your 7.8% will come down to maybe 4%. Is the country ready for that? The country has to be ready for that, the country leadership has to be ready for that, and we cannot suddenly overnight by 2030 become the third largest economy in the world. So these are the bitter pill we have to also swallow while taking on sustainability. This is my, what I wanted to do.
Rise up, your turn, please.
Somebody, yeah, can I?
Yeah, please, sorry.
I'll just join Patil Saab in thanking Professor D.N. Singh for all the efforts that he has done. No, really, you've been, you and your team, of course, your leadership, and the way you have run the session today, been wonderfully done. So I want to join him in thanking you. I think on our expectations as members of the forum have been duly met. We have picked up number of new directions, and appropriately we will incorporate these in our report. And I think also it seems to me that after this volume that we produce, this document, we will have to probably think of a secondary one, a supplementary one, which takes up other issues which we are not covering at this time. So that also will be required. And without starting a debate, I want to say that, wherever we are recommending stop this or don't do this and so on, I think we have to use the word optimize in some way. I think we have to come in between the situation that we are in and the situation that we want. We cannot by a sharp curve, change things. So I think we'll look at these material that we are producing and come in between somewhere which it is more pragmatic, more possible. So I think we'll do that. So thanks a lot. I thank my colleagues who made presentations, and thank you all.
Of course, sir, President INAE is here, and of course thanks have been given. But on behalf of INAE, formally as Secretariat, we thank you and your team who have been behind the scenes working very diligently to put all this event together. In these confined walls, it looks a small effort, but I know what you see is the tip of the iceberg. Secondly, my request is to the esteemed delegates here to visit INAE website and visit it personally sometime. We are at Technology Bhavan, co-located with the Department of Science and Technology,
and do look for opportunities to engage with us either as a fellow, as a young associate, or as a member. Thank you and Jai Hind.
Mr. Atul, you like to say a few words? Just final word.
I'm extremely delighted to be here with the August gathering, and I feel that whatever we have finally shortlisted should be fructified into some meaningful output, and that's how we should take on this kind of a effort, and all the policies which we want to that government should enforce, we should give guidelines to in that direction. Thank you, as sir brought out, that please do visit the INAE website and try to engage with INAE as far as possible depending on your interest. Thank you.
Yeah, officially you can, President can declare. Mr. President, please.
Okay, I've been told to give the final clap.